Look, I know I said that boot dev had capitulated when we released the JavaScript course, but it was actually all a ruse. The only reason we released a JavaScript course in the first place was so that we could release this TypeScript course. My friendship with JavaScript has ended, and now TypeScript is my best friend. Look, you can't learn TypeScript without first understanding JavaScript. So if you know nothing about JavaScript, go back and check out that course we just released. TypeScript is really just a bunch of additional strictly typed features built on top of JavaScript. And for those of us that love the safety that static typing offers, well, we mostly just write TypeScript now. Anyways, we've partnered with one of the most talented TypeScript creators on YouTube, Web Dev Simplified, to bring you this complete TypeScript course walkthrough, all for free. TypeScript has been growing like crazy in popularity over the last few years. So we convinced him to record this giant course walkthrough to be really the last TypeScript course that you're ever gonna need. We've even spent months animating some of the harder to understand parts so that if you're a visual learner like me, everything will make a lot more sense. Now, this course does assume that you understand JavaScript basics. So again, if you don't, we already have a course on that. But in this video, Web Dev Simplified is gonna walk you through types, functions, and unions, all the simple primitives that you need to get started with the syntax. Then he'll cover more advanced types and collections like arrays, objects, tuples, intersections, and classes. Then he'll walk you through interfaces and enums, and specifically when you should use them over similar features like object types and unions. Then he'll talk about type narrowing, which is basically just
TypeScript is able to be smart enough to know what your type is as you start to narrow it down based on different things.
Then he'll go into some pretty advanced stuff that you can do with TypeScript, the kind of stuff that you mostly only see in library code. I'm talking about stuff like utility types, generics, and conditional types. And then last but not least, he'll talk about local development in TypeScript, things like the TypeScript compiler and tsconfig file. Look, if you've never written TypeScript before, this will be a very thorough introduction to the language for you. And if you have written TypeScript before, I can almost guarantee that you're gonna learn a lot about the language and its fundamentals that until now have probably just felt a little bit magical. But before we jump into the content, it's important to note that this course on boot.dev and the walkthrough video you're watching are totally free. So go to boot.dev and create a free account. You can follow along as you watch. If you just sit back and watch without actually doing anything and typing code yourself, you're not gonna learn anything. Now, while all the text and video content in this course and like all the other courses on boot dev are free, the interactivity of the site itself, things like lesson submissions, progress tracking, chats with boots, and certificates of completion, that comes with a membership. And if you use Web Dev Simplified's code, Web Dev Simplified, you'll get 25% off your first year if you're on an annual plan. And you'll also be directly supporting him and his channel. And he's an incredible instructor. I'm super glad that we were able to convince him to help out with this video. Okay, now we're just about to start chapter 1, but before we do, I gotta tell you, I actually lied about this video being free. The cost is very simple. To watch this video course, just like the video and subscribe to the channel. It's a very small price, and it is just an honor system. I have no way of knowing if you actually do it, but it does help us to be able to continue to produce these high quality video walkthroughs, so really, thank you in advance. Now, time to talk about TypeScript.
Welcome to your journey into learning TypeScript. I'm super excited to be helping you out on this journey because TypeScript is honestly one of my favorite things that I learned. I learned JavaScript and it was great when I was using it, but I didn't realize how much better TypeScript was until I finally started using it and learning it, and I realized it not only made me a faster developer, it made it easier to change my code, and it made it more enjoyable to write my code, which is honestly the most important of all of them. So to get started into this course, we're just going to dive right into the very first lesson, which is just the basics of learning TypeScript. And this just kind of explains overall what TypeScript is. And really, TypeScript is just a superset of JavaScript. That just means that it includes all the same stuff that JavaScript includes. It just adds some fancy stuff on top of it. And if we look at the code on the right-hand side of our screen, we can see it looks like normal JavaScript, except for there's this one tiny section right here, which allows us to add types to our code. And that's the whole idea behind TypeScript. Essentially, we're taking normal JavaScript code, which is what this is, and we're adding in types to that code to help our code understand what different things should be. This means if we try to, for example, assign a number to this variable, it's going to immediately give us an error because, as you can see, we're assigning a number to something that should be a string. So this gives us a ton of different information on the types inside of our code. It gives us errors if things are wrong, and it makes writing your code easier because now I can immediately see this error instead of having to run my code and waiting for that error to show up. So to solve this lesson, it's really just a placeholder to kind of tell us what TypeScript is. And the important thing is that TypeScript is a static type checking language. It doesn't actually do anything at runtime. What that means is when you write your code like this, you can see I'm getting an error in my code because I'm assigning a number to a type of string. But when I go to run my code in the browser only understands JavaScript. It doesn't know what TypeScript is. So what TypeScript does behind the scenes is whenever you try to compile your code down to JavaScript, it'll take all your TypeScript code and it'll essentially remove all the types from it. It might do some other advanced stuff, but for the most part, it just takes all the type related code and removes it. So even if I write invalid TypeScript code, if I actually compile that down to JavaScript, it will still run inside the browser as this type of JavaScript. So TypeScript is purely there for when you're actually developing your code to help you figure out what different things should be, but it doesn't actually exist when you run your code inside of a browser. So let's go ahead and solve this lesson. All we need to do is just print out this string. So we can just come in here, change this to this particular screen. And now if we click on submit, we should see that it runs our code and you can see the output down here. Now let's move on to the next lesson here. And you can see this lesson is talking about all the different basic types that we're dealing with. This actually piggybacks a little bit on what I talked about in the last lesson because they're specifically talking about how you have different types. You can see here that this is the TypeScript code that we had in the last lesson, and the JavaScript equivalent just removes the type specifically from it. And you can type various different things. For example, all the different primitive types, for example, string, number, boolean, null, undefined, and all the other things such as like dates and so on are all built into TypeScript so you can deal with them. And you can see, just like I mentioned in the last lesson, if you mistype something in TypeScript, it will give you an error, which is really important. So here, all we need to do is just change the type of this from a number to a string. There we go. And that should fix up that error. And now if we click submit, you can see everything is running properly. Now this lesson is where we really dive into my favorite part of TypeScript, and that is the idea of type inference. One of the things you may have noticed from the last couple lessons is that when we're writing out our types, we have to add this big extra section for what the type is. And if we have a lot of variables in our code, this is a lot of extra text that we need to type. We need to make sure it's correct. If we, for example, pass a number, we need to make sure we type it as a number. It's just a lot of extra overhead. And you're probably thinking, well, this TypeScript thing kind of seems sucky. But the really nice thing is that TypeScript is actually super, super smart. So instead of you having to explicitly tell it what your type is, it can almost always, I would say 95 to 99% of the time, automatically assume the correct type for your variable. So in our case here, we're passing a string to this support AI logs. So what we can do is we can just leave off the type completely, write it as if it was normal JavaScript code. This is the same in JavaScript and TypeScript. And now TypeScript is smart enough to know that this support AI logs is a string because we pass it a string-based value. And this doesn't just work with strings and numbers and so on. It is able to infer pretty much every type that you can throw it. There are very few instances where you actually need to explicitly write types in your code. And like I said, 95 to 99% of the time when I'm writing code in TypeScript, I just let it infer what the correct type is, and that makes writing my code way easier, but I still get all the amazing benefits of TypeScript. And if we submit, we should still see that this works.
Not everyone in the world loves TypeScript. DHH, the creator of Ruby on Rails, famously declared that he's done with TypeScript and prefers to work in the dynamically typed world of JavaScript. Which, to be honest, sounds about right if you like Ruby, a famously dynamic language. Now, I love TypeScript personally, at least I like it more than JavaScript, and I've been using it over JavaScript almost any time I have that choice to make. Let's talk about why it exists in the first place, and then what exactly TypeScript is, because it's not your typical programming language. The big picture why is simple. JavaScript is dynamic and loosely typed. When you write plain old JavaScript code, you get hardly any in-editor tooling to go along with it. Your functions don't have parameter types or return types, and objects that you pass around don't have a designated structure to them. If you have a function that's supposed to return a number, but you accidentally return a string, there's no tooling that's going to tell you about your mistake. Most likely, you'll deploy those types of bugs to production, and you'll only notice the problem when users start sending you angry support emails telling you your site is broken. The creators of TypeScript were developers at Microsoft. Many of them had C# experience. Now, C# is a statically typed language, and these developers were sick of dealing with dynamically typed JavaScript all the time. So they decided to build a language with types that would compile down to JavaScript, because JavaScript's really the only language that runs in the browser, at least if you forget about WebAssembly. So they made TypeScript as a superset of JavaScript, which means all JavaScript code is actually valid TypeScript code. The difference is that in TypeScript, you can optionally add more syntax to provide stricter and stricter type information to the compiler. The more and better the type information you provide, the more powerful your editor's tooling becomes, and the more powerful the TypeScript compiler's checks become. And at its core, TypeScript's compilation isn't about speed. Sometimes it's tempting to think, oh, compiled language means fast. But that's not really what we're talking about here. TypeScript's compiler, TSC, is all about correctness. It's about the ability to ensure all the types in your code base are correct and eliminate type bugs before you even run your code. I think it's fair to think about TypeScript as less of a traditional programming language and more as an advanced linter for JavaScript.
Now, I've already talked a little bit about why you may want to use TypeScript over JavaScript, and this lesson kind of reinforces some of them. And the big one that I really want to catch on is, first of all, it'll help you catch bugs because of different type-related errors. That's like the basic thing most people think of when they think of TypeScript, but that is, in my opinion, the least important of all the features that TypeScript gives you. In my opinion, the biggest feature that TypeScript gives you is the ability to refactor your code much easier. So when you have a large code base and you have a function that is used in hundreds of different files across your code base, and now you want to change that function to take a new variable or take one less variable as a parameter. To change that in TypeScript is easy. You change it in one place and it'll give you errors everywhere in your code that you have that function because now it's different. But in JavaScript, if you change that function, it just changes and you don't get any errors in your code until you run it, and then you get these errors. And most of the time, if you don't have a perfect test suite, which nobody does, these errors are going to make it into production. Then you're going to get angry emails from users, and that's definitely not what you want. So in my opinion, the real benefit of TypeScript is not the type stuff that it gives you, but the fact that it makes refactoring and modifying your code much easier. Also, you get really good what's called IntelliSense. Essentially, you get really good autocomplete. So when you're writing your code, it makes it much easier to write because now you can autocomplete pretty much everything. So you have to write way less code when you're actually typing out your code. Now, to complete this lesson, we pretty much need to answer a question I already talked about at the very first lesson, and that is all TypeScript code valid JavaScript code? And we actually know that that is not true. We know that all JavaScript code is valid TypeScript code because TypeScript without types is just JavaScript. So we know that that works fine. But since TypeScript adds all these extra things on top, it is not actually valid JavaScript code. And if you try to run your TypeScript code without compiling it down, it will not work. So we can come in here and say false, and we can move on to the next lesson. Now, I've touched on this a little bit in that TypeScript compiles down to JavaScript, but to really understand what that means, essentially what we're doing is we're taking our TypeScript code that looks like this, and we're converting this into code that will actually run inside of the browser. And as we know, the browser only works with JavaScript code. So TypeScript will go through and modify your code by removing all your type-related stuff, as well as doing a few other small things that need to be done in order to take your code and actually make it work inside of the browser. To do this, they use a tool called TSC. That just stands for the TypeScript compiler. And that's just a tool that is written by the TypeScript team to take your TypeScript code and convert it over to JavaScript code, so it'll work inside of all the modern browsers out there. Now, one really nice thing with TypeScript becoming more and more popular is that some of the backend tools such as Node.js are starting to add in native TypeScript support. So you can actually use TypeScript directly in Node with some experimental flags, and you don't have to worry about that compile step, which is really nice because when you actually start getting to the local development side of things, which we're going to do at the end of this course, there is a little bit of setup you need to do to work with TypeScript to compile it down to JavaScript. And the nice thing is with some of these tools starting to natively support it, we don't have to worry about that weird compile time step, and we can just write TypeScript and have it work just fine. Now, to show you what these types of errors looks like, I'm going to come in here, I'm going to click on submit, and you can see immediately we get an error, TSC, the TypeScript compiler. We're having an error that says type string is not assignable to type number because I'm trying to put a string inside of a number. Well, we can easily fix this by just coming in here. We'll convert this to a number. Now we click submit and you can see everything's working fine. Now, when it comes to TypeScript, one of the most controversial things is the inclusion of the any type. The any type inside of TypeScript is essentially a type that can literally be anything. It could be a string, a number, a boolean, and anything else that you could possibly think of, null, undefined, it doesn't matter. And that is to essentially represent how JavaScript would look at your code. In JavaScript, it has no idea what type your variables are, so it just always assumes any variable can be any type at any time. It doesn't know. So to be able to make sure that when you convert from a JavaScript file to a TypeScript file, which happens when you maybe are working on an older code base written in JavaScript and you want to migrate over to TypeScript, doing that can be difficult because you now need to fix the types across an entire massive project. So what they introduced is this any keyword. And the any keyword allows you to essentially override TypeScript and say, this can be anything, don't worry about it at all. And it just skips type checking entirely. It treats that variable as if it was just a normal JavaScript variable. It doesn't check types on anything. It doesn't check for it to be proper or anything like that. It just says, no matter what you do with this variable, it will not throw any errors and it'll work just fine. So for example, here I have this system prompt, which we have specifically typed as any. And even though that this is a string variable, I can come in here and I can do anything I want with it. For example, example, I can say that I want my system prompt dot, and I can just run some bogus function and I'm not going to get any errors because essentially TypeScript says this could be anything, so it maybe has a function with this name. I don't know. Now, I personally don't think you should use any when you're writing TypeScript code from scratch. Essentially, it allows you to jump out of the TypeScript compiler and it removes almost all confidence you have in the types in your code base. Because as soon as you implement one type with the type of any, all over your code base, anywhere that's used is going to trickle down, and it's pretty much going to infect your code base. And every place that you use this variable or function with that any type, it's going to remove your type safety. But the time that it is useful is maybe when you're converting from a JavaScript code base to a TypeScript code base. It is a great way to essentially sprinkle those any's in the particular places where maybe you have hard to write types that require major refactors. You can say, you know what, I'm going to deal with this later. I'm just going to put the any type in here for now, and we'll come back and fix this in a later refactor. Now in this particular section, we just need to fix the types of these. And the nice thing is with TypeScript inference, we can just come in here and delete that any keyword, and it's going to fix all of our types. It's going to automatically infer them. And now if we remove this bad code that we wrote, we can see everything is working just fine. And if I try to run this, we should see it's working. Now we're starting to move into functions, which is really where TypeScript becomes the most powerful in my opinion, because if you know the types of all the different variables of your function and the return type of your function, it makes working with those functions infinitely easier. You get great type safety and so much more. Now in this particular case, you can see we just have everything hard code typed as undefined, which is why we're getting tons of different errors. And in order to fix this particular problem, we need to specifically type what these different variables are. And this is pretty much the only case where you need to explicitly type the variables every single time you use them, because a function doesn't know what this price parameter is. It has no idea. So you need to explicitly tell it, hey, this price is going to be a number. Same thing with this quantity and this discount. These are all going to be numbers. So whenever you're creating the parameters or arguments of a function, you always need to make sure you explicitly say what the type of those are going to be, because otherwise TypeScript has no idea what those are. Now we can also come in here and explicitly type what the return of this function is going to be. And the way that you do that is after you have the parentheses of your function, you can see here we have the parentheses with all of our different parameter names. Directly after that, put your colon followed by whatever you want the type to be. So if I just come in here and I specify number, you can now see all the different errors inside of here have been completely removed because I've explicitly typed what my parameters are. So TypeScript knows all these things, for example, price, quantity, and discount are all numbers. And it knows when you do math on numbers, you still get a number, so everything's working fine. If I change this to a string, I'm going to get an error because it's trying to return a number and I'm expecting a string. So let's come in here, fix that as a number and run, and you can see everything's working.
This topic has been debated and debated over the last few years, and because I'm creating this course, I feel obligated to not only steelman both sides of the argument, but also weigh in with my own opinion. The argument? Should you allow TypeScript to infer your return types, like this? Or should we explicitly declare our return types like this? When I first saw this debate, I kind of defaulted to, well, explicit's better than implicit. I like seeing what my functions are meant to return right there in the code. But as I've seen more explanations and heard kind of the different sides of the arguments, my thoughts have become a bit more nuanced and I've landed somewhere in the middle. So let's break it down. First, the pros of explicit returns. Number one, you can see the author intended return type right in the code without needing to run any tooling. Now, I'll admit, basically everyone uses LSP and in-editor tooling these days, and honestly, if you don't, I don't even know why you're using TypeScript in the first place. So the bit about being in the code versus like shown on hover actually doesn't matter too much to me. But there is value in seeing, hey, this is what the person who wrote this function actually wanted to return. That way you know it's not an accident. Two, it stops you from screwing up your contracts. When you write a function, it's because you expect other parts of your code to use that function. If those parts expect your function to return this, but you started mucking around in the body of the function, and now it actually returns this, you've potentially broken all the places where the function's called. Had you explicitly said that you wanted to return the type that you wanted to, then your function body would have yelled at you as you were writing it and told you that you're returning the wrong thing. Okay, so now why might you want to use an inferred return type? Well, the big reason in favor of inferred or implicit return types is that they're always going to be more accurate and specifically more narrow. For example, you might have a function like this. It accepts a Boolean, and then, depending on what was passed in, returns one of two strings. The inferred type here is very specific. It's either hello admin or hello user. It's only one of those two specific string values. But if you explicitly typed the return as, say, something more generic like string, you'd actually be casting it to a wider type, and that more specific type information is now lost. To be fair, it's not actually wrong, it's just not as useful now. The other nice thing about inferred types is it's just straight up less typing. When you let TypeScript do the inferring for you, you don't have to write as much code, which is a benefit of its own. Okay, so here's my personal take. If I'm working on a function that I'm planning to export from the project, for example, I'm building a library, then I'll use an explicit return type. And that's because I never want to change my return type on the users of my library without being extremely intentional about it. Also, if I'm working on a very big or complex function with a lot of different places where it returns, and I want TypeScript to ensure that I never accidentally return a type that I didn't mean to return, I'll also use an explicit return. If I know I should only be returning, for example, one of 3 values, like status codes 200, 400, or 500, but there's a ton of crazy logic and maybe 10 different places my function returns, I see the value in using an explicit return to make sure I don't screw up my own function body. Now, to be fair, that is pretty rare, and in basically all other cases, I prefer to allow TypeScript to infer my return types for me. So to just be a bit more hand-wavy, if I'm writing a function that's only going to be used in my own code base, 99% of the time I'm using an inferred return type. If I'm writing a function that people outside my code base depend on, I'm using an explicit return type 99% of the time.
Now, one thing that's a little bit annoying is you notice we had to write a lot of explicit types in that last example, but in this one, we're actually going to get around writing the type for the return of our function. First of all, like I said, we always need to type the parameters. So we're going to come in here. These are both strings based on the prompt that we get. So this is going to be a string here, and we'll come into our user prompt, and we're going to make sure that there's a string as well. Now I'll just make this a little bit easier to see by expanding it. And now what we need to do is we need to combine these 2 different prompts together. Based on what it's telling us to do, all we need to come in here is just return these prompts combined together with a new line between them. So we're going to use some string concatenation, and we're going to say that we're going to have our system prompt followed by that new line character, followed by our user prompt, just like that. And if we just close that off, you'll notice we're actually not getting any errors, even though I didn't say what the return type of this function is. And that's because TypeScript is smart enough to infer your function return types. So it knows I'm taking 2 strings, combining them together into a new string, so this function returns a string. So it automatically knows that this combined prompts function, I look at the type up here, has a string as the return value. So this is a really powerful feature of TypeScript. And some people will say that you should not use inferred return types, and you should explicitly specify that this returns a string. But I honestly think this is not a good idea. There are very few advanced use cases where you need to explicitly say what the return type is to make TypeScript work properly. But in 99.9% of use cases, inferring the return type is going to be much better, because now if I change my function to, for example, return a number or return something else, TypeScript is going to be smart enough just to figure that out for me. It also makes sure that you don't accidentally have your return type be too wide. For example, if I explicitly type this as string or null, we're going to get later into this how we deal with nulls, but essentially I'm now saying this function can return a string or it could return null. And when I hover over here, you can see that that is my return type. But I'm actually only returning a string. I never actually return null. And now after that change, your explicit return type is slightly different than your actual return type, which could lead to problems in your code, which is why I pretty much always leave this just as an inferred return type. And anytime that I can infer things in TypeScript, I always try to do that. Now let's just give that code a quick run and we should see everything is working fine. Now we're already aware that inside of JavaScript, we have null and undefined, which both kind of represent having nothing. But in TypeScript, we have a third type that kind of gets lumped into the same category, and that is void. Void is specifically used just with functions to represent a function that has no return value at all. By default, if you have a function that doesn't return inside of JavaScript, it'll return undefined, which is a little bit unclear because is it actually returning undefined? For example, if you were to type in return undefined like this, or is it just returning nothing at all? So to be a little bit more explicit inside of TypeScript that you're not returning undefined, you're specifically returning nothing, they introduced the void keyword, which is used by functions that specifically return absolutely nothing at all from them. So in this case, we have a function that has no return at all from it, so we mark this as void to denote to the people that are using this function, hey, this doesn't return anything at all. But the nice thing is we can just implicitly do this as well. So if I remove this type that's hard coded onto here and I hover over log system, you can see it still has that void return type because we are returning nothing at all from this function. The nice thing about this void type is 90% of the time that you're writing in TypeScript, you probably never have to use it at all. There's very few use cases where you specifically need to use the void type, mostly when you're typing functions for other things, which we'll cover later in this course. But the important thing is just to understand that void exists. It is a type that is specifically there for functions that return nothing at all. Now in this particular case, we want to return the string from this function, so we're going to remove that console log, and instead we're just going to return that string back down to us. And now if I run that, you should see it submits successfully. Now in this lesson, we're going to start getting into some more advanced types by talking about the function type. Because if you have a variable inside of JavaScript that's set to a function, we know we can do that. For example, you can pass around functions as variables all over the place. It's one of the really cool things about JavaScript. But how exactly do we type that? You would think that you would just, paste down the function keyword as the type, but that doesn't give us any information on what parameters does this accept, what does it return, how does it work, is it asynchronous, all these different things. So that is why TypeScript actually introduced a way to type specific functions. And the way you do that is kind of like writing an arrow function. What you do is you take your parameters and you put them inside of parentheses just like you would inside of an arrow function, and you specify the name of the parameter followed by the type of that parameter, just like you were writing a normal function. And then you put the arrow just like you would in an arrow function, and instead of writing the definition for your function, the whole body on what happens, instead you just write what the return type is. And remember when I mentioned that void is sometimes something you need to do when defining function types? Well, this is that particular example. If you had a function that returned void, you would put void here as that return type. So a simple example of like a sum function, for example, it would take the parameter a and b, they're both numbers, and it's going to return to us a number. So as you can see down here, these two functions both match that signature that we defined up here. And you'll notice they have lots of similarities with an arrow function. You can see here is an arrow function that defines our code. We have our variables and we have the arrow, and then we have our return. Same thing here. We have our variables with their types, an arrow, and then whatever the return type is going to be. So to specifically answer this question, which of the following these represents the correct type for a function that takes a number and a Boolean and returns a number? Well, what we need to do is you can see here, this one says a is a number, b is a Boolean, and it has an arrow pointing towards that Boolean return type. In our case, we want a number return type, so we're going to use C down here. And the important thing is we need to specify the variable name and the type of the variable. That's why this top one doesn't work because it doesn't have variable names, and this bottom one doesn't work because it doesn't have type information. Now you may be realizing as we're going through this, certain things are quite long to type out. For example, function types are very long to type out, especially if you have a complicated function. So if you're passing a function to another function and that function takes another function, there's functions and functions and functions all over the place, you're gonna have a lot of really complicated TypeScript code saying what all these different types are going to be. And that's generally not something that you want to do. So we have this thing called the type alias that just allows us to create a type that is some other type, but with a new name. Think about it like a variable in JavaScript. If we have a variable that is a equals 2 plus 2, we now took 2 plus 2 and converted it to this variable a that contains that value for us, and we can use it anywhere we want. Type aliases are the same thing, but instead of a variable that stores a value, it is a variable that stores type information specifically to use with only TypeScript. These don't exist in JavaScript. In JavaScript, all this type alias stuff just gets completely removed, just like all the other types in TypeScript. So to create a type alias, you just use the type keyword followed by whatever name you want to do. And in TypeScript, it's generally best practice to use capital letters for your naming. So instead of a lowercase followed by a capital case, we have capital letters for every single word inside of our thing. And these type aliases can represent anything we want. So for example, I can come in here and I could say type name is equal to a string. And now I have a new variable called name that is always going to be equal to a string. In this case, it doesn't really make sense to do this because this is a very simple type. But if we have a complicated function, we could do this as well. Now, if we look at what we want to do for this, we essentially want to export a type called support response that returns to us a function that takes a name and returns a string. So we can call this type support response, make sure we export this, and this is going to be a function that takes in a name, which is a string, and it's going to return to us a string. So again, we have that variable name followed by the colon, and then the type for that variable, an arrow pointing to what our return type is, and then the actual value for our return type. So now we have this support response, and we need to make sure that greet customer and farewell customer conform to whatever support response is. So here, this should not take an age because there's no age in our type up here. And then down here, this return type should be string, and we're just gonna let that be inferred. So that should be everything we need to do. And if we submit, you can see it's all working. Now, the important thing to note about this though, is this support response variable right here, it is a type specifically only for use in TypeScript. You can't check to see if a variable is equal to this support type or anything like that inside of JavaScript. This is a TypeScript only thing because when your JavaScript code exists, this just gets completely deleted. So that's a really important thing that I messed up a lot when I was a beginner in TypeScript, is I would try to look at these types and try to infer things based on them inside of JavaScript by using type of or instance of inside of JavaScript. But JavaScript doesn't know what these type variables are because it's only in TypeScript. So just make sure you realize that all this type stuff gets removed when you go down to the JavaScript side of things. Now, the one thing with TypeScript is that you want to be able to import different code. For example, all these different type aliases. I may create a user type alias in one file that contains a bunch of information for my user, a really complicated and a long type, and I want to use that all across my entire application. Well, the really nice thing is we can import those directly just like we could in JavaScript by writing our import like this. But the problem with doing that is we're only importing type-related information. So we don't care about the actual code in that file because when we compile down to JavaScript, that type is removed anyway, so we don't want to add all that extra code inside of our system, which is why we have these import of type. So we can explicitly say, I want to import just the types from this file, which means the file itself is not imported into our JavaScript bundle at the end of the day. It's just the types that are used for compiling down our JavaScript code. So none of the actual code that's JavaScript related from this file actually ends up in our bundle. So we can import our type code like this, or we can import our type code like this. Both of them are going to work just fine. And the nice thing is when we go and compile our JavaScript code, this is a type related thing, so it's completely removed. So again, it just makes it so that our bundle size is slightly smaller. So anytime you're dealing with types, I always recommend importing them with the type keyword, either before your type or in line with your type like this. So here it's just asking, is this going to reduce the size of our bundle? And of course we can say, yes, this is going to reduce it because we don't need to import all this information. Now, I already alluded very briefly to the idea of a union, but a union is when you can create one type that can be multiple different types. For example, here we have a user ID that can be a string or a number. And the way you create a union as TypeScript is you use this pipe symbol. And you can chain together as many different unions as you want. So we could have a string, number, boolean, and so on, as many different changes we want. We just put a pipe symbol between each one of these different things. So in our case, we have this ID that's coming into our get ticket info, and this ID could be either a number or a string. So we can come in here and say that it's going to be a string or a number. And for example, if we wanted it to be a Boolean as well, we can come in here and say or a Boolean, and now this ID has all three of those different types. It could be any of those things at one time. In our case, it's just a string or number, so we're going to bring that down to string or number. And by far, the coolest thing in TypeScript, in my opinion, it's even cooler than type inference, is the idea of type narrowing. And type narrowing is just TypeScript's ability to take a type, for example, ID that's a string or a number, and be able to narrow it down to say it is now just a string, or it is just a number, or if we had like a one that had a Boolean as well, we could say it's just a string or a number, or it's just a number or a Boolean, and all these different things. And the way that you do that inside your JavaScript code is quite easy. Essentially, we just need to check, is this thing a string? Is this thing a number? If it's a string, TypeScript will know that it is now a string. That's what's showing down here. We can check the type of a variable. And remember how I said type information is removed from the JavaScript code? That is true, but JavaScript still represents what the type of an information is. And it's based on our primitive types. So we have like a string, a function, a Boolean, and number. TypeScript still knows those levels of typing information. It doesn't know our complicated types that we create. For example, when we created that function type in the last lesson, that's not going to be carried over, but the ability to actually store type information for just the basic primitive types is carried over into JavaScript. That's something that's been in JavaScript since the beginning. So we check this value to see if it's a type of string. Now inside of here, TypeScript will know that this is a string value. So I'm going to show you what that looks like inside of here. We can say if ID, and we want to get the type of it, is equal to a string, then we know that it's going to be a string. And you can see really quickly, if I hover over this, I get all the different types that it can be, such as string, number, big int, boolean, and so on. It's all the built-in types into JavaScript. So I can check for a string in this particular case. And now if I come down here and I actually use my ID variable and I hover over the type, you'll see the type here is a string. It is no longer a number, and I have access to all my string related variables, such as @ or I could say like to whatever to change it to a lowercase string. While if I access my string or my ID out here, this is a number or a string. So if I try to access things such as to lowercase, you'll notice that I actually am going to get an error. And the error is because this ID could be a number or a string. A string obviously has to lowercase, but number does not have a to lowercase, so it's going to throw an error for me. So this is why this type narrowing is really important, because it allows you to take something that has multiple types, convert it down to one type, and do different things based on what that type is. So inside of here, I could, for example, convert this to a lowercase ID, and that's going to work just fine. Now in our particular use case, if we look at what it wants us to do, we essentially are going to get a number like 42, or we're going to get something that says support dash, and then a number followed after that. And we want to either return the number as is, or we want to essentially come in here and get the number from this by removing this support dash section at the start. And we want to just return the string, processing ticket, and then whatever the ID is going to be. So if we have a string, we need to do something slightly different with our ID versus if we have a number. So we can just come in here and we can get the essentially parsed version. So I'll say const parsed ID is equal to, I want to take my ID, I want to split it on that dash character because I know we always have a dash at the start of our number, and I just want to get whatever the second property is because this property right here is our like support or whatever, and then the dash followed after that is our real number. So we're going to get the second value in that array, which is our parsed ID, and we just want to convert that into a number. So we can say const number ID is equal to our parsed ID, and we want to parse this as a number. We can come in here with an integer just like that. So now our number ID is an actual number, and we could just return that string, which we'll just copy over just like that, and we'll paste our number ID directly into there. So now that's properly working when we have a string type. We just need to make sure that this works when we have a number as well. So we can come down here, and we know that since ID was a string up here, that means that it cannot be a string down here because we're doing a return. It's like a guard clause essentially. So inside this code, we know that the ID is a string. And since we're returning, we know that any code that comes after must be not a string. And in our case, the only value is a number. So we can just essentially return our code as is, just replacing the number ID with our actual ID. And that right there should be the entire solution. Now, one thing that's really interesting about JavaScript when it was written is that you could call a function without passing all of the parameters to that function. It's kind of a weird quirk that not many other programming languages have for a function when you define it, but we needed to be able to make sure that we got that to work in TypeScript as well. So we have the idea of an optional parameter. So if you want to take a function and only pass some of the parameters along, like I said, in JavaScript, you can do that no problem. But in TypeScript, you need to explicitly say which one of your parameters are optional. That's to make sure that you're explicit in your types and saying, okay, you know what? This function must always accept all of its parameters, while this other one can have some optional parameters that we can pass along sometimes or not pass along other times. And to do that, you just put a question mark after the name of your variable. So if we look at this greet function here, you can see it takes a name. That name is required. And then we have this title, which has a question mark afterwards. And we can see that this title is now optional. And this essentially means that we don't need to pass this title along. Down here, you can see sometimes we're passing it and sometimes we're not. So it allows us to actually change what we do based on if we pass that value or if we don't pass that value. Now, another thing to keep in mind is if you have an optional parameter, it will always be whatever type you specify here, and it'll also have the union of undefined added on after that. So if we come in here and we make this tier an optional parameter by putting a question mark and I hover over it, you'll see that it is now a string or undefined. It has both of those different types being defined. And you need to make sure when you write your code, you handle that undefined case. As you can see here, it's handling the case when it exists, as well as the case when it does not exist. Now, another important thing to note is that your optional parameters must always come after your required parameters, because you can't pass an optional parameter before a required parameter. That just doesn't make sense. So if I come in here and I try to make this optional and I try to make this required, that's not going to work. You can see we immediately get an error in TypeScript saying that you can't have required parameters after optional parameters. So just make sure if you have optional parameters, they always come at the very end of your function definition. And you can have as many as you want. I could come in here with another variable just like this, and I now have two optional parameters. That works just fine. It's entirely up to you. They just need to be at the end of the function definition. Now for our particular code, what we need to do is we need to modify this where we essentially return a value based on whatever tier they're in. So based on certain tiers, they have a higher or lower cost. If they have no tier, they have the highest cost, while these other tiers have a lower cost per request. So what we can do is we can just do a simple check. First of all, we'll say if our tier is equal to null, or if you want to be very explicit, you could come in here with the triple equals and say it's equal to undefined. Those will both work. I generally use double equals because double equals to null will check both null or undefined. So either one, it'll match just fine. So now if our tier is equal to null, we know inside of here, when I access my tier variable, it is going to be null. You can see, well, in our case, undefined because that's what it is by default, but you can see we now have an undefined tier directly inside of here. So if our tier is not passed in at all, we know that our cost is going to be 0.1. So we can just return our number of request times 0.1, and that solves this base case right here. Then we can come and we can check to see if our tier is pro as well as our tier is enterprise. So we could say if tier is equal to pro, then we want to return something else. So we'll return our number of request times 0.05, and we can essentially do the exact same thing all the way down here with enterprise, and we can just return 0.03 for the value right there. And now we've essentially checked all of our different cases that we have. We checked to see it's null, and now we know that it's not null. So down here, we know it's a string, and now we're checking our string-based values. And if we submit, you notice we're technically getting an error. It's saying that the result is possibly undefined. The reason for that is because this function can technically return undefined. So what we need to do to make this a little bit easier is we'll just come in here and we'll say that if the tier is equal to pro, we do this. If it's enterprise, we do the thing below, and then we'll come down here, and instead of checking to see if it's null, we'll just return number of requests by default. So essentially, if you don't pass in either pro or enterprise, we always just default you to being no tier at all. This will make sure that this function always returns a number and it doesn't actually return undefined, and that should solve our problem. Now, often if you have an optional parameter in JavaScript, you may want to give it some other default value besides undefined, and that is where default parameters come in, which is actually something built into JavaScript as well. And this is just like the TypeScript way of doing it, which almost looks identical to JavaScript. So you can see here we have this new character. It has a role, which is a string, and you can see here we set a default value of warrior. This not only marks it with a default value, but it also makes this parameter optional. And you'll notice we didn't even put the question mark on here. And that's because if you specify a default value, you don't need to specify the question mark because it's inferred that this is going to be an optional parameter since you have a default value specified for it. And you can see here when we don't pass along a value, it uses our default, while here it uses what that actual value that we pass along is. So the really nice thing about these default values is since you give them a value by default, TypeScript can infer the type of your variable based on that default value. So we have even more type inference. So when you're using these optional parameters with a default value, you don't even need to specify the type of your variable because it knows this is a number variable. So inside of our code, we can come down here and you can see that we need to estimate the response time inside this function. It's going to take in a prompt length, which is a number, and a model type, which is going to be a string. And the string is either going to be text, image, or code, and it's going to have different response times based on that information. So let's come in here with our prompt length. We know that that is a number, and we know that it's going to have a default of 100 as its value. And let's just make this quite a bit bigger so it's easier to work with. Then we're going to have our model type, and we know that that is going to be a string, and it's going to have a default value. Let me check what that was supposed to be. Looks like text is the default value for that one. Now, since we have default values for both of these, we don't need to explicitly mention the type, so we can remove that information, which will make our code a little bit easier and cleaner to work with. And now we can go ahead and actually implement what this code should do. So you can see here if it's text, it should be 2 seconds plus 0.01 times the length of the prompt. Same thing here with image, it's 5 with 0.02, and code is 3 seconds with 0.05. So we can just do a really quick check here. If the model type is equal to text, then what we want to do is we want to come down here and specify how we want to do this operation, which is just going to be 2 plus 0.01 times the prompt length. So we can say return 2 plus 0.01 times prompt length. There we go. And then we can do pretty much the exact same thing with our model type being equal to an image. So we can come down here and this one would be 5 seconds and it'd be 0.02 times the prompt length. And then finally, if we come down here one last time, we can do the same thing with code. So if our model type is code, we know that this is going to be 3 seconds plus 0.05 times the prompt length. Now you'll also notice if we come into here, it specifically says that we need to round these values to the nearest whole number. So I could put like a math.round on every single one of these, but you'll see that I'm kind of copying a lot of code all over the place and it's not super clean. So instead we're going to refactor this slightly and I'm going to show you a feature of TypeScript, which is one of the only times you may need to explicitly type a variable. So essentially the model type determines only 2 things. It determines the base time and it determines the value per prompt length. So we essentially have 2 numbers that are determined by this. Everything else in our code is the same. So we just need to create 2 variables. I'm going to call this our base number. And then we're going to come in here with another variable, and this is going to be our rate number. And in order to set these values, you can see they by default have a type of any because we didn't specify a default value for any of these. Now in our case, we could set the default value to 0 because anything else is always going to return 0. But what I want to do is I want to show you how you can actually specify the type for these. So in our case, I could say our base number is going to be a type of number. And here with our rate number, we know that that's also going to be a number as well. So now TypeScript knows that these are numbers instead of any. And this right here is pretty much the only case where you actually need to explicitly type a variable. When you're defining a variable that has no value, but will later be given a value, and you want us to denote what that new value is going to be. Now in our case, I'm actually going to default these to 0 because that'll work with the actual code. So we'll default these to 0 just like that. And now TypeScript knows that they're numbers. But inside of here, I could say, for example, our base number is going to be equal to 2. And our rate number is equal to 0.01. There we go. Get rid of that. And now I just need to essentially put this code inside of a bunch of else's. So let's just make this a little bit easier to work with. We'll come in here with an else. And I'll put this check right here. There we go. Make sure we close that down. And I'll copy over our number information because this one's going to be a base number of 5 and 0.02. And then finally, I'm going to do the exact same thing with our code version. So we can come in here with code, make sure that this is an else if. There we go. And same thing here, else if. And this is just 5, or I'm sorry, not 5, it is 3 and 0.05. So I'll say 3 and 0.05. There we go. Now we can remove these sections down here, and all I want to do is just do my return, where I take my base number, and I multiply it by my rate number. So I'm just taking my rate number, multiplying it by my length, and I'm adding in my base number. And in the case where we don't have one of these model types, it'll default everything to 0, so this will just return 0, which is what the prompt over here is asking for. So now we should be able to run that, and we can see all of our codes working. Now we're getting to even more powerful features in TypeScript, which I use all the time, and that is the idea of literal types. And this is something most other typed languages don't have. Essentially, a literal type allows you to define a type of something not just as like a string, number, boolean, but instead as an actual value. For example, the string Kyle, or the number 22, or the boolean true. So it can denote specific values that are literal values, that's why they call it a literal type, instead of a generic type such as a string, which could be any string in all of the strings in JavaScript. So if we scroll down, you can see here move is a direction that could be a string. But in our case, we're going to say that it is specifically only north. So we can pass in a value. So anything that you could define as a value for a variable, you can use as a literal type. So here we pass in a string of north. We could pass in the number 0 or a string of down. It doesn't matter what it is, but now we can explicitly say this direction only has one possible value, which is north. So literals are really great when you have a hard-coded set of values that something can be, or even just a single value that something can be. Literals are going to be the choice that you want to do. And here we can see which of the following represents a good use case for literals. So a function that takes 2 strings, obviously not, because this could take any 2 strings. 2 numbers, again, this could be any 2 numbers. A function that takes one of 3 specific string values as an argument, that's a great choice because it can only be specific values. Or a function that checks if Alan's job has been replaced by AI. Probably not that one. So in this case, we have one of 3 specific string values, so we could do a union of 3 different literal types, and that would be the value for our argument. So we're going to click on that option. Now, speaking of a union of different literal values, that's exactly what we're covering in this lesson. And if you look here, move only in one direction, not super useful. What if I want to move north, south, east, west? I want to move in all the different directions possible. Well, I can take a union of multiple different literal values, and now my direction will only be one of those values. So right here, you can see we have north, south, east, or west as the directions that we can move. We can even extract that out into our own type alias, which makes it so now we can reuse this anywhere. So anytime we need a direction, we can use this specific type, which makes our code cleaner and easier to work with. Now let's move on to the lesson for this. And essentially all we need to do is we need to create a new type for priority that can be low, medium, high, or critical. And then we need to implement this set priority function. So let's get started with that type. So we can just say export type priority. And we want to set this to the value of low or the value of medium. Or we can come in here with high, and then finally critical. There we go. And if I hover over this priority type, you notice it has explicitly those values, low, medium, high, and critical. It can only be those 4 things. And now instead of this level being any string, I'm going to change this to specifically be a priority. There we go. So it can only accept one of those different priority types. And inside of here, I can check to see, is it going to be low, medium, high, critical, or just return 0 by default, which honestly should not be something that can even happen because we can never pass in a value that isn't low, medium, high, or critical. So what we can come in here is let's just do a switch case. I generally like to do switch cases when I have these types of syntax where it's like a few literal values. So we can switch on our level just like that. And I want to do a case. And our case for our level is either going to be one of those levels that we talked about. So if we look at our autocomplete, you can see we have low, medium, high, and critical. It's one of these different levels. Let's start with low. And we want to just return, what was it? 0 for low. There we go. Then we can come down and we can create a brand new case. And I don't even need these brackets actually. So we'll just remove them. So I can have a case here. This one is going to be medium and we'll return 1 for this one. Then I can have a brand new case, and you'll notice again, I only have critical and high as options because it's narrowed my type down. It knows it's not low, and it knows it's not medium because it skipped my first 2 cases, so it must be high or critical. So we'll come in here with a case of high, and I'm going to return 2. I need to make sure I put my colons at the end of my cases. There we go. And then finally, we can have a case of critical, which is my last remaining case. There we go. And in this case, whoops, getting some weird autocomplete going on, we can return 3. Finally, we're going to add in a default case, even though this should never be possible for it to hit. We're going to add it in here to be able to make sure we define what we need to do based on these different criteria. And now we've essentially created a solution here that has a priority of low, medium, high, or critical, and then we return that as a number based on which priority we pass in. And if we run the solution, we should see everything's working just fine. So these literal type values are something I use all the time inside of TypeScript. It's probably one of the coolest features in TypeScript. And the great thing is they work really well with switch cases like this. Now in this lesson, we're going to be talking about superset unions, not something you use all the time, but it's really useful, especially for library authors. And what this essentially allows us to do is take some set of literal values and allow us to add on more values to them so we can have a set of values as well as any value that falls within a specific range. So in our case, you can see we have error codes 1 or 2 or 3, and we're also saying or number. Now, this essentially narrows down to just or number. Essentially, if you wrote this as just error codes equals number, that will be the exact same type. The big difference is how it works inside of your editor for when you're writing code. Because by writing these specific types of 1, 2, 3, or number, we now get autocomplete that's going to autocomplete to 1, 2, or 3, or we can type in any number and it'll still work just fine. So in our employment status up here, you can see we have employed or unemployed or student. And if we look at the example, we essentially want to make it so that this employment status type is going to also accept in a value of any string that we want. So it doesn't just have to be a normal string, it can be literally any string. So what we can do is we can just say that we want to add the or string onto the end here. And now when we call this update employment function right here, we can pass in any string that is in this list. So we could pass in employed, just like that. That's going to work fine. We could pass in unemployed, that's going to work fine. Or I could pass in just a bunch of gibberish, and that's going to work fine too, because it also accepts that string as the parameter it's taking in. Now, some situations where this may be useful, imagine that you have some metadata that you're accepting into a function, and this metadata could be a few specific values. For example, you have like a name and an age as different metadata, but you also want the person using your code to be able to pass along any other metadata they want. So you have some hard-coded metadata, and then they could just pass along whatever other metadata they want. This would be a great use case for that because you can specify some hard-coded values that say, hey, these are the things that we normally work on and expect, but also since you can do whatever you want, we're going to give you the option to pass along literally any value that falls within this type as well. So like I said, it's not something you use all the time, but it is really useful in specific situations, especially when you're writing different libraries. Now to make this code work, we can just essentially remove all this code we did down here below the thing that says literally don't go below this line. And when we submit, you can see it's working. Now, one thing that's really cool with TypeScript that I don't think any other type system has is you can take these literal types and you can use template literals, which is that fancy string syntax that we have down here. And you can create custom types by combining together different things. So here we have a type of class, which is just a wizard, warrior, or rogue. It's just a combination of these three different things. It's just a literal union type we've already talked about. And now what we're doing is we're taking a new type called hero and combining the string template literal of elf at the beginning, followed by a class, which is this type up here. And what TypeScript does when it sees code like this is it'll take everything in this union and essentially it'll loop through them one by one. So that this hero type will essentially take each class and insert it where class is. So the first time it'll say wizard, second time it'll say warrior, and the third time it'll say rogue. And it essentially combines that together into its brand new union. So now we have a union that is elf followed by wizard, and elf followed by warrior, and elf followed by rogue. So it combines together all those different elements. And the really cool thing is that we can actually combine this together with multiple different unions as well. So here we have a wizard, warrior, rogue, and here we have some races, elf, human, dwarf, and now it's combining these together. So we have a elf wizard, an elf warrior, and elf rogue. We also have the same combination for human, and then at the very end we have the same combination for dwarf. So essentially it's two different loops nested inside of each other. It's looping through all the different races and doing each class for them, and it's looping through all the classes for each one of the races. So essentially it's combining together these different unions into a larger union that contains every combination of those different unions together. This is again something that you don't use all the time. It's especially useful for library authors, and I've used it a lot when writing libraries, but when you're writing more application style code, which is like your day-to-day code, it's not something that you use all the time, but it's good to have in the back of your mind because certain situations, this is really important to use. So what we need to do for our particular assignment is we need to create two different types. We need to create a log message, which we use down here, and a log source, which we use right there as well. And these two different types essentially are going to be, for the first one, a log message. It's going to start with a log level, followed by a colon and a space, and then we're going to have any valid string that we want. So let's get a quick start on that. We can say that we want to export a type of log message. Make this a little bit bigger so it's easier to see. And we know that this specific type is going to start with a log level. So let's put that inside of brackets here, log level, just like that. So now we essentially, our log message is equal to our log level. Nothing has changed. Next, we want to do a colon and a space. So now if we hover, you can see we have a colon and a space. And then finally, we want to follow this up by any string. So the way that we would do that is, again, just wrap this inside of our parameters. And now we just type in string here. And this is just a single union, essentially. We have a string, which is just one single value. So instead of doing looping over this string, we're just saying it's going to be a string. So now if we look at our log message, it is info colon followed by a string, warn colon followed by a string, and error colon followed by any string at all. And if I were to change this string to be a string or number, you can now see when I hover over this, we have warn or number, error or string, error or number, warn or string, and so on. So it's being able to loop through these different things. In our case, we're saying it could just be any string, which is why we're passing it in like this. And the next thing we need to do is our log source right here. So let's come in here, we'll export a type log source. And this log source is going to start with our log source type. So we'll say log source type, just like that. Then we're going to follow it up with an underscore and then any number. So we could just come in here with that number type. And now you can see we have our log source, which is API followed by a number, database followed by a number, and auth followed by a number. And if we submit, you can see everything's working. Now, one downside to using these dynamic string template literal unions is if you combine together things that have a lot of different parameters. So in our case, we have this distance that can be the values between 1 and 9. And then we have all these different classes here. So we have a bunch of different values. In our case, we have 9 distances and 8 classes. And then we combine them together in this move message that has a class. So that's 8 options, followed by a distance, a distance, a distance, and another distance, and then finally another distance. So we have 9 options here, 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 and then we have 8 options here. And we need to create the permutation of every single one of the different options that we have for 8 classes across all those different distance values. You can see that it is a massive number of types. And eventually TypeScript's going to get to the point that says, hey, you know what? Stop that. That's way too many types. You are absolutely overloading me with different types. It slows down the performance of your application. And at a certain point, TypeScript just says, I'm done. I don't want to deal with this. Your type is too complicated. So when you start to get into really complicated types like this, where you're trying to hard code everything to be super specific, just ask yourself if it's really that important that it has these specific types. Because if you get too many of these types that become too large, not only will it slow down your TypeScript, but you could run into these errors if you have too many of them. Now, it's very unlikely that you will run into this error because you don't normally write code like this. And most of the time when I'm using unions, I write my unions with just hard-coded values like this. Or if I'm using this string template syntax, my union that I'm pasting in is usually very small. I may have like 3 options here and 2 options here and like 4 options here, which is a much more manageable union versus this one, which has essentially an infinite number of combinations. And to answer the question here, creating a hyper-specific union type does have negative impacts on your editor, so we're going to say true. Now we're going to be moving on from the basic built-in types to some more complicated types such as arrays. Defining an array in TypeScript is actually relatively straightforward. All you need to do is take whatever the name of your value is that you want to check, for example, a string or a number, and add brackets to the end of that. And that denotes that now you have an array of those particular values, whether it's a number, string, or whatever else. And as you can see here, we have the average score, which is a rating, which is an array of numbers. And inside of here, we have an array of different strings. So we can see these different values. And you can even combine this together with unions and other things. So if I wanted to have an array of strings or numbers, I would just wrap my string and number section in parentheses to denote that these are one single thing. And now I have an array of both strings or numbers. And if I hover over my ratings, you can see it gives me that exact type. Now in our case, these are just numbers, so we're going to return these as numbers, and we want to get the average of these different ratings. So we can do that relatively simply. We're going to use a reduce for this. So I'm going to come in here, we're going to take our ratings, we're going to reduce down our ratings, and that's going to give us essentially an accumulator as well as the individual rating itself. So we're going to have our current rating, we'll just call that rating, and then we're going to have our sum right here. Then this is going to be a function that's going to return to us some value. So we can just return my rating plus my sum. That essentially is going to sum up all of our different values. We're going to start with 0 as our very first value, and this is going to give us the sum. And of course, we need to be able to divide by the length to give us the average. So we're going to take ratings.length just like that. And that's now going to divide by the length of my ratings. And if we submit that, we're actually getting an error down here when we have an empty array. I didn't think of taking into example when the array was empty. So we'll just come in here with a simple, if ratings.length is equal to 0, then we'll return 0, because obviously if we don't have any ratings, dividing by 0 is going to give us an error. So now when we submit, we have the successful solution. Now there's an alternative way that you can define arrays. I don't use this option nearly as often, but you can do this if you want. And essentially that is by using this array syntax right here. So you say array inside of brackets, then you put the type that you want. So if we look down here, this is what we've already looked at. We type our type followed by brackets to denote that's an array. Here you can see we have this array keyword, and inside of these angle brackets, we put the type that we want the array to be of. So this is an array of strings, and you can see this is a string array. They both give you the exact same type in TypeScript. There are no differences between these two, but this one is using something called a generic. It's an actually relatively complicated thing in TypeScript that's covered towards the very end of this course because it's one of the more advanced features you use in TypeScript. So it doesn't matter which approach you use. I generally use this approach for defining my arrays, but it's entirely up to you, and you will definitely see both options. Now, if we take a look at the question, you can see which one of these types notations is invalid. Well, if we wanted to have an array of numbers, this is essentially an array nested inside of an array. This is actually completely valid. Essentially, we're saying that we have an array of numbers, and then we have an array of that. So we have essentially 2 nested levels of arrays. This one is going to be the invalid one right here because array is not capitalized. Then we have the capital version of array, which is correct. And then down here, we have that exact same thing. We have a doubly nested array. We have an array of numbers inside of an array. It's the same exact syntax as this top one. Now, earlier I talked about how you can have array with union types, and that is exactly what this lesson is all about, is heterogeneous arrays. Big fancy word for essentially saying an array that can have more than one type inside of it. Because inside of a JavaScript, we can have an array with numbers, strings, booleans, objects. It doesn't matter. It just works in JavaScript because there are no types. But in most languages, when you're dealing with an array, your array must either be all strings, all numbers, all objects. It must match a specific type. But in TypeScript, since we're matching JavaScript, we can have an array that can contain anything we want. For example, we can have an array of strings or numbers, as well as a bunch of other information. Now, you may be starting to think when you're looking at some of this syntax that it's starting to get really confusing. We're combining together a lot of different things. But when you get confused by a TypeScript type, I highly recommend breaking it down into the individual components of the type, because everything in TypeScript is just composed together of all these different small features we've talked about. So for example, this comments type, we can see we have a string or an array inside the parentheses. So we know that we have something that is a string or an array. And then you can see we have the array syntax afterwards. So we now know we have an array of these strings or numbers. And if we were to break this apart, it's essentially two different sections. The first section here is this string or number union. And then we have this section, which is combining that together into an array syntax. So it's an array of this particular union. So everything in TypeScript is just built on top of the building blocks. So when you get confused by a type, try to break it down into those building blocks. It makes it much easier to parse. Now for our particular assignment here, this one's a little bit more complicated. Essentially, we have an ID and a comment that are being passed in. And then we have an array that's going to be both full of strings and numbers. And all you need to do is you need to find wherever the ID is inside this comments array, essentially the number inside this array, and replace it with the comment that gets passed in. So we're essentially just taking this ID, finding it in the array, and then replacing it with the actual value that we're looking for. So first we need to find what the index is. So we can say index is equal to comments.findIndex. That allows us to find an index for a specific value. We're going to have our comments, and we're going to say where the C is equal to our ID. So essentially wherever this value, which is a string or number, is equal to the ID that we pass in, which is a number. That's going to give us an index. Now this find index function is kind of interesting because it returns -1 if there is no found value. So if the index is equal to -1, then we're just going to return and say don't do anything at all. And if we do have an index, then we want to replace that. So we're going to take our comments at that index and replace it by our comment. Essentially, all we're doing is we're finding the comment based on this ID in our array and then replacing it with the comment that we want passed in. Now, if we submit that, you can see our code is working properly. So that's all that's working. And really, this was just to demonstrate that you can have an array with multiple different types inside of it. Now, the next thing we're talking about is REST parameters. And this is actually a feature built directly into JavaScript. This is not a TypeScript specific feature, but we do need to understand how to use it in TypeScript. So as you can see, we have this gather party function, which takes in a string as a name, and then it takes in any number of adventurers, which is an array of strings. So you can see when we call gather party, we have to pass it the name of that party, and then we can pass it any number of strings after that that are going to be in this adventures array. Again, this is a feature built into JavaScript. Now, the only important thing about TypeScript specifically for this feature we need to understand is that we just need to make sure that when we use this REST parameter here, that we always denote that it's going to be an array, because it always takes in an array of values, and it can be of any length between 0 and infinity, essentially. Now, if we scroll all the way down to what we're supposed to be doing in this code, you can see that if we run this, we're going to be getting an error. Essentially, you can see here, a spread argument must either have a tuple type, blah, 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 a bunch of different information going on. Essentially, what we need to do is this format labels could pass in any number of labels. It could pass in 1 label, it could pass in 10 labels, it could pass in no labels. We're not sure how many it's going to pass in. So this is going to be a REST parameter. So we need to use that triple dot syntax and come over here and denote that this is going to be an array right here. Then what we need to do is we need to actually make the function work. So return the string no labels if there are no labels. Let's do that first. If labels dot length is equal to 0, then we're going to return no labels. There we go. Then what we can do is we can turn the string label, whatever the label is, if there's only one label. So we can say if labels dot length is equal to 1, then we're just going to return the text right here. I'm going to make sure that's a string interpolation, and we're just going to take our first label from the array, just like that. There we go. So that's returning essentially our label if we have exactly one label that we're going to be using. And then down here it says we can return the string label and combine together all the different labels if there are multiple labels. So we can come down here and we can just return, and this should say labels. And then we're just going to combine together all of our labels. So we'll say labels.join, and it looks like we're joining on a comma and a space. Now, if we give that a quick save and close that off, we should see that this works properly. And there we go, it does. So this is just kind of showing you how you can use these REST parameters inside of TypeScript by just denoting that they are always going to be an array type. Now, arrays are again a little bit complicated because when you define an array, it can have any values in it by default if you don't specify what the values are. So you can see when I hover over this, the type for this is any. You can see it has any type because anything can be pushed into it because I didn't specify what the type could be. But the interesting thing about arrays is if I start adding values into it, it'll essentially evolve what that type is to try to narrow it down as much as possible. So if I push a number into my array, it'll now turn into a number array instead. And I can show you that by just saying support data dot push, and I want to push a number into it. And now if I hover over support data down here, you'll notice that support data is now a number array instead of an any array because it's now inferred that type. But it goes even further because now if I push a number or a string in, it'll now infer that it's either a number or a string. So it'll constantly evolve what the type of this particular variable is. Now this is something that can be useful, can not be useful. It can also be something you can easily get in trouble with by having an any type here. And generally I try to avoid any types as much as I can in my code, but this specific example in this lesson is really to showcase how this evolving any type works. So to be able to finish our code, if we go all the way down here, we just need to add these different things into our data. So we can come in here, we can add in this string, so we can push that into our data. Then we can push in the ID, so we can just copy this down. And we want to push in the ID that's being passed in. And then we want to push in this resolved variable, just like that. And this should solve all of our code. Essentially, we're just pushing all this information in. And now you can see this is a string, number, or Boolean array. So it's one of those different values. If I click submit, you can see that did work successfully. Now, I do want to mention one potential thing that you may run into when it comes to these particular arrays, though, because sometimes instead of getting an any type, as you can see here, we're going to get a never type instead. And now it's not always clear exactly when this is going to happen because it depends on different configuration values and so on. But one case where this will happen is if you try to essentially do like a default fallback value. I'll show you what I'm talking about. Let's say I have a variable, just call it C, and this could be set to like an array of values, or it could be undefined, for example. And if this variable is undefined, I want to fall back to an empty array here. So I could say C, and then I could use this nullish coalescing, which lets me fall back. So if C is undefined or null, it'll fall back to this empty array here. And now my support data, if I hover over this, is a never array. Now never is a type we'll cover much later, but it essentially means that it could never happen. It's the opposite of any. Any means that it could be any type, never means that it is no type at all. So this is essentially saying that this array has no type information. So depending on how you define your array, you may get an any array in most cases, or in these smaller edge cases, you may end up with a never array. Just something that you may want to watch out for, which is why I pretty much always recommend if you're creating an array and then adding data to it later, I pretty much always recommend hard coding what the type of that array is. Like in this case, if it was a Boolean array, I would do something like this. Now in our case, we're using inference and trying to use that particular evolving any just to understand how it works. So I'm going to take our code back to what we had before, and we're going to submit it again just to make sure everything is still working. Now this is by far the best feature when it comes to inference and type safety inside of TypeScript, and that is object literal types. Essentially the ability to type what an object should look like. So instead of it just being an object that can have any key and any value, we now say this is an object that has specific keys and values. So how you define an object type inside of TypeScript is for the most part relatively straightforward. You just open up with some brackets just like you would for an object. You specify the property name, you give it a colon, and then you give it a type. So normally when you define an object in JavaScript, you would come in here, we'll just say const a equals, and you give it a property and a value like this. So we have our name and our value. But in TypeScript, if we want to do this, instead of giving this a value here, we just give it a type. And otherwise, everything else is exactly the same. And obviously, this would need to be a type variable instead. So now we have a type A, which is an object that contains a name that must be a string. So that's the whole idea behind these object literal types. And the reason they're so powerful is they give you amazing autocomplete and IntelliSense throughout your entire code base, and it makes refactoring so much easier. So if we scroll down to what we're supposed to do, essentially we need to create a type called male. So I'm just going to come up here, export a type called male, just like that. And the type must essentially match this type right here. So we're just going to come in here. We're going to copy that full type. I'm going to paste it up here. I'm going to rechange this to that male type. So now I've created a type alias called male. And this male type alias has a from, a to, a subject, a body, and an urgent, and they have specific properties on them. And the really great thing is now when I'm working with this, if I get autocomplete, you can see it autocompletes to only the properties available directly inside of this male object. So you can see I have the to property being used because that is what this is right here. And if we submit, we should see our code works properly. And this is going to be a little bit of a lengthier section in the course just because objects are so powerful, so versatile, and they're the main thing you use inside of TypeScript. Now, this lesson is specifically talking about something that the TypeScript does for you in your editor to help you out, but it doesn't really change how TypeScript works. And that is how it handles extra properties. An interesting thing about JavaScript is if I have a function that takes an object, for example, a name and an age, and I pass it a person that has a name, age, address, and a bunch of other information, it'll work just fine because it can still get the name and it can still get the age. And TypeScript, for the most part, works exactly the same way as JavaScript. If you pass a person object that has a name, age, address, and so on to a function that accepts a person with a name and an age, it'll still work because you have passed all of the required properties. But it works a little bit differently when you pass an object literal. So let me show you what I'm talking about. If we scroll down here, you can see we have a type for a spaceship. It has a name and a speed. And we have this falcon type, and it has a name, a speed, and it has this weapons type as well, this weapons property. This falcon is still considered a spaceship because it meets the minimum requirements. It's just having a name and having a speed. So if we use a function that takes in a spaceship, it'll work if we pass in that falcon because it meets the minimum requirements. You must always pass along the minimum requirements. But if we were to pass along that object in line, as you see here, we're passing that full Millennium Falcon object in line, we're actually going to get an error because this weapons is not required. And this is just to help out you as a developer if you're accidentally passing along properties you don't need. Because if you're using an object like this, it's oftentimes the case you're getting this object from somewhere else and it contains a bunch of properties and you don't know exactly what it contains, and you just know it contains at least the minimum required properties you need. But if you're hard coding what object you're passing along, that means most likely if you typed in a property that doesn't exist, you either made a typo or added extra code that shouldn't be there. So TypeScript will let you know, hey, you probably didn't mean to add this specific type. So this is purely there to help you out as a developer. For example, if you spelled speed incorrectly, you spelled it S-P-E-D instead of E-E-D, it would give you a warning saying, hey, there's some type of error inside your code because you spelled speed incorrectly. It'll let you know that particular type of information, which is really useful. Now with our particular assignment, if we take a look at the code that we need to solve here, we have this mail type up here, and then you can see we have some code down here because we have some incorrect stuff inside of our type. So let's see what we need to do. We just need to fix the mail type by adding the missing properties used, which we can see is that CC property. And it looks like it is an array of strings. So we can essentially just copy 2, change that to CC, that should fix our errors. And if we submit, you can see it's working properly. Now, just like we could have optional parameters inside of a function, we can also have optional properties inside of an object. For example, a superhero can have a name and a strength, but a cape could be optional. And when you create an optional property, you do it exactly the same as you would in a function. You just put a question mark right here. And that means that now this cape is going to be either Boolean or undefined. It'll automatically add that or undefined section in there for you. Now, if we take a look at our code over here, essentially all we need to do is fix this because some of this could be optional. As you can see here, this CC property is optional. So let's change the type up here for CC to be optional by putting a question mark on it. And now the type for this is going to be a string array or undefined. And if we submit, that'll work properly. Now, if you remember back to when we dealt with arrays, an empty array defaulted to an any array, and in some weird instances, it defaulted to a never array. But if you use an empty object in TypeScript, it actually works quite a bit differently. You may have heard in JavaScript that everything is an object under the hood. And that's true. Every single thing in JavaScript is built on top of an object. A string is technically an object behind the string. Scenes. Think about it. If we have a variable called a, which is equal to a string, we can use functions on that. We can say a dot to lowercase and so on. So this is a object behind the scenes. Everything in TypeScript and JavaScript is essentially an object behind the scenes, except for null and undefined. Those are not objects because they're the essentially absence of an object. So if you create a variable called new user and you set it to an empty object, that's essentially the same as saying, I think the type of this is literally anything except for null and undefined. So we can go ahead, and if we try to add properties, that's not going to work because it doesn't know what exists on this value. So we can say here, empty array, we can say a.name is equal to whatever, and you're going to see we get an error because it doesn't know, hey, there's no property name on this object. This object has no properties at all. But if this was a let variable, I can come in here and I could say, you know what? A is just going to be a random string. That'll work because A is an empty object type, which is literally anything except for null and undefined, because those are the only two things that aren't objects behind the scenes. So generally, if you're creating an empty object, you almost always need to give it some type to go with. So for example, I could say that this is going to be the mail type. And now I have autocomplete on all the different properties in here that I need to define, and I can't redefine it because obviously it's specifically this mail object, and it must always match this mail object format. So almost every time you're working with empty objects, you need to give it some kind of type just so TypeScript knows, hey, how do I create and work with this particular thing? It doesn't come up too often, but you may see it in your code every once in a while. Now to be able to fix the code here, we need to give our address a type. And if we look all the way down here, you can see our address has a name and a domain. So let's just go ahead and add those in. We can say name is going to be a string, and we can say that the domain is also going to be a string, if I can spell properly. That should fix all the errors. If we scroll down, I don't see any errors. So let's go ahead and submit this. And you can see we have no errors. It's working fine. Now, a feature I love in TypeScript is the idea of discriminated unions. And discriminated unions is very similar to a union where we have like string and number, but instead of being based on like primitive types or small types like that, it's actually going to be based on larger types, pretty much always objects. And these objects are going to have a single property that is different between each of these different types. It's going to have a hard-coded discriminating value. So in our case, the property is kind. And if we have a multiple choice lesson, the kind is multiple choice. A coding lesson has a kind of coding, and now a lesson can be either a multiple choice lesson or a coding lesson. And TypeScript is smart enough, if we check to see what the value of kind is, whether it's multiple choice or coding, it's smart enough to figure out, okay, if the kind is coding, we have a coding lesson. While if the kind is multiple choice, we have a multiple choice lesson. So if we look down here, you can see lesson is either multiple choice or coding. And we check if the kind is multiple choice, well, now we know we have access to all the multiple choice related stuff. While if the case is coding and our kind here is coding, we now have access to all the stuff inside that coding lesson property up here. So this is essentially another way for us to create unions, but these are more complicated unions that have a single property on them that allows us to distinguish them from one another. The example that I like to give in the case of discriminating unions is, imagine that you have an API that you make a request to, and that API is going to send you back some data, and it's going to have 3 different states. You can have the loading state where there's no data and there's no error, it's just loading. We can have the success state where we get back a data property, or we can have an error state where we get back an error object. So now we have 3 different distinct states that we can be in. So if we created that as an object, we could have a type here for loading. And if we just create that type, we can say that the status is going to be the text loading. We can now copy this down. Let's say that we have an error. The status on this one is going to be error, and we know that we have some type of error value. It doesn't matter what it is, we can just say that it's going to be a number for like a status code. And then we can come down here for a success state, and we know the status here is success. And we now, instead of having an error, we have some data, and this is going to be like a string with our error or our data message or whatever it is. So you can see we have these 3 distinct types. We can check this status property and get proper TypeScript based on what the status is, based on all the narrowing we do. If we look down here, you can see we're doing exactly that. We're checking is the address kind internal or external and doing different things with that information. So we just need to create this internal address and this external address type to solve this problem. If we scroll down, you can see essentially create those different types for us. So let's go ahead and we'll create those types. We'll come in here, internal address, set that equal to an empty object to start, and we'll come in here with external address as well. Now, if we look, kind is the property that we're checking on. And if it's internal, they have a first name and a last name. So let's go up here. We'll say that the kind is going to be internal. This must be that hard-coded discriminating value. Then we have first name and we have last name, just like that. Make sure I spell all this properly. And if we scroll down, we should see that cleans up all of our different errors, at least in this case, but it's actually not quite cleaning up all of our errors because we don't have a type for external address yet. So I'm going to copy over what we have here, paste that down, change this to external. Now that should fix our internal section, but now external has a username and domain. So we need to change this to username and this to domain. And now hopefully if we scroll down, we have no more errors. And if we submit, everything will work fine. Now inside of JavaScript, we have a concept called sets. Sets are like fancy arrays that cannot have duplicate values. So I can have an array of like 1, 2, 3, 3, and that's going to be fine as an array. But if I turn this into a set, it takes all my duplicate values and automatically removes them, which is really useful for certain scenarios. And when you want to have a set, it makes sense to use the set inside of JavaScript. So to create a set in JavaScript, we can just say const set is equal to new set. And then we can pass it in an array of values, for example, 1, 2, 3, 3, and this will convert to an array that is 1, 2, 3. It removes those extra duplicate values for me. Now inside of TypeScript, we can specify what the type of this set is going to be for us by specifically coming in here. Like if we don't have any default values and we hover over our set, you can see it has this type of unknown. It doesn't know what this type is yet because we haven't defined it. So we can come in here with that same generic style thing we did with arrays, and we can define a type. For example, this is a set of strings. Now when I hover, you can see we have a set that is all string-based values. So if I try to add a value into here, and I try to add a value that's a number, I'm going to get an error. But if I try to add a string, you can see that it works just fine. Now this is again using that fancy generic syntax. Like I said, we're going to be covering towards the end of this course because it's one of the most advanced things that we're going to talk about. Now we can go ahead and actually try to implement this function. So we'll scroll all the way down to the assignment. It just says what we need to do is take an array of strings, return the number of unique values in that array. So what we can do is actually relatively straightforward. We can come up here, we can create a set, which is going to be equal to a new set of those formatted addresses. Just like that. And you'll notice I don't actually need to define a type for my set. When I hover, it knows that it is a string-based set. Because again, TypeScript is smart and it infers that since this over here is a string array and I pass that string array to my set, well, my set also must be an array of strings. So it's really, really smart at inferring things. So you almost never have to pass along those generic types, which is really nice. So now we have a set that is created from that array. So all the duplicates are removed. So to find the number of unique values, we can essentially just take the length of our set. So we can just say set.length just like that. And if we submit, we of course get an error because I always forget sets are slightly different than arrays. And instead of using the length here, we're going to be using size, and size is essentially the equivalent of length. So now if I submit, you can see we get the proper result and everything's working. Now, just like sets, JavaScript has support for maps. And inside of TypeScript, when we use a map, it's essentially the same as when we use a set. So I can come in here, say map is going to be equal to a new map. And a map is essentially like an object, but it's specifically saying that we have a key and a value, and the key can be anything. It could be like a number or a string and so on, while in an object, obviously the key must be a string. So we have a little bit more flexibility in maps where we can make the key even something like a Boolean if we really wanted to. Now, when we define a new map, we can pass along what the types are going to be for the key and for the value. And we do that same thing in the angle brackets. So the first one is going to be the key. In our case, if we had a string for the key, it would say string. And the second one is the value. So if we said number, that means that the value is going to be number. So now when I try to set a value for this, I can come in here and I can set my first thing must be a string and my second thing must be a number because I denoted that is a string and a number. And again, if we were to pass in some default values, for example, a string with a number, we can now actually remove this generic hard-coded type because TypeScript is smart enough to say, hey, we know that you passed in a string number pair, so it knows that it's going to be a string number based map. Now for this particular lesson, what we need to do is we scroll all the way down here. This is going to give us a file length. So we're going to take in that map that represents file names and their file contents, and with a specific file name to get the length of that. So what we can do is first get our file. So we can say file equals files.get, and we want to get based on the file name we passed in because that's what the key property is. Now this file could be null or undefined because it doesn't exist. So if our file does not exist, then what we can do is we can return here. It wants us to get the length, so I would assume it probably wants us to return 0 in that particular case because there is no file. Otherwise, what we can do is we can return that length, and we need to use the text encoder for that. So we're going to return a new text encoder. There we go. And I want to just call the encode property to encode our file content. So that right here is going to be our file. This is like our file content. And then we want to get the length of that. So we're going to get the length just like that. And if we submit, we should see everything's working. Now inside of TypeScript, sometimes we want to create an object, but we don't want to define exactly what the keys are. So instead of having a person with a name and an age, instead we want the keys to be able to be dynamic. They can be automatically set. We just want to say, oh, you know what, the key is always going to be a string and the value is always going to be something like a number or string or a Boolean, whatever it is. And in order to do that, it uses a little bit of a complicated syntax. So we define our object type. And instead of putting in specific things like name is string, age is number, and so on, we instead specify this weird funky syntax on the left, which I'm going to kind of skip over. That's like the name of the property, the key. And then we specify the value we want to have for that. So if we come up into here to do something similar, we can come in here, and the first part of this bracket syntax, essentially this bracket syntax is denoting we're accessing the key, and we need to give the key a name, and we're just going to call it key. It doesn't matter what you call this. I could call this A, I could call this B, it doesn't matter. This is just the name of the variable we're using in here, but it doesn't really matter what the name is. Usually you're going to see key because that's what you're denoting. You're denoting the type of our key property. The next thing you do is you denote what the type of that parameter is going to be. So we denote that our key is going to be a type of string. Then finally, after that, we denote what the type of the return is, the type of this value. So if we put Boolean here, now we have a mail preferences. We're going to have keys that are strings and values that are Booleans. So if I create an object that's going to have that mail preferences type, I can come in here and I can define any string that I want. So we'll just put a bunch of bogus data, and then the value must be a Boolean. So for example, true or false. Those don't throw errors, but as soon as I put like a number in here, I'm going to get an error unless I change this to number. And now you can see my code works just fine. So this allows me to use dynamic keys that have a specific type and a specific value. This is really useful for when you want to be able to like let people define their own keys on an object. And I know the syntax looks really confusing, but think about it. When you're accessing a dynamic property in JavaScript, you use the bracket syntax on the object. For example, I could say a dot, and then I could pass in whatever I want. And that is able to access those dynamic properties using that bracket syntax. So we use the bracket syntax, put a name for our variable because you always need a variable name in TypeScript, and then we specify what the actual type of that thing is. Now, if we look at what the code for us is asking us to do, essentially we want this mail preferences to store a mapping of key value pairs. And if we scroll down to our code to look, it looks like here the value should be a Boolean and a string. So we know that this should be string Boolean. I actually had it right the first time, and now we can remove this. And if we give this a quick submit, it should work. Now, there is one thing I want to note is that you can actually define these dynamic objects in two separate ways. We're going to be covering the second way later in the course, but I want to cover it here quickly because it's another way to do the same exact thing. So what we can do is instead of writing all this code like this, I'm just going to copy this. I'm going to call this mail preferences 2. And what we can do is we can define this as a record. A record inside of TypeScript is essentially just an object. That's what it's defining is an object. And we can specify two things inside of here. We can specify the key property and the value property. So in our case, if we write our code like this, we're saying that this is an object that contains strings that are keys and it contains values that are booleans. And these two definitions are exactly the same for pretty much all of our purposes. So if we actually remove this, change this to mail preferences, and we submit, you see that our code also works. They're both exactly the same solution. Now, sometimes when you're working with dynamic properties, you have other properties that are 100% required and then everything else is dynamic. I talked a little bit about how like metadata is a really good use case for that. For example, you have a user with some information, for example, an email and a password, but they can also pass along any other metadata about that user into this form data field. So what we can do is we can specify, we can have a field which is a string with any value, and then we also always have to have an email and a password. So this works just like the dynamic properties we talked about before, but these other values we pass along are required to be passed along. So it adds a little bit of extra flexibility where we have some properties that are required, and then everything else is dynamic and entirely optional. Now, one thing I want to note about this is that you shouldn't overuse this dynamic style property, especially with required string keys like this. Usually you either want to have a fully hard-coded object with all the properties that are required, or you want a fully dynamic object. There are very few minor use cases where you want to have a combination of the two. So if you see this a lot in your code, just make sure to double check and think, is this the best way that I can be solving this problem? Because oftentimes it's probably not what you want to do, because this can make your code much more complicated to work with. Now, if we look at trying to solve this particular problem, we'll scroll all the way down here to our assignment. Essentially, we want to run the code to see what the errors are, a bunch of different errors about stuff, and we just want to fix it to make sure everything's work. In addition to the required properties, we should allow a string to map to a Boolean or a string. So if we look down here, you can see we have do not disturb, we have out of office, and then we want to make sure that it's going to map either to a Boolean or a string for any other property besides these two. So we can add those in as optional keys. We know that the key is going to be a string and that the value is going to be a string or a Boolean. Those are the only other two things it can map to based on this code right here. And now if we submit, you can see everything is working properly. So we have these two required properties, and then we have a bunch of other dynamic optional properties. Now, one thing that's really nice about TypeScript is they have tons and tons of built-in types that make working with things easier. And this property key is a built-in type to define anything that a normal JavaScript object can have as a key. Now, there's only three things. It can either be a string, which is what we've looked at mostly. It can be a number, or it can be a symbol. And a symbol is kind of like this fancy type that you probably will almost never use. I myself pretty much never use it, but it's a way for you to create essentially a string key that you can use for very specific niche use cases. Honestly, I would kind of just forget that it even exists because like I said, you'll almost never use this symbol type. But this property key is really nice because if in the future JavaScript functions or JavaScript objects, allowed you to pass maybe something else like an array as a key, that would never happen. But if it ever did, this would be able to get updated to include that new type for you. So this essentially is just TypeScript's built-in type that tells you what are the property keys that are allowed inside of TypeScript. And this is just based on the JavaScript implementation. So relatively straightforward. So we can use this, for example, here to say that a key can be either a string, number, or symbol without having to write that out ourselves because it's built into TypeScript for us. Now for our particular code, what we can do down here is all we need to do is implement this isSecure function. And we just want to check to see if they have either two-factor authentication or biometric lock enabled. If they have either of those enabled, we return true. Otherwise, we return false. Now these are using symbols. So if we look at this little tip right here, it kind of tells us how we can work with symbols. And symbol is a little unique because instead of being like dot and then typing out the name of the thing, you need to pass it whatever the symbol is to get the value for that. So here we can just take our preferences and we know that we have the symbol, which I think is just called two-factor. There we go, just like that. Yep, two-factor. So that'll give us the value of that two-factor property. And we just want to concatenate that with our biometric lock. So we can say here, preferences of biometric lock. So we're saying if either of these are true, we return true. Otherwise, we return false. And if we submit, you can see that that was successful. Now, TypeScript allows you to add quite a lot of modifiers to your different things. And one of them is the read-only modifier. Essentially, it allows you to take an object property and make it so it's only read-only. So we can't actually change what the value is. So if I just come in here, I'll say that const A is going to have that type of mail preferences. And if I wanted to set that to an object, whatever, we need our do not disturb. We'll just set that to false, and we need our out of office. We'll set that to false as well. If I were to come in here and I try to set my do not disturb to a new value, such as true, I'm going to get an error because this is a read-only property, which means I cannot change the value. I can only read the value. This is not something you can normally do in JavaScript, but TypeScript has support for this, and it's actually a really nice feature. You don't need it all the time, but in the cases where you want to make sure something's read-only, this is a really great way to do that. Now, if we scroll all the way down here to essentially run this assignment, we just need to make sure do not disturb and out of office are the only read-only properties. So if we remove read-only from here, and we just get rid of the rest of our code, and we submit, everything is going to work fine. So again, read-only, not something used all the time, but for specific cases is really nice. Now, one of the most overlooked features in TypeScript that is honestly quite powerful is the asConst property, which allows you to essentially take something that would normally be a more generic type and say that it is a very specific type that has specific values inside of it. So if we use asConst, not only does it create a read-only version of our type, which means we can't change anything, but it also makes it so that the actual definition of our type is specifically whatever we pass in here. So normally, if we take this example, that's colors, and I'm just going to paste that into our code here. Normally, our array here is going to be a string array, as you can see, because it can be any string. And we could come in here and we could add yellow to this, and it's going to work fine because it is a string array by default. But by adding asConst to the end of this, we've essentially said that now, instead of being an array of strings, this is an array that has only the values red, green, and blue. And if we hover over this, you can see it as a read-only array of red, green, blue. It literally cannot be anything else. So obviously I can't push yellow into this. Also, if I try to access properties inside of here, and I try to access, for example, a property beyond the last property we have, I get an error because there's not enough elements to access index 3 because index 2 is the furthest along that we can get inside of this array. So asConst is really great for converting a value that you have into essentially a constant type inside of TypeScript. So TypeScript knows this isn't going to change. This is always these values in this order no matter what. It works on arrays, and it also works on objects, and it even works on just generic string values, for example. For example, let's just come in here, and I'm going to say let a equal, and I'm going to paste in a string. Now, if I hover over a, the type is string, because I could always come down here and redefine this to a brand new string. But if I put asConst at the end of this, now a is specifically just that string type and nothing else. Generally, if you're going to have a type like this, you're just going to define it as a constant variable, and that essentially does the same thing for primitive values like strings, numbers, and booleans. But with arrays and objects, creating a constant version of them doesn't do that because you can always add and change them. So if we look at our object version up here, our object default preferences now has a name, which is always crazy. We have this do not disturb, which is always false. And we have this out of office, which is always going to be false. You can never change these. You can never update these. And these always have these specific values. Now, if you're familiar with JavaScript, you may be familiar with object.freeze, which is kind of similar, but not nearly as powerful in my opinion. I pretty much never use it. But object.freeze is a way in JavaScript to say that an object is immutable, at least at the top level. So it doesn't work on nesting, but it works at the top level. For example, this config constant, if I actually freeze this inside of JavaScript, it means I could not change my API URL. My admins, I couldn't redefine it, but I could add new ones. And same thing with the features. I could not change my features to something else, but I could still add values to that array. Now, asConst is really nice because unlike object.freeze, it actually makes it so I can't change the admins. I can't change the features. I can't add new features. I can't remove features. Everything all the way nested down to the lowest level possible is entirely immutable, constant, read-only, can't change at all. And object.freeze doesn't actually modify the ability to change things that are nested. As you can see here, I can change this admin's name and I can push new things into this array because those don't get frozen. It only freezes the top level of my implementation. Now, I don't really use object.freeze because I have TypeScript to do that for me, so I don't need to spend the extra runtime resources checking to make sure everything is immutable because TypeScript does that for me. But if you want to, you can use object.freeze for those specific use cases, and I believe we will for this assignment. So we're going to run the code and we're going to get some compile time and immutability errors. If I run, you can see some things are passing, but we're definitely not getting everything we want. We want to make it compile time immutable, and to do that, we just use that object.freeze property on here. So we can just come in here and we can say object.freeze. Whoops, there we go. There's our object. And we can come in here and just wrap that entire thing in object.freeze, and that's at least going to make it so it is compile time immutable. And now we are getting an error for our asConst. We don't actually need that anymore because it's kind of somewhat assumed with object.freeze is not as powerful because object.freeze only lets us freeze the top level, but it at least makes that top level read only. Now, if we go ahead and we run this, you can see that it is working fine. And if we submit, it is also working fine. Now, if we had a more nested object, you may want to throw the asConst directly into here. So we're saying that all the nested properties of this are asConst. But if you're using asConst, you probably don't need object.freeze unless you explicitly need that freeze property to be there on the runtime for some other reason. But again, I pretty much never use object.freeze because I have asConst to handle that for me. Now, a relatively new feature to TypeScript, not super new, but it's newer than a lot of the stuff we've talked about so far, is the satisfies keyword. And this satisfies keyword is kind of interesting because it deals a lot with the object types as well as this asConst that we've talked about before. And all satisfies does is allows you to say that an object that is some specific shape satisfies a type that you specify, but it doesn't actually change what the type of that object is. So if I come in here and I say, let's just say type A is equal to a name, which is a string. And then I say const A is equal to a name with the value of Kyle. If I can actually spell properly, there we go. I'm going to make this a constant variable of Kyle. So if I hover over A, it's a read-only name that's exactly Kyle, nothing else. Now what I can do is I could say, you know what, I want this A to share this type up here. So I could type it as the A type, but if I do that, I lose that constant ability that I have. Now it just has that type of A. So A is just a string and nothing else. It's not actually a constant value of Kyle. So if I wanted to be able to make sure that this A variable matches this A type, while also making sure it retains all this information here, I can come in here with the satisfies keyword. So I can say satisfies, and I can put whatever my type is. And now what I'm essentially doing is I'm saying, you know what, don't change the type of A. Let it stay a read-only name that is exactly Kyle, but also check to make sure that it meets the qualification of this type up here. So if I were to add something else into here, such as an age, which is a number, I'm now going to get an error because it no longer satisfies that property because this does not contain an age. And now we need to pass in an age, and now you can see that it works properly. So satisfies just allows you to make sure something matches a type without actually changing it to that specific type, which is useful when you don't want to change the type of something because it either has specific values or in our case, it has additional information inside of it, such as this signature and theme, which are not included up here. So it allows you to make sure it matches a type without actually changing that specific type. So I use satisfies quite a bit when I have these specific type of use cases that come up. Now let's go ahead and actually look at what we need to change inside of our code. If we look all the way down here inside of our assignment, we need to run the code as is to see the failing satisfies check. So this is actually failing. We can even just see that just by looking at it right here. And what we need to do is we just need to fix the different typos. So you can see we have do not disturb and out of office is spelled incorrectly. So if we change that, and we also change do disturb to do not disturb, we should now see that everything is working properly. And actually not quite, because this is out of office. I'm pretty terrible at all these different typo things, which is why I love having TypeScript, because at least it tells me when I make these types of typos. Now when I submit, you can see it's working. Function overloads are something that a lot of different languages have, and it essentially allows you to define multiple different definitions for the same function with different parameters that you can pass along. So if we take a look at this format employee message function, it takes in an employee, and optionally it takes an isNew and an onboarded date. And in our particular case, we have two ways we want to call this function. We either call it with just an employee, or we call it with an employee, isNew, and an onboarded date. But right now, the way that we can call this function is three different ways. We can call it with just an employee, we can call it with just an employee and just that isNew field, and then we can also call it with the employee, the isNew, and that onboarded date. We have three ways to call it, and we don't want to be able to call it with this middle way. We only want to call it this way or this way. This is where the idea of function overloads come in. They allow you to define essentially the type definition of what a function looks like. So we can say we have this type of function and we have this type of function, and then we can define a definition that satisfies all those different requirements. So if we look down here, you can see here's our function overloads. We have a format employee, which has just the employee portion being passed along. And then we have the format employee message, which requires all three things to be passed along. So we have our two different ways of defining that particular function. And then finally, all we need to do is actually implement that function, which is what we have up here, is that implementation portion of the function. Personally, this is not something I use too terribly often because it's very complicated to write your code like this, and usually it means that you have a rather complicated function that maybe could be simplified. There are definitely use cases where you need this, don't get me wrong. I've written this before because certain situations need function overloads, but I would say 95 to 99% of the time, you don't actually need function overloads because they add a lot of extra complexity and overhead into your code. So let's take a quick look at what our code is looking like, and we can see that it's going to have some errors that we need to fix. So if we come in here, we have this configure preferences, which is a function that takes do not disturb, and it takes our out of office portion. And then we have our configure preferences down here, which is going to take in all of our different information. So we have our do not disturb, our out of office, and then these optional values as well. And as you can see, a lot of different stuff is happening. So if we look, we essentially want to make sure that it can be configured in one of two ways, by specifying a do not disturb and an out of office. And we mostly have that one complete. You can see here, these should just be Boolean values. So we at least know that this version of configure preferences is correct. And then all we need to do is to specify a new overload to work with this particular function. So we need one that can take in a do not disturb that's a Boolean, an out of office, which is a Boolean or a string. And then we need our use system theme to be a Boolean and our theme to be a string. So I'm just going to copy this over and create a brand new overload for us. So we know that this should be a Boolean. This one should be a Boolean or a string. We have our use system theme. That is going to be a Boolean. And then finally, we have our theme, which is a string. So these are the overloads that we've created. So now when we call this function, we either call it with this definition or we call it with this definition right here, but we can't do any combination of the two. And finally, like I said, you need to define what the actual function itself is going to look like. Generally, when I write these overloads like this, I put them directly stacked above the function. So I would do something like this, where I have overload 1, overload 2, and so on. And then at the very bottom, I have my actual function with all of the different definitions included. Now, the reason that I say that this type of code is kind of fragile and hard to work with is because TypeScript is not smart enough to know everything properly. So for example, up here, if I returned a number instead, and down here, I returned a male preferences, well, the return type here must be a male preferences or number. But TypeScript is not smart enough to know that only this type returns a number and only this type returns a male preferences. So I could accidentally return male preferences here and accidentally return numbers here when I do my implementation. And again, TypeScript is not going to be smart enough to know all of that information for me. So it's kind of buggy in this particular instance. If you mess up your types, TypeScript's not smart enough to fix that for you. So it is one small thing to worry about. Now I want to bring that code back to what we had, and let's actually see if this runs properly. And we can see that it does. So we met all the requirements we needed. Now we finally moved on out of the object section and we're on to tuples, and we kind of looked at this a very small amount when we looked at as const with arrays, because if you have a hard-coded array of values that you as const, it gives you essentially a tuple as the return value. And a tuple is just an array of values that have a specific order and position that they're in. So if we look at this name and age, we have typed this as a string and a number. It is a tuple that contains a string as the first property and a number as the second property. When we were using as const, instead of a tuple that had like a generic string and a generic number, it had a hard-coded value like Kyle and a hard-coded number like 30. But in our case, we're saying this is a name and age, which is always an array of two values. The first one is always a string and the second one is always a number. This is something that may not seem that useful, but is actually used all the time, especially in lots of different libraries. You may have a function that we're going to call, let's just say it's call, func, whatever. We pass it in some random values, and this is going to return to us some values, which is our result. And this result is oftentimes going to be an array of values, where the first value has a specific value, maybe our status, and the second value is something like our data. So we can actually extract that out using this type of syntax right here to get the first value of our array and the second value of our array. And if you're using a tuple, TypeScript is smart enough to know what the status and the data is. I'll show you what that looks like by using this create ticket function up here. So if we scroll all the way down to what we need to do, we need to return a tuple that is going to increment the previous ticket number. So we can just come in here. We're going to return. We want to get our previous ticket number incremented. So we can say previous ticket like that. And to increment it, we can just add this plus plus at the start. That'll increment it before it returns. Then we need to return the comment. So we'll come in here with comment. And then finally, we're going to return a Boolean for if the comment contains the word critical, case sensitive. So what we're going to do is we're going to say comment dot includes, and we can put critical, all lowercase, just like that. Make sure I spell it properly. Critical. There we go. And if we submit, that should work. Looks like we actually have an error. And if we scroll down, the actual reason for that error is because this should be a should be critical. This critical is case insensitive. I read that incorrectly. So the easy way to fix this is we can just change this to lowercase, just like that. And now essentially I'm checking the lowercase version, which should fix our problem. And now we have no errors. So now I want to show you why you actually use this. So let's come in here. We'll say A is equal to create ticket, just like that. And we're going to pass it in a number and a string. Doesn't matter what it is. And you can see A has that return value of number, string, Boolean. Now, if we destructure this by saying that we're going to have our number, this is going to be our string, and this is going to be our Boolean, now our number has a type of number, our string has a type of string, and our Boolean has a type of Boolean. And if we try to actually extract more things out of here, you're going to see we get an error because there's not more than 3 things. It knows there's exactly 3 things with those exact types. This is something that a lot of function and library authors will use to return multiple values to you in a very strict order so you know what you're getting. Now, this entire lesson is all about talking about how a weird feature of tuples is that even though you define this as a 2-value array that has a string and a number, since they're technically just arrays, you can still actually push values inside of them. Let's just copy that code over. And if we paste that in, you'll see we get no errors at all. This name and age now just has this brand new property added onto it, even though it's defined as something that is only too long. So that's a little bit confusing, which is why they recommend that you use the read-only property when you're working with tuples. So we mark this as read-only. You're now going to see we get an error because we can't obviously push new values inside of here. But the downside of making this read-only is that we can't actually mutate it in any way, which sometimes is what you want, sometimes is not what you want. But in our case, we're going to be working around that in this particular example. So here we have a read-only ticket, which contains a number, a string, a Boolean, and then another final Boolean to determine if this is resolved or not. And this is taking in a ticket and we want to mark it as resolved, but you can see we can't modify this ticket. So instead we need to return a brand new version of this ticket. So what I can do inside of here is I can return all of my ticket related information. So I could say ticket of 0, and I could say ticket of 1 and ticket of 2. And then finally return true as my final property. And that essentially is going to return a brand new value because my old value was read only. And if I submit, you're going to notice we actually run into a massive pitfall, which is one of the biggest things you'll run into. As you look at this error, it says our type is string or number or Boolean array, which is not assignable to this tuple ticket type. And that's because when you redefine a value like this, it's just essentially a value, an array that can have any of these values. It's not a constant value, it's not a tuple. So we need to just throw an as const on here to tell TypeScript this actually returns a tuple with this order of values. And when I hover over this type, you can now see it's a tuple as before it was not. So now if we submit, you can see it is successful. Now this little distinction is talking about when you want to use a tuple versus an object, because you could return an array of values or you could return an object of values, and it's both going to work almost exactly the same. The main thing you want to consider is with tuples, the information is in order. The first value is always the first value, the second value is always the second value, and so on. While with an object, there's no order to the specific values. So if you want something to be ordered, it makes sense to use a tuple, while if you don't care about it being ordered, it makes sense to work with an object. The other thing to consider, though, that's not actually in this lesson that I think is really important is that when you are consuming a function, I'm actually going to go back to the last lesson so we can take a look at this. When you're consuming a function, for example, resolve ticket, and that returns to us a tuple of values like this, we know, for example, our first value here is going to be whatever the first type is, which is number, and our second value is going to be the second type, and so on. So when you're consuming this with an array, a tuple value here, you can see we can get the first value and we can call it whatever we want. It's still the exact same thing. But if instead of this function returning an array, it actually returned an object. I'm just going to copy this up. I'm going to come in here with the exact same resolve ticket, but here I'm going to return an object that just has a name, and we're going to give it some string value, it doesn't matter, and we're going to have an age, and it's just going to be some random number just to show the difference between them. We'll call this resolve ticket 2. So if I call resolve ticket 2, this returns to me an object of values. And this object is going to give me a name and it's going to give me an age. So if I only want to get some of the properties from here, it's way easier because if I just want the age, I can just say I get the age. While in this example, if the age is like the third property, well, I need to come in here and I need to skip the first one. I need to skip the second one. Okay, now I can finally get the age as my third one. And oftentimes to skip them, you can just throw in commas like this. This will skip these two, and now I get the third one, which is going to be age. So this is a little bit difficult if we want to skip around with properties, while with objects, we can just get the one we want. Now the downside to doing objects though, is that this name is always going to be age. If I want to rename this to something else, I have to write this extra code to rename it. So depending on how often users want to rename things and how often they want to skip around these values depends again on how you want to implement this, if you want to use a tuple or if you want to use an object. I would say probably 90% of the time I use objects for most cases, but there are specific cases where tuples make a lot of sense because you often want to rename the variable and the ordering really matters because you always want to get the first thing before the second thing and so on. So if we jump back to the lesson that we were just on, essentially this is just a question that's asking which of these would a tuple make the most sense for, and again it's generally going to be an ordered list of things. So if we read through these, a collection of file names, there's really no order to that. A collection of database column names, again, no order to that. A collection of Lane's magic cards, no order to that. But if we look at a collection of LLM input tokens, those matter because if we ask the AI for one thing, and then another thing, and then another thing, those are ordered in a specific order. So we're going to select that as our particular answer. Now this lesson is essentially going through what I just talked about when we were talking about returning tuples to be able to get specific information. We're destructuring those tuples. So you see here we're returning essentially the first name, last name. Those are ordered pieces of information. So we're returning that as a tuple instead of creating a brand new object for that particular information. We can also do nested destructuring. So essentially you can put an object inside of your array that you're returning. So now you can see we have a user and we also have an object. So we have nested stuff going on inside of here as well. So now for our assignment, what value is logged in the second example? So if we look at the second example for what the city is, well, the city here would be Minas Tirith because first of all, we're getting the second property in our array and we're getting the city property. We're doing 2 levels of destructuring. So we're going to get Minas Tirith right here. So we'll just click on that and that was working fine. Now, another thing you could do with tuples that is only for documentation purposes. It has no impact on the compiler. It has no impact on the runtime. This is purely for documentation, IntelliSense, and for you as a programmer is adding a label. Because one of the downsides to using a tuple instead of an object is what is this string? What is this number? What is this Boolean? I don't know what these values mean. So you can add a label when you create your tuple. So here we say that our name is the first value and it's a string, age is our second value, and isAdmin is our third value. So at least have some kind of label to go along with this. So then when you're inside your code and you hover over, for example, this ticket type, it'll tell you this is an ID that's a number, a comment that's a string, and a label that is a string. So it gives us a little bit more clarity on what each of these individual pieces is supposed to be, instead of just having like 4 strings in an array and not knowing which one is which. Now, you don't use this all the time, but it is useful in very specific situations when you want to add a little more documentation to your tuple if it's not self-explanatory. Now in our code, we have some order mismatch that we need to fix. For example, the ID is our first property, not our last property. So if we make sure we put that in the correct order, we should see when we run our code, it now works properly. So this is just making sure we understand how these labels work, and having those labels actually make it easier for us to know what order different properties are supposed to be in. Now, just like pretty much everything else in TypeScript, we have the ability to make things optional inside of tuples by using the question mark syntax. So if we take a look at this tuple right here, we have this HTTP response. It requires a status code, a data, and this error is optional by adding that question mark. So you can see when we use this down here, sometimes we pass a third property, sometimes we don't pass a third property. Now again, optional values must always be last, pretty self-explanatory, just like all the other stuff we've talked about. And they also always union with undefined. So if you have something that's optional, it is always either undefined or whatever value you specify. Now, I don't often use optional tuples. I pretty much, if I have a lot of optional stuff I deal with, I just use an object instead. I can't even tell you the last time that I used an optional tuple, but in specific use cases, they do make sense to use. Now in our case, we just need to kind of fix the different errors and fix the function that's working with this. The first thing is our ID is optional, but it can't be before a non-optional property. Now, luckily for us, we just need to change ID to be required, and we can change our label portion to be optional, which is what it says right here. So if we go to our label, we can mark that as optional. Now, another thing is you may not want to add labels to everything. So instead, if you want to mark something as optional without adding a label, just put the type and then put a question mark afterwards. And now our ticket is going to have a string or undefined as the very last type, as you can see here. So what we can do, we can move that back to having a label because that makes more sense for this code. So we'll come in here with our label just like that. So that solves this step 2 right here. Next step is to fix the function. It should always print an ID because it is required. So here, there's no point in checking to see if it exists or not. And if there's no label, we need to make sure that we print something specific. So we'll just make sure we check to see if that label exists and then print it if it does. So we can come in here. We want to check to see if our label exists. If it does, then we're going to print out this string, and we just need to put a space in the front of it. There we go. Otherwise, we're going to come out here and we're not going to print anything at all. There we go. And let's close that off. And now if we run this, it should hopefully work. And there we go. Now, the final thing we need to understand about tuples is we can actually use a REST property with it. This is something that I pretty much never use, but with a tuple, you can define some required keys, and then you can define essentially a list of things that are optional to go with it. Very similar to defining a function, but instead of a function parameter, this is the array signature that we have. So in this one, you can see we have a name and a scores. So the name is a string that's required, and then we can pass along any number of numbers. So you can see here, Edward has no numbers, while this person has multiple numbers, and this person only has a single number. They give an example here, which I think is quite good, which is a command line tool. So for example, you have a command that is get followed by all the different arguments for it. Same thing with npm, they follow by all the different arguments. So we have a string that's required and then a bunch of arguments that are optional. So for our particular assignment right here, we essentially need to create our own version of this. So you can see the return value from this is always a number and then any number of strings. And we're taking in an input, we're going to split that input on spaces. And the first value we return is essentially the cost. So the number of things that come after the space, and we divide that by 100. So what I can do is I can just say const values is equal to our input, and I want to split that on the space keyword. And then to get the cost, I just take our values, divide it by 100, just like that. And then we can come in here and we want to put all of our values afterwards. So we can say values just like that. So that should essentially solve the entire thing for us. This should just be the length though. There we go. Now if we give that a quick submit, we should see everything working, and there we go. Now, oftentimes in TypeScript, you want to combine together multiple different types to create a brand new type. This is where the idea of intersections come in. And you use the ampersand symbol to do that, which is quite convenient because it's essentially anding together all of our different types. We are saying you are type A, and type B, and type C, and so on. To take a look at a simple example, we have an individual contributor. They contain an ID, a name, and some tasks. Then we have a manager, which contains direct reports. Now we're defining a new type called good manager, which is taking everything from individual contributor. We're ampersanding it together with an intersection with our manager. Essentially, all this says is combine together these two types into a new type that contains everything from both of them. So now you can see we have an ID, a name, tasks, and direct reports for our good manager because it combines these two types into one single type. And essentially, it's the same as if you rewrote the type. So here we have point2d with xy. Point3d is just taking everything from point2d and adding in our new z type, which is essentially the same as writing this out from scratch if we wanted. But oftentimes combining together types with these intersections is something you do all the time. So we're going to create some brand new types, text bot and voice bot, which just combine together support bot with some additional types. So we can come in here. We have our text bot, which we know is going to be our support bot. And it's going to be some other types on top of it. So we can come in here and define all the different types we want. Now I'm getting into some errors because I need to obviously type this as a type. So we have a message log, which is an array of strings. So we'll come in here with a string array. And then below that, we're going to have a send message function. So that's going to be a function that takes a message as a string. So we'll say message, which is a string, and it's going to return a string. There we go. Now let's come down here for our voice bot. That's going to contain everything from our support bot, but now we're going to have a call log, which is going to be an array of strings. We're going to have a phone number, which is going to be a string. And then finally, we're going to have a dial number function that takes in a phone number and it returns to us a string. So now if we submit, we should see that that works. And really the whole point of this lesson is to show you how you ampersand different types together. So now this text bot contains all the types from support bot up here, plus all these new types. And this is something you're going to use all the time in TypeScript. Now I alluded a little bit earlier in the never type, and the never type is something that you may think is completely useless because it's the opposite of any. It literally means this type can never happen. You cannot have anything. It literally can't be any value at all. It can't be undefined. It can't be null. It can't have a value. It is literally nothing. And that may seem useless, but it is very useful in certain scenarios. And one of those is making sure you have exhaustive checks in all of your ifs and switch statements. This is my number one use case for the never type. So if we look down here, we have this handle status code function. It takes in a code of either 200, 404, and 500, and we want to make sure we handle all three of those. And if we pass in something that's not one of those three, we can throw an error to the user to let them know, hey, for some reason, something bad got passed into this function. But you'll notice an error. We didn't actually pass in the code 500. Now, TypeScript won't give you an error, JavaScript won't give you an error. There's no notification that we did not handle this particular use case, but the never type can actually help us with that. If we scroll down here a little bit further, you can see right here, we're taking this error and we're setting the type to never, and we're setting it equal to our code. So now you can see it's giving us an error in TypeScript saying type 500 is not assignable to type never, because essentially after we exhaust all three of these checks, if we had all three of them in place, our code is not 200, it's not 404, and if we check 500, it's not 500. So it means that it never has a value because we've already checked all the specific use cases. So this will give us an error if we forget to check one of those use cases. And now if we check it, you can see we have no error because code at this point is always going to be a never type. So we just need to essentially implement that. And I'm actually going to show you an extra trick that I like to do even better than what they're doing right here. So now let's take a look at what we need to do for this project. We just need to run the code. We're going to have some errors, and then we need to fix the code to fix those errors. So let's just take a look at our code. You can see we have 3 slash commands: greet, info, and help. And we have a greet message, an info message, and a help message. And if the command is greet, we do greet. If the command is info, we do info. And of course, here we have that error. Type help is not assignable to type never because we forgot to check the never or the help type up here. So we can come in here and we can actually do a quick check for that. And that'll at least solve our problem. So we can say this will return our help message. And actually, if we run that right now, we've completely solved the problem. But I want to go a step further and show you that little tip that I talked about. So instead of redefining a variable to never like this, we can actually use the satisfies keyword and throw an error here instead. Now this is returning an error, but in our case, let's say that we wanted to throw an error. We could say we wanted to throw a new error just like this. And we can say unexpected, let me use brackets for this. There we go. Unexpected command. And we can specify what the command is, just like this. So now at least it's throwing an error, but we no longer have that type checking. So for example, if I forgot to include this section, we don't get an error. But I can just come in here and I can say that this should satisfy never. And now it's going to give us an error if this doesn't satisfy never. Right now it does because we're checking everything, but as soon as we forget to check one, boom, I get an error right here because this does not satisfy the never type. This makes it so I don't have to create a brand new variable, and it makes it so it doesn't override any type information. So my command still has this specific type of help, which it should. And this is really useful because right now my code works. If I submit, everything is fine. But if I come up here and I, say, I'm actually going to add a new one in here for error. Now, if I scroll down, I immediately get errors to notify me that I need to update my code to handle that brand new command that I just created, which is why this type of format of never is really useful, because without that, I would have no idea where to change my code to make sure I handle that properly. So this is why I really love that never type. Now, when you combine together types that share properties, you may run into certain problems. For example, here we have Saiyan and we have human, and the name property on both of these is string, so it works fine because they are the exact same type, so it's able to merge them together into one brand new type of a Saiyan human. And if we scroll down, you can see it contains a name with a string, a power level with a number, and an age with a number. But sometimes you may run into issues where you don't have the same type. Name and name here may be completely different, and when you try to intersect them, you essentially get a type that is not possible. If we scroll down, we have another example of that. Here, instead of it being a string, the name for Saiyan must be Goku or Vegeta, and same thing with human, we have specific hard-coded names. But these names don't actually overlap with each other. So when we combine these together, it actually changes the type to never. I'll show you exactly what that looks like. I'll just copy this code into our example, paste it up here, and now if we hover over this Saiyan human, you can see the type is never. So the whole thing has been changed to a type of never, and the reason for that is because specifically our code for name and name is not able to find any overlap. These two properties have no overlap, and since it's impossible to create an object with a name that has no overlap, the entire object itself becomes a type of never. So this is something that you need to make sure you watch out for when you're combining together multiple different types, because if they don't have an overlap in them, you're going to get that never type. Now let's take a look at what we need to do for this lesson to be able to solve it. We can scroll down here. So if we take a look, it's essentially telling us that we are trying to merge together this ticket metadata, which contains our sentiment tag and our channel tag, but this is a type of never because the type here and the type here don't have any overlap. So instead of trying to merge them into one big type, we're just going to keep them as separate types, and we're going to create an object instead. So this is going to be an object that is going to have a sentiment that is going to be set to our sentiment type right here. And we're going to have a channel, which is going to be our channel type. There we go. So now we at least have those two things inside of our object. So now we don't actually overlap them at all. What we need to do is make sure down here that we actually get the proper values. So flag comes from sentiment, so we can get our sentiment property for that. If we look at verified, that comes from our channel. So here we can say channel.verified. We'll just expand this quite a bit. And then finally for our type, we're checking the phone type. So if we look up here, the phone type is specifically in our channel. So let's check the channels type here. There we go. That should hopefully solve everything. If I click submit, you can see it is now working successfully. So this is just a way to avoid that problem where you maybe have different types you're trying to merge together. So instead of merging them together, we're just keeping them separate. So now that we've talked about intersections and unions, we want to make sure we understand the differences between them. And the nice thing is that since they use the pipe symbol and the ampersand symbol, it's kind of self-explanatory the difference. A union is oring together different types. So you can be one or the other or the other or the other and so on. While the intersection with the ampersand is anding together the types, saying that you are this and this and this and this. So one of them combines everything together into one brand new big type, and the other one says you must be one of these different things. You cannot be more than one. You can only be one with no overlap at all. If we look at the example they have down here, we have this human type and we have this elf type. They share some properties and they have some different properties. So if you are a human and an elf, you must have all the properties of human and all the properties of elf. While if you are an elf or a human, you can either have all the properties of human or you can have all the properties of elf, but you can't have any overlap. You can't have this ears property set if you're a human, for example, and you can't have this age property set if you're an elf. So let's go ahead and solve the code for this to be able to make sure we understand how this works. First thing, we want to fix our support agent user, which all the way down here is right here. And this support agent user is a type that represents a support agent or an end user, not a combination of them. It's either or. So we want to use a pipe instead of the ampersand symbol. Next, we can add an export for a new type called support admin that is the same as support agent, but we want the role to always be admin. And then what we want to do is we want to create a support admin type as an option for the support agent user. And we want to update our get ticket count. So let's first of all start with this support admin, which is the same as our support agent. So here's our support agent. Let's create a brand new type. This one is going to be called support admin. And essentially it's every single thing from support agent. So support agent. All we want to do is we want to make sure that we override our role to be admin. Now, unfortunately, this will not work because if we look up here, our role is agent and our role down here is admin. We're trying to ampersand those together. Boom, we're going to get stuck with a giant never, as you can see. So instead, we just need to redefine this entire thing hard-coded, which is a little bit unfortunate, but that's just sometimes what you have to do. So here, we're going to keep the exact same things. We're just only going to get the admin property from it. So now we have our support admin section entirely done. Next, we want to add the support admin type as an option for our support agent user type. So down here, we're just going to add that as one of our options. So we have our support admin, just like that brand new thing that we just created. And finally, we want to update our get ticket count to correctly return the user's assigned tickets if they are an admin. So all the way down at the very bottom of our code, if the user role is equal to agent or the user role is equal to admin, then we want to return their assigned tickets. And if we submit, you can see everything worked properly.
frustrating things in all of programming, at least to me, is when I have two very similar ways to accomplish effectively the same thing. In TypeScript, the type keyword and the interface keyword are often used interchangeably to give defined structure to an object. For example, this type and this interface describe essentially the same object, so which should you choose? First, the bottom line, I prefer the type keyword 99% of the time. And there are a few reasons for that. Number one, I already use the type keyword for a ton of other things, like creating unions or function types, so it feels natural to keep using the same construct. Number two, there's no declaration merging with types, and this is a big one. If you define two different types in TypeScript with the exact same name, TypeScript will actually throw an error saying you've already defined that type. And that's probably what you expect. Interfaces are a bit odd. You can define multiple interfaces with the same name, and TypeScript will silently merge them all into one larger interface at compile time. So this TypeScript code actually results in this. And 99% of the time, that's not what you want. You probably just forgot that you already defined that interface. And using the type keyword would have prevented that unexpected merging bug. Now, to be fair, there are two times when I'll use an interface over a type in real world code. And the first is, I actually do want that declaration merging. I know I said this is rare, but it does happen. The most common example, at least in my experience, is when you need to augment a global type, like the window object. That object already exists globally. But let's say we have a script that adds a property to it. Declaration merging actually allows us to do this. We can declare a new type and add it to the existing window interface. And this only works because we're merging into the window interface that already existed that we actually don't even have control over. So now TypeScript knows that window.google has the type Google. This is actually code that we use in production at Boot Dev to add the sign in with Google feature. This wouldn't work with the type keyword because you can't augment the built-in window type with it, but you can merge into it using an interface. Really, the only other time that I might prefer an interface is when I'm extending it. With the type keyword, you use an intersection to add properties to an existing type, like this. But with interfaces, the syntax is just a bit different. We use the extends keyword like this. Now, they both work just fine, but interestingly, the TypeScript wiki actually suggests preferring interface extends over intersections because it's just a bit safer and compiles a bit faster, which helps keep tooling performance snappy. So I do prefer type in most cases, just with those two little caveats.
Now, TypeScript is a little bit annoying in that they actually have two ways to define types. You can use the type keyword, which we've been doing the entire time, or you can use the interface keyword. Now, they both work almost exactly the same in most use cases, but there are a few minor differences in how you write them, as well as a few minor differences in how they work. And I would recommend you always use types for 99.9% of your use cases, unless you specifically need a feature from an interface, because they do certain things a little bit differently, which I'm not really a huge fan of. And most people recommend using types over interfaces, unless you again need the interface way of doing things, but you can use them both interchangeably in the same code base and they're gonna work just fine. So let's take a look at how we write a type versus an interface. A type works more like a variable. We say we have a type, give it a name, and set it equal to some value. An interface is a little bit different because we use this interface keyword. Instead of using this equal sign, we just write out what the type looks like immediately right after it. So it doesn't quite work as well as like a variable for just reading it because it doesn't look like a variable, but these two things do the exact same thing. They both create a new type in TypeScript that's a superhero type that contains these particular values. You just define one with the interface keyword and no equal signs, and the other with the type keyword and the equal sign. So what we need to do is essentially just practice using these different types of things. So if we scroll down here, we want to create and export an interface called user feedback. So we'll say export interface user feedback. And this has a rating, which is a number. Let me fix my typing here. And of course, as you can see, I accidentally put the equal sign because I'm so used to using types, I almost never use interfaces. And then we have a comment, which is a string. So this is exactly the same as if we wrote this. These two, both identical to each other. We're just going to be using interfaces for this particular tutorial. Then we need an interface named support session. There we go. Make sure I don't put the equal sign like I always do. And then we can come in here with an ID that is a string. Started at, which is going to be a number. Ended at, that's going to be a number. And finally, our feedback is going to be of that user feedback interface that we created, just like that. Now we just need to implement this get session duration, which all it does is it takes in that session, and we just need to return the duration of that in seconds. So what we can do here, scroll this down, and we have our started at time and our ended at. So really all we need to do is just return session.ended at minus session.started at, and that should complete this for us. There we go. Now, when it comes to extending interfaces, it's slightly different than how you extend types. They both result in the same end result, but it's slightly different how you use them. With types, we use the ampersand keyword, while with interfaces, we use this extends keyword. So we say our interface, we pass in the name, and then we say extends, and we pass in what it extends. And if we want to extend multiple things, we just put a comma, followed by another name, followed by a comma, another name, and so on, until we're done extending all the things that we want to extend. In both cases, this code and this code up here give you the exact same result for this wizard. So it works exactly the same. And you can even combine together types and interfaces in the exact same code, and they're going to work just fine. I'll even show you that in the example here, but essentially they're just two different ways to do the same thing. Now, one reason for using an interface over a type is that interfaces are slightly more performant when it comes to large and complicated extends like this. So if you have a lot of different extending going on throughout your code base that can get quite complicated and large to work with, interfaces may be slightly more performant in those particular use cases. But for the size of projects that I generally work on, it's not a huge deal breaker for me. And unless you're working on large enterprise scale operations, you probably won't run into the need for these performance issues as well. And as TypeScript evolves, they make new performance changes. So it may be that types are potentially more performant in the future and so on. So let's quickly look at what we need to do to be able to pass this assignment. We want to create and export two new message interfaces that extend the message interface. We have text message and we have email message with these different properties. And then we're going to update a function. So let's first start with our actual interfaces we're going to create. So we have our message, and then we just need to create two new types, text message, just like that. And this, of course, is an interface. And this is going to extend. So we use that extends keyword, and this is called message up here. So it's going to extend that message type, just like that. And then we need to define what the actual text message properties are, which is a text and a carrier. There we go. I need to do the exact same thing with an email message. So we'll just copy that down. We're going to have our email message, and this is going to have a subject, and it's going to have a body. So at least we have all of our information inside of here. And then we need to update our function. So we just need to make it so that get text message description signature, so they use the new interface you just created. So our email message should use this email message. And up here, text message should be used down here with text message. If we submit that, we can see everything's working. Now I want to show you how you can mix and match these, and it really doesn't make a difference. So if I come up here and I actually change this to a type, we're going to come up here. Message is now a type, and it's going to be used inside of an interface, and I submit. Everything still works exactly the same. That's because when you mix and match types and interfaces, TypeScript doesn't care. Behind the scenes, they essentially do the exact same thing. So you can extend a type or you can extend an interface. And I could make this into a type that is going to be equal to my message ampersanded with these other properties and change this back to an interface. And again, it's still going to work exactly the same because it doesn't matter how you use these things together. You can use some interfaces, some types, combine them together however you want. I recommend in your project, you either use all interfaces or all types unless you specifically need a feature of the other, just to make your code base more consistent to be using one or the other instead of mixing both here and there. Now this lesson is all about extending multiple interfaces, which I already talked about a little bit. And essentially you just put a comma after each interface you want to extend. So to extend all three of these interfaces, you just say character, comma, magical, comma, physical, and it combines together all three of these different types into a new type that also has this other thing added onto it. So we can kind of skip ahead a little bit here to the assignment to try to just solve this one real quick. We want to create and export an interface called Smart Reply Bot that extends the three existing interfaces. So we'll come down here, make this a little bit larger. Export Smart Reply Bot, and that is going to be an interface. And it's going to extend all three of these types. So we have can reply, we have can act, and we have finally can summarize, just like that. And then if we come in here, we read further what we need to do. It says we need to add these properties, name, status, and shutdown. So essentially we're just going to add those three different properties. And of course, we'll want to fix what our code looks like here. So the status, this should be one of these different values. So we'll just union these together. And then finally, shutdown is a method with no parameters that returns a string. So we can just come in here with a string just like that. Now I just got to fix my type error. I just don't have a colon here. that fixes all the different errors. And if I submit, it looks like it's working just fine. So this just shows you can extend multiple things. And again, I can mix and match with types and it would still work exactly the same. Now we can also override things when we do our extending. This is the same thing you can do with types. This is just the interface way of doing it. So we have a character that has a rank, which is a string or number, a name, which is a string, and a level, which is a number. We can extend that character with our wizard, and we can override the rank and say, now it can only be a number for a wizard, and also add some new properties. The only thing is you can't change the type to be something that's not allowed. So here the rank can only be a string, and here I'm trying to change it to a number. That's going to throw an error because I'm trying to change a string to a number, which is essentially the same as doing a never type inside of a type system. So this is with types, this would turn into a never, while with interfaces, it just throws us an error. So let's go ahead and look at actually implementing this. If we scroll down here, we can see that the company uses a system event interface, and we essentially need to take that system event and create some more specific versions like an error event, an outage event, and so on. So let's create this first interface of error event. We can just come down here. We'll say that we're going to export an interface that is an error event. And this error event, first of all, needs to extend our basic event, which we called system event. There we go. And then we need to specify some specific types for it. So in our case, the type is error. We know that the payload here is going to be a string. And then finally, code is going to be a number. There we go. And we just need to create a bunch of different types similar to this. So we also need to create an outage event. So this outage event is a system event. The type here is outage. The payload, if I spell that properly in all of these, here we go. This one has a severity, which is going to be critical. There we go. And then we add a new property called duration. And that is going to be a number. And of course, code I spelled incorrectly up here. And then finally, we need to complete this function, get higher priority events, and we can just fix its signature and so on. So if we scroll down to that function, it should first of all take an array of system events. So this should be a system event array. And then we essentially want to change it so it only returns the system events that have a severity of high or critical. So we can come in here, we can say events.filter, and we can say for each event, what we want to do is we want to return event.severity is equal to high, or event.severity is equal to critical. Now, if I submit that, we're getting some errors, and that's because I did a typo. This should be duration in seconds, not duration. Now, if I submit, you can see that solved all of our errors. So reading the instructions, definitely useful. Now, this is the feature of interfaces that for the most part, I absolutely hate, and is why I generally use types instead of interfaces, and that is declaration merging. If you create the same interface multiple different times, instead of throwing you an error like a normal variable would or like type does, it instead merges those together as if you were ampersanding them all together into a brand new bigger type. So you can see here we define an interface called spaceship with a name. We then define that same interface spaceship and define engines, and we define light speed. That actually creates one interface that combines all three of these together, just like we have down here. Now, if we did this with a type, we would get an error because we're essentially trying to redefine a type with the same name. It works just like a variable inside of JavaScript. If you define a variable with the same name as another variable, you're going to get an error. This is generally what I want. If I define one type and I redefine that type somewhere else, I want to get an error saying I shouldn't be redefining that. I don't want them to merge together because that's going to most likely cause different bugs for me. Now, there is one small case where you want to use this. On the front end of code, you may want to add things to the window object inside of your code, or you may want to add things to the global this object if you're working in Node.js. So you want to overwrite the existing interface of the window to define your brand new window properties. That is the only case where this interface merging is helpful because now you can take that window interface and extend it with your own properties while still keeping it as the normal window interface. So it allows you to merge your new stuff into that existing interface. That's the only place that interfaces actually are useful, and you do that in maybe 5% of all your projects, if that. So let's quickly look at the question here. Why is type often safer than interface? Well, that's because type aliases don't merge together when you redeclare them. So there we go, we have the successful answer. Now in this next section, we're going to be covering enums. And if you want to skip a particular section of this course because maybe it's getting kind of long and you want to just try to get through it, this is a section I would recommend that you skip of all the sections just because enums are not something I recommend that you use. Now I will be covering at the end of this section, enums versus union types, why I don't think you should be using enums. But if you're working with maybe an older code base or someone that likes enums, you may see these. So of course it is important to learn that they exist and what they are, but it's probably the least important thing in the entire course. Now, enums are just a way for you to map between one value and another value with a specific set of values. So if we look here, we have an enum called direction, and direction has values of north, east, south, and west. And by default, enums always value from 0 to 1, kind of like an array. So the value of north is always 0, value of east is 1, value of south is 2, and value of west is 3. Now, if you want, you can create your own values for these. For example, status codes, you can create specific values for them, but they otherwise default to just counting up from 0. Now, when you create an enum, you access it like this. So you can say direction, which is the name of our enum, dot one of these different values, and that'll give you whatever the value is. So 0, 1, 2, 3. So if we say direction dot north, that's going to give us an output of 0. So you can kind of see here we created a nice name that we use inside of our code, and then everywhere else is going to use this number behind the scenes to represent it as like an ID kind of. Now, this is really useful in a lot of languages because they need enums to define this, but with TypeScript, we have such great type support for things like literal values and so on that enums are much less needed, which is why they have other ways of doing enums, which again, I'll cover later in this section of the course. So bidirectional mapping also means that you can convert between one value and another value. For example, direction.south will give me the number 2, and I can say direction and then pass in an array of values, and that's going to give me the value of south. But you may notice something interesting about the code here that's very different than the rest of our code in our application. I've told you that so far everything in TypeScript gets removed when you actually compile from TypeScript to JavaScript. And that's true, except enums are a little bit different because enums actually take your code that looks like this in TypeScript and convert it into some amount of JavaScript code that gives you this type of functionality. So enums are kind of a rare thing in TypeScript where instead of removing your types, it's actually adding new JavaScript code to your compiled bundle. This is another reason why a lot of people don't like enums, because it's now taking this thing in TypeScript and converting it to JavaScript. So there's no longer a one-to-one mapping where you can just remove all the types from TypeScript and it works like JavaScript, because now this is adding this new thing in that converts to some type of JavaScript code. Because if you see down here, I'm actually directly using my TypeScript type, my enum, in my JavaScript code. So I'm kind of blurring the line between what is TypeScript and what is JavaScript. And this is one of the big reasons I don't like enums, because it's weird how that line gets blurred between the two and can be really confusing, especially for newer developers, because normally you're thinking types get removed, JavaScript stays, but this one's different because now the type information is used inside my JavaScript code. So let's go ahead and actually implement this so we can see how these enums work. First of all, we just want to create and export an enum named request severity. So let's just come in here, enum, just like that. Whoops. And it's going to have the values of low, medium, high, and critical. And then we just need to complete this isCritical function, which should return true if it is critical. Otherwise, it returns false. So we can just say request.severity is equal to, and that, what did I call this up here? Request severity dot critical. There we go. So this should return true if it's critical and so on. Now I need to make sure I export this. So let's make sure we throw an export on here. There we go. That way our test can actually pass, and there we go. Now with enums, we don't only need to use numbers. We could use strings if we wanted for the value. So here for our log level, you can see our default value are actually using strings. We're essentially just converting one-to-one between our enum label and our actual value that is used inside of our code here. So we're able to print out like error messages and so on with these different logging information from our enum. The nice thing about this is it's easier to read when you're looking at code. For example, if we just had a number for user type, I don't know what 7 is inside my user type, but if this was a string, it would be a little bit more clear what this is supposed to be. This is actually another reason I don't like enums, because with the way I'm going to be talking about at the end of this section, it actually covers this problem right here where you never run into this weird situation where you have like a 7 for a user type that nobody knows what it means. So let's go ahead and actually solve the assignment here. We need to update our request severity, which is right here. We need to make it so these enums have actual string values, which are not the numbers. So essentially low should be converted to low in all uppercase, and we should do the exact same thing for medium and high and critical down here. This one should just say medium, high, and critical. Whoops, make sure that's capital L. Now what we need to do inside of our function here is we need to essentially convert our severity number into either low, medium, high, or critical. So essentially what we can do, let's make this a little bit bigger. We can say if our severity, actually we'll just use a switch for this. We'll use our severity. There we go. We'll say that in the case of 0, then we want to return request severity dot low. There we go, because that's the first one. By default, 0 is the first one. And now we just need to copy this down a bunch of times for our other cases. So we have case of 1, 2, and 3. And this is going to be medium, high, and critical. There we go. That should solve our case. And if we click submit, looks like we actually have an error. And that's because I, again, forgot to read all the instructions. If the severity number doesn't match, we're going to throw an error. So our default case should throw an error. So we'll say throw new error. and this error should say unknown severity. So we'll just paste that in there. And now if we submit, now it works. Now here is where we talk about this thing that I was mentioning where enums compile way differently than everything else in TypeScript. Instead of just removing the types, it actually compiles down to JavaScript. So this enum right here actually turns into this JavaScript code. You can see it's kind of messy and complicated and adds a bunch of extra weird code into our application to make everything work inside of TypeScript. Now, if we look at how strings compile down, it's slightly simpler. And the only reason it's slightly simpler is because you can't actually convert from a string to the actual label for that. There's no two-way mapping for strings. That two-way mapping only works for numbers, which is why it's much more complicated to work with numbers versus with strings in the compiled code. But this is where a lot of people have problems with enums because now you're adding all this weird TypeScript code that then converts into weird JavaScript code that then is like a barrier between the two. Like when you use your actual type for your enum inside of here, it actually has to convert that to JavaScript as well, which overall just makes things really confusing. So we're just going to kind of play around with that reverse mapping for our assignment. I want to create a new function called getErrorLabel. So we'll say export function getErrorLabel. It should take in an error code, which is an internal error. There we go. And it needs to return a string, but we can just do that automatically with TypeScript's inference. Then it should use reverse mapping on the errors enum to get the actual error name and return a string in the format code followed by name, with code name actually replaced with those specific values. And if the error code is not a value, we return unknown error. So we can just say here that we want to get the value, which is going to be equal to internal errors. And we're going to pass in our error code just like that. And then if our value is equal to null, for example, if the value doesn't exist, then we can return that string, which is unknown error. So I'm just going to copy that into here. There we go. Otherwise, we just need to return, what was it, code followed by name. So we can say return, what is it, our error code, followed by a colon, followed by our value. And hopefully if we submit, that should work just fine. So this just shows that we can do that reverse mapping to get these specific values. So we're getting things like invalid prompt, context windows, and so on. Now, const enums solve some of the problems of enums in TypeScript in that they don't actually add all that extra JavaScript code. Instead, it essentially converts this directly to an object inside of JavaScript. So you can access the values from the labels, but you can't do that reverse mapping that we talked about. So we don't have this ability to go backwards with the reverse mapping using a const enum. Now, pretty much the only reason to use a const enum is to have a slightly smaller bundle size and slight performance gains, but honestly, that's not going to be a huge deal breaker because it's such a small gain that you get from it. So I would pretty much completely even ignore the existence of const enum because you're probably not going to be using enums, and you're definitely probably not going to be using const enums. Now, if we look at the limitations of const enums, you can see here that reverse mapping, you can't reverse map from a value to a name. That's the exact thing. So we're just going to click on that one right there. And we're going to move on to what I think is the most important lesson in this entire section. And if you skipped ahead, this is where you want to come to, because this is talking about why you probably don't actually want to use enums.
We're at another one of those classic crossroads where TypeScript gives us two nearly identical ways to do the exact same thing. And that's enums versus unions. Take this simple string union type. Cardsuit equals one of these four strings. Awesome. But it turns out there's another way to do basically the exact same thing, and that's with the enum keyword, like this. Now, bottom text, I don't use enums. I'm showing them to you because you might find them or happen upon them, but I don't recommend ever using them. Even Anders Heilsberg, the creator of TypeScript, said that if they were gonna start over with TypeScript from scratch, they might not even include enums that second time around at all. So why is that? First, unions are already part of TypeScript, and we use them for more powerful things than just enum-like code. For example, discriminated unions like this. And that's when two similar types have a single property that can be used to easily discriminate between them. But unions aren't just useful for this complex stuff, they handle the enum-like use case just fine. Second, enum types are entirely erased during compilation. They don't add any additional JavaScript code to your bundle at runtime. Enums, on the other hand, are real JavaScript objects that do get emitted to your final bundle. And that does introduce some, even though very small, overhead and complexity. Last, union types are just easier to write. Compare these two examples again. The union version is much shorter and simpler and uses the type keyword that we're all already familiar with. So I avoid enums in most cases.
So I mentioned how enums and unions are very similar. We have an enum right here for a card suit, hearts maps to hearts, diamonds, diamonds, clubs, clubs, spades, spades. And now I have a card suit type, which is a union of hearts or diamonds or clubs or spades. These two are essentially the exact same thing inside of TypeScript. It's just how you use them that's different, which means all that extra JavaScript code that this comes with is not really that important or needed because you use these pretty much the same way. instead of using the hearts dot whatever or cardsuit dot hearts, here you would just type in the string hearts. And that's going to work fine throughout all of your code. So you get the exact same results from using enums versus using this style syntax. But I find this style syntax much easier to work with. You don't have that weird number mapping. You don't have to worry about defining the exact same string as the value over here. Everything is just so much easier to work with, in my opinion, using these unions over using these enums up here. Now, technically, there are some pros for enums in that it's slightly easier to refactor is what they say, but for the most part, if you're working with a modern editor, you can hover over any variable and rename it. Usually the keyboard shortcut is F2, and that'll rename it everywhere in your code, so you don't even have to worry about that easier to refactor part. That's actually solved for you by most modern editors. And we have the ability to reverse lookup things, but in my case, when I'm using enums, I have the value and the label exactly the same, so I never need to actually do that reverse lookup. Really, there's not a single pro that I can think of when working with enums in real actual code bases, so I would just stick to unions every time because they're much easier to work with, it's consistent with everything else in TypeScript, and you don't get that weird extra TypeScript code, or JavaScript code, I should say, added onto your bundle. Now let's go ahead and actually do the assignment for here. We are refactoring this code and we're converting the enum into a union type. So what we need to essentially do is take all this enum related stuff and just remove it. So we'll get rid of all of that, get rid of this enum. This is now a type. Then we can come in here with an equal sign, and we just need to make sure that instead of an object, this is just a union. So we're gonna have free, or, and then change that to a pipe, that to a pipe, and that to a pipe. And there we go, that completely solved this portion. Now down here where we're calling API tier.free, we would just use the text of free, for example. Same thing here, this would just be the text of basic. This would be the text of pro. And then down here, we have the text of enterprise. And that should solve all of our different problems. I just have an extra pipe here, but now if we click submit, you can see everything is still working like it was before. So this is a really useful tool to be able to just use essentially this union type instead, because it's much easier to work with. And overall, I really prefer this way of doing things over enums. Type narrowing is something we've kind of already looked at, in that TypeScript is able to be smart enough to know what your type is as you start to narrow it down based on different things. So this is a discriminated union of regular customers and premium customers, and we're able to narrow that down. If we look at here, we're using a discriminated union that has a type of either Witcher or Star Wars. And if we look at the code, you can see if player 1 type is Witcher and player 2 type is Witcher, we now know in the code as TypeScript that player 1 is of type Witcher character and player 2 is of type Witcher character. TypeScript is smart enough to know that because we did this level of type narrowing. So it's kind of something we've already looked at, but we haven't given it a formal name until now. And this is one of the superpowers of TypeScript, to just kind of automatically figure out what everything inside of your code is. It is magical once you finally start getting it to work. So this allows you to just automatically narrow those types down, because this fight Witcher function expects a Witcher character for both of them, and TypeScript's smart enough to know that if you get to this point in your code, they are going to have that Witcher character type. Now, if we look at our assignment here, we have two plans, the regular premium I've already talked about, and regular customers have a limit. And we need to look at the open ticket function and notice that its current state produces a compiler error. So you can see here, customer.aboveLimit is throwing a particular error for us. We just want to fix that bug using type limiting. So here we have a regular customer that has the above limit and a premium customer that doesn't. So we can really easily solve this by just coming in here and saying customer dot, and I believe it's called plan. So if the plan is equal to regular, then we also want to check to see if they are above their limit, and this is called customer. This right here should be all we need to do. Let's just submit and see, and it does actually work. The reason this works is because first we check, is their plan regular? We now know their plan is regular, which means they must be this regular customer type. So when we get to this point, our customer is always a regular customer, which means above limit exists. So TypeScript will not only narrow inside of if statements, but it will even narrow within the if statement itself as we go through and along the if statement. It's super powerful what it can do. Now, an often confusing type for people with TypeScript is the unknown type, because it's very similar to the any type, but they have very distinct use cases for when you want to use one or the other. Essentially, the unknown type tells TypeScript that you don't know what the type of something is, but instead of allowing anything to be passed to it, the unknown type is super restrictive and requires you to type check every single part of that type before you can use any part of it. So for example, let's just come in here with a constant variable a, and we're going to type this as unknown, and we'll just come in here just like that, and then we'll come in with another variable b, and we'll type this as any. Now, if I wanted to use this a variable, we'll make it a let, so it actually lets me define these. There we go. So if I wanted to do something with this a variable, like let's say it's a string, I may want to do like a.to lower case. But if I try to do that on an unknown variable, I'm going to get an error because a is of type unknown. It can't do anything with it. Unknown does not allow you to do anything at all. While if I were to do this with B, it's going to work just fine because B is of type any, which means you can do anything that you want with it. In order to actually use this A type, we need to narrow it down to some other type. So I could say if type of A is equal to string, well, now I can all of a sudden access the tuple lowercase property because it knows that A is of type of string. So unknown essentially tells TypeScript, I don't know what this thing is, and I don't know how to process it. You need to narrow it down to a specific type to be able to use it. And I would say anytime that you think you should use any in the case of writing TypeScript code for the first time, you probably want to use unknown instead because it's going to be just a little bit better for type safety, because instead of allowing you to do anything, it forces you to make sure that you check the type of something before you actually use it. I like to think of any as essentially turning TypeScript off, while unknown just says, I don't know what this thing is, so I can't give it a type, but I still want to use type checking inside my code. Now let's get rid of all that code from this example and go back through here. You can see the problem with any, as they say, is it allows you to do pretty much anything, even if your type is actually incorrect. And unknown forces you to check what that type is. This is actually very similar to the example that I just did. It forces you to check that specific type before you use it. Now, oftentimes you're not going to be using unknown inside your code anywhere, but whenever you're trying to access data from like an API, you get back data and you don't know what the response type of that data is, that's a great place for you to use unknown instead of any, because you don't know what that type is. So you just throw an unknown on there, and then you can use some type narrowing to actually narrow that down to the correct type that you want. But I would say 95% of the time, you're probably not going to be using unknown in your code very often. Now let's go ahead and actually see what the assignment wants us to do. We can see here, this function is going to receive unknown. And if it's a string, we should come in here and use this information. And if it is an array, we need to do some other information with it. So the first thing I want to do is I want to check, just see if input type of is equal to a string. Well, then what we want to do is source should be email and content should be the string. So I want to return an object. Source is going to be email. Whoops, and content is going to be our input. And if I make sure I spell return properly, that should clean up all those different errors. Then I can come down here and do essentially the exact same thing. If the input is an array, then the source should be chat and the content should be that array joined together with a new line character. So let's do that. We'll just do a little check here. Now, unfortunately, we can't just do the type of is equal to array because that's not an actual type, but we can use the array.isArray function to be able to check to see if something's an array. This now says that this input is of type array. And now I can do import.join, and I want to join on that new line character, and that's going to solve that error. Now we can come down here. Otherwise, source should be the string unknown, and the content should be an empty string. So we can just say at the very bottom, we can return an object, and this one is going to have source of unknown, and the content is just an empty string. That should actually solve all the different problems. I don't see any type errors. And if we submit, it looks like we actually do have an error. I took a quick look at the error message, and that's because when we have an array, the type should be chat right here. So I just need to change this to chat. That was just my bad. Again, not reading the question all the way. And there we go. You can see that that now is correct. Now we've kind of covered this type hierarchy a bit, but I really like this diagram right here. And we can see at the very top of this diagram, we have the widest possible types, the types that encompass literally everything that you can do inside of TypeScript. For example, the unknown, we don't know anything about this type. It could literally be anything, and any is obviously anything. And as we start going down this, we get more and more specific types. So for example, from unknown, we now have a number, a Boolean, a string. From a number, we can go to a specific value like 69. And then at the very bottom of our graph, we have never. A never type is essentially a type that can never happen. There's no way to use it. It's impossible for this to have any specific type. Great for like error checking and stuff that we talked about earlier. And this is the narrowest you can possibly get. You've essentially narrowed down your type to the point where there is no more types left. So this is a really great hierarchy of kind of how that different type narrowing works. And this example that we're going to be going through essentially is an example in all of this different hierarchy. So the first thing we need to do is this respond to sentiment function. We want to make it if we have a positive input that we use handle positive. If we have a negative input, we use handle negative. And if the input is anything else, we just return this specific message. So first of all, what we can do is we can say if the sentiment, and the sentiment here to be positive either needs to be happy or satisfied. So the sentiment, we'll just do this actually in a switch statement because I think that'll be a little bit easier. We'll do a switch on our sentiment just like that. And we want to have a case. And the case for our sentiment is going to be happy. That's going to be in our positive sentiment. And we also need to have the case of satisfied. There we go. And I just need to make sure I put my colon right there. And now we know that this is a positive sentiment. So we're going to use handle positive sentiment. And we're going to pass along our sentiment. There we go. And we just want to make sure we return that. And the nice thing is this sentiment is properly typed as either happy or satisfied, which is our positive sentiment. So we know that it's correctly in that positive sentiment. we can copy this down and essentially do the exact same thing, but this one is for dissatisfied and angry. So I'll use angry here, and we'll use dissatisfied here, and that should be handle negative sentiment, and that should get rid of all of our errors that we have. And then we're finally going to have a default case. And in our default case, we just want to return, let's see, it says we don't understand. And actually we just return that as a string, I believe. There we go. And that should solve all those different problems. Actually, it needs to be in this response, which has a message and a notify. So message is just that. And then we can come in here with a notify, and that is going to be true. There we go. And actually, yep, the notify is a Boolean. There we go. That cleaned up the entire respond to sentiment. Next thing is handle positive sentiment. So we need to handle this by breaking it up even further. So we're essentially going to do a switch statement again. And actually, it doesn't really make sense to do a switch statement because we only have 2 values. So we can actually just do this with a ternary, which is even going to be easier. So if our sentiment is equal to happy, well, then we want to do whatever is in this happy example here. So we're going to return an object where the message is equal to hooray, and we're not going to notify. So we'll say notify is equal to false. Otherwise, we're going to return a new object in the case where it's satisfied. So we're going to have a message here that says we are glad, and then we don't notify again. So we'll say notify is false. There we go. That's all the code we need for our positive sentiment. And now we can move on to our negative sentiment, which is pretty much going to be the exact same thing. So we'll come in here. I'll make this a little bit wider so it's easier to see. And we just need to look at what the messages are going to be. So in the case here, we can say we are sorry if it is dissatisfied. And so we'll say dissatisfied. So we'll say we are sorry. We're also going to keep notify as false. And then here we want to do a re-apologize, and we want notify to be true. So we'll come in here, we'll change notify to true. That should be cleaning up all that, and we can see we've just slowly narrowed our type more and more throughout doing all of this different code. Now if we give that a submit, we are getting an error. That's just because I forgot to put a period here. There we go. Now if I submit, you can see everything works successfully. Now here we're going to talk about a little bit more of an advanced type of narrowing, and that is narrowing using this in keyword. And this is something that's built into JavaScript. It's the ability to check to see if a property exists on an object. So we have an object message, and we're checking, does this message have a content property? And we're able to actually narrow our types because if you look at our types, only one of our types has a content property. So TypeScript knows it must be this property because that's the only one that has content. So we know at this point, we have a text message variable. Same thing here when we check for caption. And then down here, we know that it's not these other two. So it must be our third option, which is video message. So it's a really easy way for us to narrow down based on the properties of an object. This is actually quite similar to discriminated unions, as you can see here. If we have an exact kind, we can specify that instead. And generally, if you're creating your own types, I recommend using a discriminated union over the in-check, because the in-check is not always perfect because you may have certain overlap. For example, these all have a sent at. And if we had other things that were overlap between them, it could be more complicated. And as you change different names, for example, you change this from content to text, now all of a sudden all your code breaks. So it's a little bit complicated to work with. So if you can, I recommend writing your code as discriminated unions, but sometimes you're using types from third-party libraries or other code that you can't change, which in case using this in keyword is really great. And again, it's just a JavaScript feature that TypeScript hijacks to be able to narrow down the different types. Now let's go ahead and actually look at what we need to do for this particular assignment. So here you can see if we have an image, we need to return this particular string. If we have a document, we need to return this string, and so on. So I'm just going to copy over this string and we'll start implementing this function first for the image portion. So we want to process our attachment. We can come into here and we can say if we have a width or a height, so we'll just do width. It doesn't matter which one we do because those are both unique. So if width is in, and what is this called? Attachment. There we go. Now we know that our attachment at this point, if I just type this out, is an image attachment because it's the only one with a width. Well, then we just want to return that string. So we can just paste in that string and we can replace these particular variables right here. So let me just come in, clean this up a little bit. And we know that this should be our image dot size, or actually it's attachment dot size, attachment dot width, and attachment dot height. And I believe this is called file size. There we go. That should clean all of that up. So now we can essentially do the exact same thing, but move on to document. I'll copy over the text that we should be using. Essentially it says attached document. It should have the size. So this should be document. It should have the size, and then it should have pages instead of dimensions here. So we'll just change all of that to pages. And instead of checking the width, we want to check the number of pages because that's the thing that's unique to our document type up here. And we can just use that pages section in here, which is attachment dot number of pages. There we go. And then finally, we can do a simple return that just says attached and whatever the file size is. So really we can just copy all of this over and hopefully just return that like this, and it should work just fine. Let's click submit. And of course, it should say attached file instead of attached document. Again, more copy paste errors. And now when we submit, it's working. Now, type predicates are a quite advanced feature in TypeScript that you mostly won't have to use, but in certain instances, they become very powerful. And that allows you to create your own type narrowing inside of TypeScript. So we've used things like type of, instances of, and in keyword to narrow down our types, but sometimes that's not enough and TypeScript still doesn't know what you want to do. And in those cases, you can write your own type predicate, which is a fancy function that works as a narrower. So if we look here at a function called isString, this takes in a value. It can be any value, it doesn't matter what it is, and we're narrowing that type down. We're saying that the type of this value is equal to string. If this function returns true, then TypeScript is going to automatically convert our type to string, and it does that through this value right here. Instead of specifying a return type for our function, because this returns a Boolean, so instead of saying this returns a Boolean, instead we specify that what this value is going to be is a string. So if this function returns true, value is a string. So we're essentially telling TypeScript to narrow our type down to a string if this function returns true. So you can pass it in any values that you want, it doesn't matter what it is, and you're able to map those values to something else. If we look down here a little bit further, we have this particular example. We have a manager admin, which access level and a number of employees. We have an admin that has an access level and a payroll date, and a manager, which has a number of employees. You can see a lot of these properties overlap. For example, number of employees overlaps between these two, while access date or access level is in between these two. So there's too much overlap to do narrowing the normal way. So we can create our own function called isManagerAdmin. It takes in a boss, which is one of these three different levels, and we're essentially checking to see if it has these specific properties. We now know that it is going to be a manager admin because it contains both of these levels of properties. And we're telling TypeScript, hey, the boss property we passed in is a manager admin. So essentially, if this returns true, then TypeScript narrows your type to this specific type. Now we're going to go ahead and go through this assignment, and then I want to talk about some catches that you have to worry about with these type predicates, because if you write them incorrectly or not great, it can be a huge detriment to your actual code because you're kind of overwriting TypeScript's default behavior. So the first thing we need to do is we need to create the actual type predicates. Essentially, these two functions are type predicates, but they're not doing the type narrowing because we need to specify that it is going to convert this value. So we're going to say model is, and this one is the skippity model, which is called model skippity. There we go. So we're saying that it's going to narrow down when we call this function. Same thing here for this gene version. It's going to narrow down to the model gene version. So now we at least have the narrowing part done. So when we call these functions, it will properly narrow. Let's look at step 3 down here. We need to complete the activate modal function, or model, sorry. If the given model is skippity, then we need to return a specific string, replacing some values. Same thing here, we replace a specific string. So I'm going to come in here and I'm going to try to implement this. We'll just say if, and we want to check the model, and we'll say is model skippity. There we go. And we'll pass it in our model. So now we have that type narrowing. So if I try to access my model, I should get only the properties from skippity. And what we want to do is we want to return that string. So I'll paste in that string, and we want to get a version, and we want to get a status. So we can say model.version, and with search, and we can say model.search, I believe is probably what we need to pass in there. Let me just read the documentation to make sure. Status is either enabled or disabled based on the search property. And if we look up here, search is a Boolean. So we essentially need to just change this value here. So search is either going to be enabled or disabled. Next, we essentially need to do the exact same thing, but with this particular string for this gene model. So we need to do another if check here, and we're going to come in here and say this is the gene model. So now we know that when we're inside our code, this is the model gene, and this is going to take in a status that's enabled or disabled based on the think property. So we have a think property here that's going to be enabled or disabled, and it should say activated model gene, and it should say with thinking. There we go, enabled or disabled. Now, when I run this, you can see everything's working, but I want to show you one of the huge pitfalls of using these types of type predicates. Let's say, for example, I wrote my code incorrectly. Either I failed to do all my proper checks inside of here, or maybe I actually returned the wrong type here. Let's say I actually returned model gene here. TypeScript is not smart enough to know I made this mistake. It just assumes I said this is a model gene, it must be a model gene. And now down here in my code, it's essentially, since I have this model skippity here is returning the model gene, it thinks that this is a model gene. You can see right here the model gene type. So it doesn't have my type safety. Even though we know that this is a skippity model, it's not the gene model, it still doesn't know that because I accidentally made a mistake in my code. So if you make a mistake in your code like this, it makes your code really hard to work with, because now when you call this function, it's actually going to give you incorrect information, but you don't know that when you're using it. So I would make sure that when you're writing these types of functions, not only are you very careful when you write them and you use them sparingly, but also make sure that you have really good testing around these functions to make sure that they do exactly what you expect, because if you have an error in this function, it can propagate throughout your entire application, ruining your type safety. Now this section is talking all about exhaustive checks, which is something we've already kind of looked at before. Imagine you have a switch statement that's going over email, SMS, and push. And you can see here we're doing all those different cases. And then down here, I have this other return that should never be hit, because we know for a fact that our notification is always email, SMS, or push, which is already all checked by these three. So this is unreachable code. So we want to make sure that we actually get errors when we specifically reach this type of code in TypeScript. And we kind of looked at this where we were using like throw error as the default case, and we were using that satisfies never to give us that particular error checking. So this is just kind of recovering the stuff that we've already talked about a little bit. And if we go down to this assignment, it says the increment count function is working as intended, but someone committed an unnecessary default case that throws an error. So if we look at our code, we'll just bring this over. We scroll all the way down to increment count. You can see we have this chat.topic, and our chat topic is either question, complaint, upgrade, or refund. And we're checking all four of those right here. And then we have this error down here, which is actually giving us an error because it's unreachable code, because we know that our chat topic is always going to be one of these four. It'll never actually get to this code down here. So we can just remove this because we know we don't need that code. And honestly, what I would personally do is I would just come in here with a default case, and that's where I would put my error, because this allows me to always make sure that I actually get an error inside of TypeScript if I add a new topic. For example, I could just say satisfies never, like we had talked about before. And now if I add a brand new topic up here, for example, doesn't matter what it is, I'll get an error down here saying I still need to implement that topic, while if I have everything implemented, I no longer get any errors. And if I submit, you can see our code is working. Now, guard clauses are something I've been using very heavily throughout this video, as it's my preferred way of programming for most checks. And essentially what that means is that instead of checking for something and then doing code inside your if, you instead check to see if something exists, and if it does, you return or exit out of a function early. So in our case, you can see our name, if it's null or undefined, we just return an empty string to immediately exit out of this function as quickly as possible. Then when we get down here, we know that name is a string, because if it's null or undefined, we already returned, so TypeScript knows it can't be null or undefined at this point. So guard clauses are a really great way to be able to do that type of type narrowing. Now you could do it by checking in reverse. You could say if name type is a string, then do particular code inside of here. Both of these are going to work, but I find that guard clauses usually result in slightly cleaner code when you're writing out your code. And the nice thing with guard clauses is also, if we throw an error instead, it still narrows our type. So it doesn't matter if we return or throw an error, it'll know that if we got to that point, we are either null or undefined. So we know if we're past that point, we can't be null or undefined, and the only option left is string. Now we go ahead and actually use guard clauses in our example. Let's look at what the assignment wants us to do. We want to complete this function, and we can add some guard clauses to narrow the undefineds away. So if the rating is undefined or it is not a valid rating, use the helper predicate function. We can return the string, give a rating between 1 and 5. So let's go ahead and do that. That's going to be in the handle feedback function. So we have handle feedback that's taking in some user feedback. And if our feedback dot rating, I think we have an is valid rating. Yep, we do. So we can say if the feedback rating is equal to null, that'll check for null and undefined at the exact same time, or is valid feedback for our rating. If it is not valid feedback, so we'll pass that in just like that. And we want to make sure we use our feedback here. So if our feedback rating is not valid or it is equal to null, well, then we know that we have a problem. So we need to return this string right here. There we go, give a rating between 1 and 5. Then we can check to see if the email is undefined or it doesn't include an @ then we can return the string provide a valid email address. So we'll do that in another if check here. So if the email is equal to null, or, and of course we can say email username here. Yeah, we don't need to worry about any of that. We can just check to see if feedback.email.includes an @ there we go. So if it does not include an @ then we can return that text provide a valid email address. There we go. And that should hopefully solve all of our problems. We can just click submit, and it looks like it is working fine. So again, this is just another way of doing type narrowing, and what I've pretty much been doing throughout this entire video. Now inside of TypeScript, there's a lot of ways that you can mess yourself up, but there's a lot of ways that TypeScript can mess up and not know enough, and you know better than TypeScript. And that's where the as keyword comes in. The as keyword essentially allows you to tell TypeScript, you're not smart, I know what this type is, I'm going to tell you, and you just have to trust me that I'm correct. So you can essentially tell TypeScript, I know that you think this is a certain type, but I know what the type is, and now you just have to trust me. So what we can do if we scroll down a little ways is you can see where we're taking in this user ID, which could be multiple different things, and we're specifically telling TypeScript this is a string and nothing else. Let's come in here, we're gonna say that const a it's going to have a type here. Actually, let's just make it a let variable. It's going to have a type of string or number, just like that. So if I try to use I can't access like to lowercase or anything like that because it is not a string. But I know for a fact that this is a string. Let's say that I just know when I get to this point in my code, it is a string. Well, I can tell TypeScript a as a string, and now it's going to essentially assume that this a variable is a string. And I can access all the string properties such as to lowercase on this particular string. Now the problem with as is that if I'm wrong and actually a is a number at this point, it's going to throw an error in my code when I run it, but TypeScript will not give me an error. So it's a potential source of errors, which is why I generally try not to use as very often. I'd rather just do a simple type narrow of just saying if type of a is equal to, a string, then I can particularly do my code inside of here. So this is a safer way of doing this exact type of check, in my opinion, because now you're actually making sure TypeScript is properly checking everything inside your code and that it's going to run properly even if a number gets passed in, for example. It's just going to skip everything related to the string. There are a few rare cases where you know for 100% certainty what the type of variable is though, and type narrowing it is going to be overly cumbersome. In those cases, doing a simple as cast is perfectly fine, but again, I try to avoid them as much as possible inside my code. Now let's go ahead and look at what the assignment actually wants us to do inside of here. Oh, also, I guess one thing I should mention is technically you can use this angle bracket syntax in order to define as. So if we go back to our code here, instead of doing a as string, I can write string inside of angle brackets like this and then a. That's going to be the exact same code. I have never seen anyone in my entire life write their types like this for the as casting, and I find it way more confusing to work at because angle brackets in TypeScript have a very specific meaning for generics, and overall, I've never seen anyone do this. I've never done it myself, and I would recommend not doing that. So let's actually go ahead and look at what the particular code wants us to do. Inside of our assignment, we're using a third-party service for handling payments, and although we can't have type safety on incoming data, we do expect that it comes in a consistent format. This is a very common use case for where you may want to use as because you know what the data looks like and it's complicated to do the type checking for it. So we're going to fix this function by asserting the order response is in fact some order data and leave the type unknown in the signature. Okay, there we go. So what we can do here is we know that this order response is specifically of our type order data. So we can just say we're going to cast that to order data, and that essentially overrides all of TypeScript's type checking. It's almost like using any, but instead of saying it can be anything, we're saying it is specifically this value, but we haven't actually asserted that other than telling TypeScript that. There's no code that's making sure this is correct. We just tell TypeScript, trust me, and hopefully it works. So let's submit and see if that works. Looks like it does. And in some cases, this is okay to use, especially when you're dealing with like APIs and things like that. Now inside of TypeScript, something you have to watch out for that they actually warn you about is if you have something that's, for example, a number that is 42, it can never change. There's no way it can be anything else. And you try to cast that to a string, TypeScript's going to throw a warning like, hey, this is a number. I know this is a number and it can never be a string. So we're going to throw an error. But if you want to get around this, for some reason, you may have a use case for getting around this. You can first cast to any other type, such as unknown or any, or literally anything else. Usually unknown is what you're going to cast to. And then from there, cast specifically to your type that you want, which is in our case, a string. This gets around that problem because you're telling TypeScript, okay, this ID, it's actually unknown. And since unknown is a broader type than number, it's okay with doing that cast. And then we're saying, okay, we're going from unknown to string, and TypeScript is okay with that because it forgot that this was a number because it went from a number to unknown and then from unknown to a string. Now, if you see this in the wild, it's probably not a good thing. I mean, I've never actually written code like this in real code bases. I've written this in like certain testing situations when I'm trying to debug things, but I have pretty much never seen this inside of production code bases and never actually written this code in production code bases myself. Generally, it's not something that you see that often, but it is important to know what it is because you may run into it, and you just have to hope that whoever wrote this knew what they were doing because oftentimes they're really getting around the TypeScript system. And you're most likely going to see this when you're either integrating a library that has really bad TypeScript support and their types are actually incorrect, or if you're converting a project from JavaScript to TypeScript, you may have to do these weird kind of hacks. So let's look at the question here. Why is double assertion usually a bad idea? Because you should have used OCaml. Well, we can skip that. Because of a potential assertion to incorrect types causing runtime errors, that sounds correct. Because it's rude and because it results in slow compilation. So yeah, it's entirely because it could be incorrect. And it looks like that is the correct answer. Now, another type of assertion we can do that goes over the head of TypeScript is a non-null assertion. That's this little exclamation point syntax. If you have any variable inside of JavaScript or TypeScript and you put an exclamation point after that variable, you're telling TypeScript that it is no longer optional. It is required, it cannot be null, and it cannot be undefined. So if we look at the code here, we have this cleaned text, which is either a string or null. And down here, we're putting a little exclamation point after this to tell TypeScript this clean text is actually not null. It can never be null. It's always going to be a string. And this is something that's very similar to as, where if you use this, you are overriding what TypeScript actually thinks can happen. So instead of actually checking this yourself with like, is this null checks and so on, you're just telling TypeScript, I know more than you, just trust me on this one. And again, you run into all the same problems you do with as, because maybe this is actually null and you didn't actually check it. You just told TypeScript it's not, and now you're going to run into runtime errors. So I would recommend if you do something like this, it's way easier just to throw in a simple if check to say, if it's null, do something else instead. I would almost always result in actually checking if something's null rather than using this exclamation syntax, especially because checking for null and undefined is really easy. I mean, it's a single line if statement. That's how easy it is to do. So let's look at the assignment for this one. We need to write some code that pulls some data from the customer orders. We need to complete the sum orders function, which takes in an array of order data and returns a sum, and complete the report orders function, which calls all this information. So let's first of all work on sum orders, because that should be relatively straightforward. So we're going to come in here with sum orders. It's going to return our orders. We're going to reduce that down just like this. This is going to take in our sum and our current order just like that. We want to default this value to 0. And then I just want to return our sum plus our order dot, and it looks like amount is probably what we want to get from there. So that just sums up the amount of all of our different orders. And of course I spelled this incorrectly. There we go. If I type that as order, we can now see sum orders is at least implemented correctly. Now we need to complete the report orders function, which calls some orders on the orders, asserts that the given orders aren't null, but don't change the function signature, and then we can return the string total amount for orders with that information. So down here on the report orders, we can just come in here with some orders. We'll just call it some orders. We're going to pass in our orders. And again, this could be null. We're just going to override that with TypeScript by using this assertion right here. And we want to return this particular string. So I'm going to copy that over, return, paste in that string, and we want to replace the sum section with our sum orders. There we go. That should hopefully be everything we need. If I just make sure total is in there, we click submit, it does look like it's successful. So again, we're overriding TypeScript by using that exclamation syntax. I would prefer just to do a simple if null check at the beginning, but again, this is for very rare cases where you 100% know that it's not going to be null. Now, classes in JavaScript are something that on their own, I don't find that useful, but as soon as you implement them into TypeScript, I find them to be infinitely more useful because TypeScript adds all the things that most other languages have in classes into JavaScript, which makes them much more enjoyable and easier to work with. The nice thing though is that the syntax for defining classes is pretty much exactly the same in JavaScript and TypeScript. We just have the ability to do extra stuff with these classes by adding different type-related information. So if we look at our class for hero here, if we ignore the section right here at the very top and ignore like the types for the actual parameters of our functions, you'll notice it looks just like a normal class inside of JavaScript. Really, the only difference is that we define what the types of all of our different properties of our class are directly inside of the class. Usually it's the very first thing you do inside your class. So you can see here we have a names with a string and a health that is a number that is directly inside of this class as our two class properties. And then we have the functions down here for our class that work just like they would inside of JavaScript or TypeScript. It's essentially the same. So really that's the only thing we need to add to make our classes work inside of TypeScript. Now, as we go through this section of the course, we're going to see a lot of stuff related to classes that are really cool, but creating basic classes is relatively straightforward. So what we want to do is we want to create a customer class that has two string properties, first and last name. So we'll say first name right here is a string, last name is a string. Then we just pretty much wire everything else up with normal JavaScript. So we can say this.firstName is equal to first name. Could do the exact same thing with our last name here and here. And then we just need our get full name function, which is just going to concatenate those together. So we'll say this dot first name and this dot last name. There we go. And hopefully if I did everything correctly, we run that and you can see it works just fine. Now inside of JavaScript, a few years ago, they added the ability to create private members, which is useful because that's one of the huge things that classes were lacking. So essentially, I can create this ID, which is private, which means I can access it inside my class, but I can't access it out here. I'll get an error if I try to access it out here. And TypeScript actually looks at this and it knows that this is private and it'll give us a proper type error anytime we try to access a private property from outside of the class that it's defined in. So if we look at what the assignment wants us to do, we want to add a private balance number inside of our customer. So we'll come in here. We're going to say that that starts with that hashtag symbol and the balance is going to be a number. Then we can say here that our balance is equal to that balance property that's being passed in. And finally, we want to complete this purchase function down here, which subtracts the cost from the balance and returns the new balance. So we could say this dot balance is equal to, and that must have that symbol at the start. There we go. This dot balance minus our cost. And then we can return I think it just wants to return the new balance. Yep, so we can say balance just like that. There we go. And now if I run this, we are getting some errors. That's because I forgot to put that hashtag symbol at the start of balance up here inside of our constructor. Now if I run though, it does look like it works. Now, one thing that I believe we're going to be talking about later, but I'll just talk about right now since it's kind of relevant, is that if you want to create something that's private inside of TypeScript, you can also use the private keyword like this. And that is also going to denote that this particular property is private, but it's only going to denote that inside of TypeScript. So our code is still going to work. You can see we have no errors. If I submit it, it is going to give us errors because it expects certain things to actually work inside of TypeScript and is expecting this to be called balance like this. So the type test cases aren't working, but our code essentially works the same. The one big difference between doing it this way versus this way is that when you use this pound symbol, this is actually interpreted by JavaScript, so JavaScript will throw errors during the runtime if you try to access this balance property. While if you use the private keyword, this is a TypeScript only feature, so it won't actually use a runtime error inside of JavaScript. So if I access this balance property in JavaScript, it won't throw an error. So it's important to notice the difference between these two different properties. And as I mentioned, we will be talking about this later. And here we have public and private inside of TypeScript, and we also have this protected keyword as well. So the private keyword essentially works very similar to that pound symbol, and protected works very similar to protected in other languages, but I'll talk about that in just a second here. So to create a private member in TypeScript, we just add private. I already showed how that can be done. Now, if we go a little further, they kind of talk about which one you should use. They recommend using the pound symbol here just because it is a built-in JavaScript feature, and I would say that perfectly makes sense to me. Use the pound symbol if you want something to be private. It's entirely up to you though which one you want to do, but I would again recommend that pound symbol. It's sometimes a lot more difficult to use the pound symbol because a lot of people are used to writing private, public, and so on if they're used to other languages, but if you just get used to the JavaScript way of doing things, it's not too bad. Now, I do really quickly want to talk about what protected is in case you're unfamiliar. Protected is essentially a object or a property that is available inside of the current class and not available outside of it, just like private. But the difference is that if you have a class that extends another class, so for example, I'm an animal class, and then I have a duck class that extends that animal class, so it inherits everything from animal. Well, private properties are still not available. So if I have a private property on animal, it's not available in that duck class. But protected properties are available in all of the children, the subchildren classes. So if I have a protected property in animal, it is available inside of that duck class. That's the one difference between private and protected. So let's see here which syntax is preferred for private fields. That is going to be that pound symbol right there, just because it's native to JavaScript. And right on cue, as I was talking about protected versus private, here's the definition for protected is essentially a property that's accessible within the class and its subclasses, but not from outside. Just like I talked about, it's available in the animal and the duck, but not outside of the animal or the duck. And this protected keyword does not have any JavaScript implementation at all, so you just need to use the normal TypeScript protected keyword to actually use that particular thing. So if we go down to this assignment here, we want to complete this. The regular customer is a more specific type of customer, which is a class right down here. It extends our customer. And we need to make it so the balance is accessible via the getBalance method. So they have getBalance that returns their balance. The problem though is our balance up here is private. We need to change this to protected to make that work. And we need to update the name of everything as well. So we can come in here, and now that at least cleans up all of our different name related stuff. We also need to make sure that our regular customer calls our customer. So we can call the super method. That's going to make sure we call the constructor of the parent. So we can come in here, last name, and balance. That's going to make sure our constructor gets rid of all of its errors. And let's check to see if we have anything else. Fix the error by updating that. Yep, so that's all correct. So now we should be able to just submit, and hopefully this should work just fine. And there we go. It looks like we have everything proper. Now, abstract classes are something that you will not use too often, but they are really useful for specific use cases. So if we wanted to create an abstract class, we can come in here and say we have an abstract class of shape that always has a size of this particular signature. It always has a constructor, and it has some functions such as a calculate area function, which is going to be abstract. And then we have this display area function that has a definition. Now, something that is abstract, for example, an abstract class, means you can't create a new shape. If we look down here, we get an error. We can't create an instance of an abstract class. Essentially, an abstract class is like a shell that we are saying, hey, we have this shape shell, and we can extend this shell to make rectangles and circles and all these other shapes, and they're going to share all these different things, the size, the constructor, this calculate area, this display area. All these things are going to be shared between them, but it essentially gives us a shell we can share with them, but we don't actually have the ability to create that shell as its own thing because we don't have any information on just a generic shape. There's no thing in our code that handles that, but we have instances of like rectangles and circles and so on. So abstract classes are great if you need to create a shell of something without having the ability to implement that specific thing. Same thing here with this calculate area function. A rectangle calculates its area differently than a circle, but they both need to have the ability to calculate an area. So creating an abstract function says, hey, whenever we inherit or extend this class, we need to make sure that we define this calculate area function. It takes in no parameters and always returns to us a number. If we actually scroll down a little ways, we can see an example of this. This circle extends our shape and it has some additional properties of its own. It calls our parent constructor and it does some things based on that size. And it defines that calculate area function because, again, circles have a specific calculation to get the area. We can then call it creating a new circle all we want and get all the information from that, such as the display area, calculate area, all this different information is available to us because we created essentially a wrapper for that shell that we had earlier. So we can actually use this as a concrete version of our class. I like to think of it as concrete versus abstract. We have a concrete class, which is our circle, and this abstract class is just something that is a shell for what we want to actually implement. Now, if we go ahead and look at our code down here for the assignment, it says that our customer object is never actually used. It's just a template. So we should use that as an abstract class. So we can say that's going to be an abstract class. And if I spell that properly and I make sure that there's no errors and we submit, we should see everything works just fine. Now, if you've worked with other object-oriented languages before that have strong type systems, you may have heard of interfaces used in a different context. And interfaces are used as essentially a shell for what a class should contain. We talked about how you can use abstract classes to define a shell of what a class should look like. For example, what functions it must define, as well as some predefined functions and properties. Interfaces in this particular instance are much better used when you want to define what something should look like, the shape of something, but not actually any implementation details. For example, here we have an interface called vehicle that has a make and a model, and we have an interface drivable, which has a function on it. And all we're doing here is we're saying that when we create a class that uses these different interfaces, it must include these properties inside of here with some type of definition and value. So if we scroll down, we have this electric car function, and we can say that it implements these different interfaces. Kind of like how we used extends to extend different things. Implements essentially says, hey, this class implements all of the features, so all of the properties and all of the functions of these different interfaces that we define. So you can see here, it has the make and model, but we need to add a drive function inside of it to make it actually work properly with this implements. So when you want to essentially extend a class by saying that it's going to implement different features inside of it, you use this implements keyword. And it doesn't just have to be with interfaces, you can actually do this with types. I'll show you by making this one a type and this one an interface, and I'll show you they both work the same together. So if we scroll all the way down to the assignment, we want to run the code and notice the methods in the regular customer class are not returning the types the test suite expects. That's because this functions down here for get full name and get balance don't return these types up here. They should match this exact type up here. So we want to make sure that this regular customer implements these things and then fetch these different functions. So let's go ahead and do that. So we can say that it's going to implement the user, I believe is what it's called. Yep, user and customer. And again, one of these is a type, one's an interface. They're both used interchangeably inside of TypeScript everywhere you go. Now we want to make sure get full name returns properly. It should just return a string. Right now it's returning an object. So let's fix that to make it return just a string. There we go. And then for get balance, that should return just a number. So we should hopefully just be able to get rid of all this information and just return the balance. Now, if we submit, it looks like that worked properly. And again, I was able to mix together types and interfaces. It's entirely interchangeable. Now at this point, you're probably getting a little bit overwhelmed because we have classes for defining things, we have interfaces for defining things, and we have types for defining things. So we have 3 different ways to define things. Well, the main difference between interfaces, types, and classes is that classes are actually a JavaScript feature built into JavaScript. They have different things that go on JavaScript. They're runtime focused. It's a JavaScript feature. Interfaces and types are entirely TypeScript only. And the big benefit of classes being in JavaScript is you get extra things with classes. You can define like pre-built functions with actual function implementations and things like that. So generally when I'm writing my code, I use types for almost everything. I very rarely use classes unless I really need object-oriented programming. As soon as I want to do some object-oriented programming, I start to lean more towards working with classes because they have different things like being able to do subclasses and being able to have like abstract classes. Those are really powerful features that object-oriented programming allows me to do. But 95 to 99% of the code that I write is just using types or interfaces if you like to use interfaces. The main benefit of types and interfaces is they don't actually add any extra overhead on the runtime, which is really great. And since they're so much more lightweight and easier to use, it's great for just being able to sling around in different pieces of your code. So let's go ahead and try to answer the question here, which of the following is false. Type aliases are simpler and more flexible. That is true. Interfaces have inheritance, and classes predefine methods on all instances. Well, classes always have these methods defined, so it is interfaces have inheritance. Technically, you can do like extending with your interfaces, which is kind of like inheritance, but not quite the same because it doesn't actually inherit implementation. It's just the shell of how things should look. Now, luckily, we know that TypeScript is incredibly good at inference, so it's able to infer what the this keyword is pretty much every single time. But if you really need to override what the this keyword is, you can do that when you define your functions. So if we scroll down here, you can see this is properly inferred to be the counter, which is the class that we're inside of. But if we needed to override this, you can use the syntax this colon followed by whatever the type of the this keyword should be, and that'll override the this keyword for that particular function. Just make sure you put it at the very start of your function just like this, or this one, you can see it's at the very start of the function. It doesn't add a new parameter called this, it specifically overrides what the this keyword is. Now, I have never seen anyone in production code actually do this, and I would recommend that you probably never do this because TypeScript is super smart and it's able to infer this correctly pretty much every single time, but in very rare instances, you may need to do this, so at least it's a good thing to know it exists. So for our code, what we need to do is we need to add a private balance queries property in the number for the regular customer. So we can come up here. I want to add a private field, which is balance queries, and that's going to be a number. And remember, I could do that with the pound symbol, or I could use this private keyword here. It's entirely up to whatever you want. Then we can come in here, we can say that the balance queries is going to be equal to 0 by default because we're just checking how many times they call get balance. So inside of get balance, what we want to do is we just want to say this dot balance queries, and we want to add 1 to that value, plus just like that. And then down here for this get balance queries, we're just going to return the this dot get the balance queries like that. That'll actually fix our code and we submit it. You can see it runs properly. Now to use the this keyword up here, I could, for example, say that this is going to be a regular customer. And now I'm essentially overriding that this keyword is the regular customer up here. But I don't need to do that because TypeScript is super smart and just infers all that for me. Now this is something I'm super passionate about in TypeScript, and that is the idea of a single source of truth. Oftentimes, especially with beginner, junior developers, when they're writing TypeScript code, they're going to write TypeScript code that looks like this. They're going to have a user that has an ID, name, email, age, and then they need to have a user object that's slightly different. It doesn't have an ID property. So they redefine everything in their user. There's a huge problem with this, especially as you get more and more of these types that are essentially the same thing, but with a few properties added or removed. And that's because if I wanted to change my email to now be slightly different, or I wanted to change my age to be a different property, I need to update that in every single location. Or what if I want to add a new property like address to my user? Again, I have to update that in every single location. It's super error prone, very easy to mess up, and it's very difficult to refactor. This is where the idea of utility types inside of TypeScript come along because they allow us to actually create different types based on everything. And we can even just make sure that when we create our own types, that we're always extending other types to be able to create these new types that we need. So in our case, we're not even using any utility types. We're just taking the user without ID and then extending that to get the ID property here. But I think using utility types, which we're going to be covering throughout this entire section of the course, is a much better way of writing code like this. Really, the key approach though here is that when you're trying to define a type for something, you want that type to be in one single place. And then anytime you need to use a modification or variation of that type, you either extend, inherit, or use these utility types we're going to talk about to modify what that type looks like. So let's take a look at the question here. Which of the following is true about single source of truth? We can derive multiple types from one main type. That sounds correct. It's best to copy paste. Definitely not. Duplicating code makes it easier. Definitely not. So we're going to go with that answer. Now, all of these different utility types we're going to be talking about are going to have a signature that looks very similar. It's going to be some word. In our case, this one is the partial utility, followed by some angle brackets, followed by a type, ended by the angle brackets. So if we actually scroll down to where we use this, you can see partial, angle bracket, the type, angle bracket. This is again using generics, which we cover in the next section of the course. I'm really excited to get there. But this partial utility type allows us to take a type that is required. For example, ID is required, name is required, email is required. And if we pass that into the partial type, it makes all of these different keys optional instead. So you can see here, my user info for ID, name, and email are all optional. And to create that, all I did was I take my user and I wrap it in this partial. So it just converts all my required types to optional types. Really useful if you're creating a form, for example, for someone to fill out. You may have all your types be optional because the form starts out blank and they slowly fill in information as they go. But instead of creating a brand new type, copying this, pasting it down, and calling it user with optional fields and making everything optional, you can just wrap it in this partial, and now you automatically have a user that has these optional types applied to it. Now, seeing how that actually works with nested objects, it only works on the top level. So if we were to use partial on this, you can see it only makes the ID, name, and preferences optional, while the things inside the preferences are not marked as optional. This is really important to understand, and it is a good thing TypeScript works like this because it just makes logical sense when you're writing out your code. So for our assignment here, we want to fix the compile time bug for update user. It should accept a user object, but where each property is optional. So that's super simple. We can just wrap this in a partial just like that. And if I spell partial correctly and I click submit, you can see our code works. Now, one really nice thing about these TypeScript utility types is that there's always an opposite type for pretty much everything. So we had partial that makes everything optional. We have required that essentially takes everything and makes it required instead of optional. So for example, here our tags, our publish date, and our author are all optional. If we wanted to make those required, we could just wrap it in a required optional type, and now all of those fields are required instead. And again, down here, we can use required to enforce our contact info is required, just like that. Make sure it is a capital R. It is type sensitive. There we go. So now our info here is all required information, and then we can return a string that just essentially says this. So we can come in here, return that string, make sure that we get our proper information. So this is info.email. And if I hover over this email type, you notice it is string because it's not nullable. It is not optional. It is required to be a string because I used required here. And this is info.phone, just like that. Now, one thing that you may get slightly confused with is what I could do is I could remove this required type here, and then I could just, throw down an exclamation point on both of these. And of course, make sure this says phone number. And now that kind of does the same thing because I'm telling TypeScript that these are required properties. The huge difference between these two, though, is one of these essentially is overwriting TypeScript. I'm telling TypeScript, I know better than you. I know that you say this could be undefined, but I'm going to force you to make it a not undefined value. While using this required property is useful because it gives you actual type safety inside your code, because now you're guaranteeing when you call this add billing info, you pass it along required information. So if I call add billing info and I try to pass it along an email, it must be a string. And if I pass along a phone number, it must also be a string, just like that. I have to pass along these values. While if I remove required, I can actually get rid of my phone number and it still works just fine. So this forces me to actually write functions and parameters and variables that take in the correct information. So let's bring that back to what we had with required, remove this and make sure that our code actually works. There we go. Looks like it is, so we have that correct. Now we have the read-only utility, which essentially allows us to convert all the keys inside of an object to read-only. So if we look here at this user profile, by making it read-only, our ID, our name, and preferences are going to be converted to read-only, as you can see here, but the nested values don't change. So this stays read-only, and this notification stays not read-only. So in this case, we want to complete the import config function. It should return the config object with all properties marked as read-only. So we can just say that this is read-only, just like that. And then we want to return that config. There we go. And this should say read only with a lowercase. And now if we just submit that, we can see that that works properly. So this just allows us to essentially create a config where we can't change things. Like I can't come in here and change my API URL. It's going to throw an error because it is read only. Now I briefly talked about the record utility type when it came to defining objects with dynamic keys. And that's really one of the great use cases for it. I can say I have a record, which has a string and a number. And now I can create an object with any number of strings, and it just has to have a value as a number. And as long as I pass a value of number, it's going to work just fine, as long as the key is also a string. Now, the reason this becomes really useful is it's really great with exhaustive types, which is something we've already talked about a little bit before. For example, if I have this union here of tank, healer, and DPS, if I now combine that together with a record where my player role is my key and a value is the number here, now I'm forced to actually pass along all the different values for tank, healer, and DPS. So you can see here, it's working just fine when I pass that along. But if I come along here, I'm not actually passing along my key for healer. So it's going to give me a TypeScript error because it's missing that particular role capacity inside of our player role right here. So the really nice thing about doing this is it just forces you to have those exhaustive checks, because if you know you want to have a record that contains the keys for all of your different unions, you can set it up like this, and that's going to work inside of TypeScript. And this is something I do quite often. So now let's scroll down the rest of the way here. You can see they're doing it for HTTP status codes. Again, another great use case for this type of situation. So let's go ahead and actually do our code. We just need to fix the bug in get status message. So if we look at this map here, you can see property responding is missing in type waiting, but required in type record model status. So you can see up here, we have waiting, thinking, and responding, and we're only mapping to waiting and thinking. So we also need to map to responding as well. So you can really say responding is going to return our responding message. There we go, responding message. And if I click submit, you can now see it's working. Now pick is by far the most used type that I use for the utility types inside of TypeScript, and it essentially allows me to pick only specific keys from an object to use in my new type. So you can see I have this product with a lot of information, and maybe I don't want all that information inside of another type. So I can create this product summary, which is going to pick my product. So you pass along as the first parameter what object you want to pick from, so the type of product in our case, and then you pass along the different keys you want to pick from it. So in my case, I only want the ID, the name, and the price. And that returns me a brand new type that has just ID, name, and price, and all of this other information is completely removed. So now when I create these product summaries, you can see I pass along only the ID, the name, and the price, and everything works just fine. Like I said, this is by far probably the most used utility type I use because it allows me to take one type and essentially narrow it down to various different types while keeping that one main type as my single source of truth. Now, if we look at our assignment, we just need to fix a bug with my user without ID type so it has the 3 properties we need. We want to specifically pick all the properties except for ID. So we're going to come in here with name, we're going to come in here with email, and age, and that's going to give us those 3 types. And now when we submit our code, you can see it's running properly, and we can actually move on to omit, which is the next type, and it works just like pick, but instead of picking those properties, it removes them. So if we take a look at this database user, for example, it has all these different properties, and we actually don't care about the password hash or the updated at field, so we omit those, and it essentially gives us a database that has an ID, a username, an email, and a created at field, and it removed the 2 fields that we do not want. So again, omit is the opposite of pick. The nice thing about TypeScript, almost everything has an opposite inside of it. So in this case, we want user ID to use omit instead. So essentially, I'm going to write the exact same code I did in the last example, but using the proper type of omit this time. Remove that ID property just like that. And now if we run our code, you can see it works. Okay, so if you've been zoning out, you need to lock in and pay attention because this is by far the hardest thing to learn in TypeScript, but also one of the most powerful and most important features, and that is generics. Generics are used in pretty much every type-based language, and it allows you to use type information that can be generic and reused with many different types. We've already seen this with the TypeScript utility types. For example, with pick, we can pass in pretty much any type that we want, and it's able to use that type for various different things. So we've seen this same thing with arrays. We can create an array that has a string inside of it like this. If I can actually type properly, there we go. So we can create an array with strings. We can create an array with numbers. We have all this different type information we can do. Again, this is all built on generics. Generics allow you to use any type that you want and retain the type information. So if we pass along, for example, in our getFirst function here, this is a generic, if we pass along a number as the type inside of here, TypeScript will know that now this is a number and it'll retain that type information everywhere. Same thing here when I use my array syntax and I pass it in a number, it knows that I now have an array of numbers inside of whatever type this is. So if I call this A, this type will be an array of numbers as the actual type. Now I could talk a lot about what generics are and why they're so useful, but the easiest way, in my opinion, to understand generics is actually just implement and use some generics. So what we're going to do is we're going to come in here. This function is called getFirst, and all it does is return the first value inside of our array. So obviously we can do that relatively easy. We can just come in here and return the first value of our array. And now our function works. We submit, everything's going to run fine, but we need to actually understand a little bit more about how everything inside of here is actually working. So let's try calling this function with a few different properties. We can say getFirst. I'm going to pass it in an array of numbers. So we'll say 1, 2, 3, 4, and then we'll just say over here, we want to get the value. And if we hover over our value, we're going to notice the type of this is number or undefined, which makes sense. Our return type here is either a T or it's undefined. And the way that defining generics works is we actually define them inside these angle brackets. So anytime that you define a function or a class or anything that can be used as a generic, even a custom type could be generic, you just put these angle brackets. So in the case of a function, you put these angle brackets right after the function name, but before the function parameters. And you create your own custom type. I don't know what this type is. This could be a number. This could be a string. It could be a bunch of different types. I don't know what it is. I just call it a generic type. You can call it T, but you can call it literally anything you want. I can call it like element if I want to be more specific and say that this is the type of the elements in my array. So by using this generic type, I'm telling TypeScript, I don't know what this element type is. I haven't figured it out yet, but I do know anytime that I use this element type, it's going to be the exact same type here and the exact same type here. Anything that uses element is going to be the exact same type. So if I pass in an array of numbers, well, I'm essentially replacing the word element here with number in all different places. So now I have a number array and I'm returning a number or undefined. If this was using strings instead, Now, all of a sudden, I'm replacing element with string, so my value is now a string because it's again replacing that text element with the type of string. Something else you may have noticed is I didn't actually have to pass along the type inside of here. For example, normally when we've been dealing with generics, you have to pass along the type like this. But TypeScript is super smart, and in 99% of cases, it can just infer what the generic should be because we passed an array of strings, so it knows element is a string, so it knows that we return a string from this function. Now this is pretty much scraping the surface of what you can do with generics, but they are incredibly powerful. The nice thing though is if you find this quite confusing, is you don't actually end up writing very many generics in your TypeScript code, especially if you're doing more web development style code. You don't actually write that many generics, but you will use generics, for example, TypeScript utilities and so on. So understanding what they are and how they work is important, but it's okay if you don't feel like you've completely mastered them by the end of this lesson. I would recommend if you really get stuck with this section, just repeat this section of the video and it'll really help you understand what generics are. Now, when it comes to generics, we've already kind of seen this before. For example, when we used a record type, we actually passed along two values for the generic. We passed along the key and the value. And with generics, you can use any number of generics that you want. Generally, most functions are going to have 1, 2, and maybe 3 generics, but you could have infinity generics if you really wanted to. And you can call them whatever you want to make the naming a lot easier. A lot of times you'll see like T and U and V, these small single letter case names. And that's fine if you have a really simple generic. For example, that last function that we did, this is fine just to call T. But if you're starting to write more complicated code inside of TypeScript, I would highly recommend using full size names to write out what your generics are, because it makes it easier when you're reading your code to understand what's going on. Because if you see a bunch of T, U, V's, and so on, it's kind of complicated to parse what all that means. So let's go ahead and actually take a look at what we need to do for this particular assignment. If we just scroll down all the way here, you can see we want to complete this pair function. It takes 2 arrays, one with the input of A, one with the input of B, and we want to return a list that's a tuple that is going to be A and B. So if we take a look at a quick example here, if A had these 4 names and B had these 4 values, we would essentially create a pairing of these different values. And it specifically says we want to do this until the shorter list runs out. So let's go ahead and do a quick implementation of that. We can just say that we want to have an array. We're going to set that equal to an empty array. And again, this by default, actually, I need to give it a better name because we have A already up there. So this array has that any type by default. I don't want this to be typed as an any type. I want to type it as an A, B array, just like that. So it's an array of tuples A and B because that's what we're going to be passing into this. It's the same thing we're returning from here. And then we just want to loop through our values. So we can say for let I equals 0, I is less than A dot length, or I is less than B dot length. So essentially whenever we get to the shorter of the 2 arrays, and then we just want to add 1 to I each and every time. Then we want to get the values from these and put them into our array. So we can say array dot push, a brand new array that takes A at the index I and B at the index I. And then down here, we can return our array. Now let's make sure that works before I start explaining exactly what's going on. Now we do have a quick error. I need to put an and here instead of an or, essentially saying that my length is less than A and it's less than B. It needs to be less than both of them for me to continue. Now if I submit, you can see it is successful. So let's really quickly again go through exactly what's going on inside of our code as well as what's happening inside of all of our different type related stuff. First, we're going to analyze the code because it's mostly straightforward. We start at an index of 0 and we essentially check, are we smaller than A and are we smaller than B? That means we have new items in A and B to go through. If so, we continue on our loop. And for each iteration of our loop, we just get the item at the index for the index we're on from A and the current index from B. We push that into our array until finally we get to the end of one of our arrays and we just return the value. Now, when it comes to understanding our type related information, you can just see we have 2 generics, A and B. And when I call this function pair, it doesn't matter what my array is going to be for value A. For example, it could be a number array. And it doesn't matter what my array is for the second one. It could be a string array like this. It's still going to work just fine. And when I hover over the return of pair, you can see here, it's specifically returning a number string array. And again, I don't need to specifically pass number and string into here because TypeScript knows the inference that this is a number array, this is a string array, so it knows what everything needs to be, and I don't need to manually pass all that along. So generics, again, are just a way for me to put a placeholder type. This type just sits there until a real type gets passed in, and then that real type is used everywhere inside of my code. So let's just get rid of this so we have working code and move on. Now here we're moving on to something that is quite complicated inside of generics, especially as you get to more and more complicated code, and that is generic constraints. Essentially taking a generic value, what we have right here is just a generic of T, and we need to constrain it down because right now T could literally be anything at all, and I want to say that it follows a specific format. In the example they give over here, we have fetch from API, and we're saying that T is a generic type, and it's going to be returned in this promise down here. But T could literally be anything at all. We don't know exactly what T is, and we want to maybe narrow that down. In order to narrow down what the type of T should be, we can use the extends keyword. So we're saying here that T extends has cost. That means that T must follow the format of an object that has a cost, which is a number. Now this generic T could have lots of additional information. It could have like a name, price ID, all these other things. We don't really care. All we care about is that it has a cost, which is a number. Everything else is irrelevant. It doesn't matter. So we're just essentially forcing a minimum viable type to have inside of here, a minimum type that we have to contain those particular properties. A really common use case may be you just say it extends a string. So we can come over here and say extends string. And now anytime I pass a generic into here, it must be of type string. But usually you're going to use this with objects. And the nice thing about doing it this way is instead of just saying that this is going to be a has cost variable, so let's just kind of change this to what we had over here. Instead of just saying that this is that has cost type, that removes all of our type information. Instead, we want to retain that type information, which is why we're using generics, because it allows us to pass along that type information and just extend whatever we want. You can almost think about this as the satisfies keyword. We're saying that T satisfies this particular property, but we don't overwrite what the type of T is. We just say it at least meets the requirement of this particular type. Very similar to the satisfies keyword. So let's go ahead and scroll all the way down here to figure out what we need to do. So this pluck email function, it should accept any array of objects of type T, but only if they include an email string property. So we need to make sure that this type T is going to extend an object which has an email, which is a string. And we can even do this inline directly right here if we want. We could extract this out into our own type or do it directly inline. Then we return a new array of just the email addresses. So we can say inside of here, array.map, I want to map through each one of my values, and I want to get that email. And you notice we get autocomplete for that email property because it's right here inside of our extend. Now, if we submit, you can see our code works. And to show you kind of how this works, we're going to call pluck emails, pass it in an array. I'm going to come in here, I'm going to say the email is kyle@test.com. There we go. This is called pluck emails. And now when I hover over this particular type, you can see it returns to us a string array, and it's all working just fine. Our type here is an email with a string. But I could also have some other properties, for example, a name of Kyle, just like that. Put in a comma here, and you can see it still works. And the really great thing is when I hover over pluck emails, you can see my generic type updates to include that name property as well, which is great because now if we're like returning that T type or using it in other places, it's able to get all the type information from it instead of being restricted to just an email and a string. Now, I briefly alluded to this at the beginning, but you can use generics not just with functions, but also with types if you want. So you can see here, we're using an interface, but it works the same exact way with types or interfaces, it doesn't matter. And to create a type or interface that's generic, you just take your name of your type or interface, and right after it is where you put your generic information. You can do the same extending inside of here. All the stuff we've talked about with generics works exactly the same, and we can use that type inside of the definition for our interface or type. So you can see here a store of type T has a get function that returns T. It has a save function, which is an item of T, and it has a list, which is an array of those T items. We can then use that generic type anywhere we want. For example, add and get items is just going to use that generic type of store just like this. And we can have all these different things. For example, this product store is essentially just an implementation of this interface of store. It has get, save, and list. If we go down, get, save, and list, it maps to all those properties perfectly. So we can use that directly inside that function that we created that takes in a store value. Same thing here, we're doing the exact same thing with the homunculus. We have the homunculus store, and it's working exactly the same inside of here. So let's go ahead and actually implement these ourselves. You can see here inside of our assignment, we need to define a new job queue T type, which is going to be a generic type with a push method that matches the implementation in create queue, and a next method that matches the implementation in create queue. So let's come up here and create that type, export type job queue. And this is going to be a generic type. Again, you can call this anything you want. It could be T, it could be like element. We'll just call it elem because it's an element inside of our queue. And then we're going to come in here with a quick equal sign, and we need a push function, and we need to have, I believe, a next function. Yep, a next function. So let's create a push function. This takes in an element. We don't know what type it is. It could be any type. We just know it takes in an element. So we're going to take in an element, and that element is going to be a type of our elem type right here. We know it's going to be of this particular type. And then we know this push function doesn't need to return anything, so we can just return void as the return type for this function. Now, if we look at the next function down here, this essentially is supposed to return us the next element. So it's not going to return void, it's actually going to return an element. Now let me fix my typing here by putting a little colon here to make sure I define that as a type. And then we can come in here with the next, This is a function that doesn't take anything, but it returns to us an element from our array, which is that ELEM type. So that's the full implementation of this generic type that we have here. The next thing is we'd like to write a new generic run next function that accepts a job queue and calls its next method and returns the result. So let's come in here and we're going to do that. We'll say this is going to be called function run next. This is going to be generic. So it takes in whatever type. It doesn't matter what we call that type. It could be literally anything. It accepts a job queue, which is a job queue that is generic. There we go. So we're essentially taking the generic from our run next and passing that along to our job queue so it can use that exact same generic. So we're essentially just hopping it to the next thing inside of our line. And then it just returns calling job queue.next. That's relatively straightforward. Now I do believe we have a small error. If I hover down here, you can see job.shift technically could return undefined. So this could be element or undefined, and that should fix those errors in TypeScript. And if we submit, it looks like we do still have an error though. And that's because I need to make sure I export this function. Always forget to do that. And now when we submit, it works. Now, luckily this lesson is pretty redundant for us because I've already talked a lot about how generic types have inference. For example, if you pass along a type information to the TypeScript function that is generic, TypeScript is almost always smart enough to know what those types are, and you can actually leave off this generic thing right here, and you can see it works exactly the same with and without, because TypeScript in 99% of cases can do that inference for you. So what we're going to do is we're going to implement this assignment, which is just reinforcing some of those generic things, and we're going to make sure we use inference for everything. So we need to complete this summarize feedback function at the very top here. It accepts an array of objects that must include a text string property. So we need to make sure that this extends an object which has a text, which is a string. That's going to fix that first portion. Then we have a transform function to extract the text values from it. So we can just return transform, and it's going to give us an array of those values. So if we look at transform, you can see that the inputs are going to be of type T, which is an array. So we can just call transform and pass it along our data, and that should do all the transformation for us. We just need to make sure we also pass it along a function that's going to take in each piece of data, and it's going to transform that data based on whatever input we want. So in our case, we want to return just the text portion, so we can get the d.text from here. And that should be all we need to do. If we submit, we can see that everything is working properly. And the nice thing is TypeScript was able to automatically infer the R type was a string because our text is a string, and the T type was this data here, which extended a text of string, so it was able to infer that property for us. And the really nice thing about all that inference is since we knew that our generic type T had a text of string, we passed that along to this function here. But when we define that transform function, T can be anything. We don't know what it is. But when we get that T or that D variable being passed back here, which is of type T, it is the exact same T extends text of string, which is coming from here. So that's the really cool thing about generics, is because we were using generics all the way along the way with our functions, it was able to infer everything for us, and it was able to make sure that the types that we got passed along were exactly what we want. We know that this D variable matches this exact format right here because of the type safety that we have, and this data also matches this T format as well. Now, the final thing we're going to talk about with generics is that you can also have generic classes. Like I said, pretty much anything can be generic types, classes, functions, and so on. So what we want to do, we're just kind of scroll down past this because creating a generic class is as simple as just putting the generic type right after the class name and then using that inside of the class. So we're going to scroll straight down to the assignment to just jumpstart what we want to do. In our case, we need to complete the feature flag class, should keep track of all the enable flags and allow users of the class to enable new flags and check if a flag is enabled. So let's go ahead and do that. We should just come in here with our constructor and we'll just say this.flags is going to be equal to an empty array because we have no flags enabled by default. And this actually needs to be a new set because we're using a set here. So we're going to say it's a new set. And of course, that set must be of the type T to make sure everything is working properly. But even if we remove that, it still knows that this is the correct set type because we're setting it to a variable that explicitly has that type. So again, TypeScript's super smart. It figures all of that out for us. So if we want to enable a flag, we can just add it to our flags. So we can say this.flags .add. We want to add that flag into there. If we want to check if it's enabled, we can just return this dot, get our flags. And I think we have the has function, yep, and we can pass in our flag and it'll tell us if that thing exists or not. And now if we click submit, you can see all of our code works fine. Now there is one thing I want to note about the test file here. You can look at something real quick and you see we have a type for our BG3 flag, which is just our different flags related to Baldur's Gate 3. And then if we scroll all the way down, we're creating this new feature flag object with BG3 flag being passed in. So if we look inside of here, T extends a string, which means it could be any string at all. But by passing along specifically this BG3 flag, we're saying that it must be one of these three different flags. It can't be any other flag at all. It must be one of these three strings, which is a way of just narrowing down that type. So this is one use case where you may want to actually pass along what the generic type is if you want to filter down what the type can be even further. Not something you're going to do super often, but in some very unique situations, such as like making a new array, this new feature flag is, if we look at it, essentially a wrapper and around an array. So it makes sense you may need to pass the type of that array along. Now this section really dives into some advanced TypeScript stuff, and to be honest, this is code that when you're just writing applications, like web applications, you don't use at all. But when you're writing a library that other people use, these are very common types that you're going to be using. And this is where I like to create a distinction between library authors and application developers. If you're an application developer, you really only need to know 20% of all of TypeScript because you just need to know the basic, simple TypeScript things. But if you're an a library author, you need to know all the really advanced nitty-gritty features of TypeScript because you need to write really complicated types. So that way people that use your library in their application can do it really easily by just using the simple TypeScript types. And conditional types are one of those things that you very, very rarely use inside of application code, but you use all the time inside of library code. So it's okay, again, if you don't quite understand how this section works, that's perfectly okay because you're probably not going to use it super often, but I would recommend, especially when you start wanting to get into more advanced TypeScript, go back, rewatch this entire section. Hopefully it'll start to make more sense. So if we scroll down a little ways, a conditional type is essentially an if-else check inside of TypeScript and is done entirely using ternaries, which is very confusing, especially when you have lots of nesting. So you can see here, we're creating a brand new type that is checking some type to see if it extends some other type. If that's true, it returns this type. If it's false, it returns this type. This is a little bit complicated to look at, so let's move down here for this isString. IsString is going to be generic, and a lot of times, pretty much every time I should say, when you're doing these types of checking, you're going to be doing it with generics because you essentially want to check, is this generic of type string or is that of type something else, and so on. And here what we're doing is we're saying, hey, does this type T, this generic type, extend string? If it does, we return true. If it doesn't, we return false. So here you can see isString, we pass it a string, we get true. Pass it in 42, we get false. Pass it in the string type, that still extends string, so it returns true. Now this may seem not that useful from this contrived example, so we're going to move down to some slightly more useful examples right here. So we have a bunch of different events. We have a click event, we have a key event, we have a mouse move event, we have a submit event, and they're all inside this event union essentially. We can see that this is essentially a discriminated union based on these specific types right here. And now what we want to do is take it so that we only get the specific events that have X and Y coordinates. So to get mouse related events, we can use this fancy extract function, which we're creating. It's also a built-in into TypeScript, but this is the implementation of it. And we're just saying, hey, if T extends the type of U, then return T, otherwise return never. And that allows us to narrow down our type because never essentially removes the type completely, and we're just left over with the types that match this particular signature. So up here, this type and this type are the only ones that match an X and Y coordinate. So click event and mouse move event are going to be included when we call this extract event right here. As you can see, that's all we get back as our return value. So let's go ahead and we're going to implement what this function wants us to do. And then I'm going to explain in my words, the best way to understand this complicated TypeScript. So we want to create and export a sentiment string utility type. So we're going to say export type sentiment string. And that's a utility type that evaluates to mad or furious if T includes angry, otherwise content of happy otherwise. So we can say here it's going to be a generic type T, and we want to say that that is going to be equal to a specific type. And if T extends an object where angry is true, then we know that it is going to be returning mad or furious. Make sure that I put a question mark here and then I spell furious properly. There we go. Otherwise, what we want to do is we can come in here and we can return content or happy, just like that. And to make our syntax formatting a little bit easier, generally what you'll see inside of TypeScript is you'll see your code brought down like this. There we go. So now we have our extends keyword, we have the true value, and we have the false value. And if we submit, you can see it works properly. So if we pass in a T object that has an angry property set to true, we get this, otherwise we get this. And the way that I look at code like this is the extends keyword, I try to ignore what this keyword does because we've already talked about the extends keyword, but the use case of extends here is entirely different. Don't even think about it as extends. Instead, think about this as an if query. Essentially, you're saying, is T equal to this? And not quite equal to, we're essentially saying, does T satisfy this requirement? That's another great way of looking at it. So if T is this particular shape, if it satisfies this shape, I don't care if T has other properties or anything like that. As long as it has a property angry and that's set to true, that's all I care about. If that's true, then do the code inside this true section. Otherwise, do the code inside this false section. And these are just returning types to us. So it has a type of mad or furious and a type of content or happy. So again, if T is equal to this, then we do this. Otherwise, we do the code in the colon section. Now the infer keyword is incredibly advanced, but again, as a library author, you're going to use this all the time. And it allows you to infer the type of something from your generic type stuff that you're doing. So in this case, we have a function called getReturnType, takes a generic, and we're checking does t extend an object, a function that takes any number of arguments, it doesn't matter, and then it returns something. And instead of just saying that it returns anything, we're specifically saying we want to infer whatever it returns. So this is going to be a function that takes any arguments and returns something. And whatever that something is, we want to return as our type R. Otherwise, we return the type never here as the final option. This is actually a built-in type into TypeScript. Return type is something you can use in TypeScript. This is the implementation of how that function works. And again, this is a conditional utility type that if we pass in, for example, the greet function, it returns to a string because this returns a string, while if we pass in the sum function, it returns a number because this returns to us a number. The infer keyword here is just used by TypeScript to be able to let us tell them, hey, we care about what the type of this variable is. Essentially, it replaces infer R with any, and then we type R to be whatever that new type is. So just like when we work with generics, we know that our generic can be anything at all. We don't know what it is until we actually run the code. Same thing here with infer. We're saying this R variable can be anything. We don't know what it is, but we want TypeScript to tell us what it is and then use that particular value. Now let's scroll down a little ways further and you can see we get to the assignment here. But before we get to the assignment, I actually want to talk a little bit more about another example that I think might make this a little bit easier to understand. Let's come in here with a type. We'll just call this test. It doesn't matter what the type is. We'll make this a generic type. And we're going to come in here and say if t extends, and we want to check to see if it extends a specific string. So we're going to come in here with our string template literals, and we're going to come in and we'll say, for example, it's a string followed by a colon, followed by another string. Let me make this quite a bit wider so it's easier to see. So essentially we're checking, hey, is it a string followed by a colon, followed by a string? If so, then we can just return true. Otherwise we'll return false because this part doesn't really matter that much. So now we can come in here and we can say type A is going to be equal to test, and we can pass it in just a random string like this, and we'll look at A, and A is going to be false. Now, if we put in a colon followed by another value, and we look at A, you can see it's going to be true. So essentially, we're able to match this based on our template literals. But what happens if I want to get what the value of this is? Imagine like it's a key value pair. I want to get what this key is. Well, I can use infer here, and let's just say we're going to infer this as our key. So now I have a new variable called key that matches whatever is in this section of my string, and I can return that as my type here. So now if my string matches this syntax, it's going to return to me whatever is my key. So if I say name and Kyle, when I hover over A, the value of A is equal to name because that's what this value is inside of my string. I could also infer multiple things. For example, I could infer my value right here, and now I could do something interesting here where I return an object that has like a key value pair similar to this. We just need to slightly change how our code is written. And instead of actually doing that, we'll return this as an object because that'll be a little bit easier. We don't need to do any complicated TypeScript stuff. So we'll return a key and we'll return a value just like this. So now we have a tuple instead of that object. And if I hover over A, you can see I get name followed by Kyle. So it's relatively easy for us to do that. And this is a little bit, I think, easier to understand how that infer keyword actually works. So now let's go ahead and actually do the assignment it's asking us to do. We need to create and export a generic input type of. So we'll say type input type of, that'll be generic. And it extracts the type of the first parameter from the function type t, and the function can return any type. And then we want the fallback value of that to be unknown. So what we need to do is we need to say that this is going to take t, it's going to extend a function. So we have a function inside of here, and we want to get the first parameter of this function. So this is going to be like arg1, and we're going to infer that as our type p. That's our very first parameter. And then it can take any other number of arguments, and we don't care what those are. Those are in any type. And this can also, I think it said return anything. So we're going to say the return value is any. So this is a function that has at least one parameter, and we want to figure out what that parameter type is. If that's the case, then we return that parameter type, I believe is what it asked for. Otherwise, we return unknown. Let me make sure that is what it asked for. Falls back to unknown, and the function can take any type, return that first parameter type. Now I'm going to submit this, and we are getting an error. Of course, it's because I forgot to do my export up here. So we'll say export, and now when we submit, you can see it is working successfully. Now, one really interesting thing to note is we can actually do this with TypeScript's built-in types because TypeScript actually has a type called parameters. So we can say parameters just like this, and this can give us the parameters of any function. So we could pass in any function we want, for example, like console.log or something like that. And this will give us all of the different parameters of that function. So we can say here, type A is equal to that. And now if we hover over, and I make sure I spell parameters correctly, we hover over A, it gives us essentially any type because that's just what this function is. But let's create our own function called greet. We can come in here, This is going to take in a name, which is a string, and an age, which is a number. I don't really care what the function itself does, but now when we hover over A, you can see I get a name, which is a string, and an age, which is a number. So if I want to get the first parameter, I can just say of 0, and now that's going to give me the type of the very first parameter, which is a string. So you can see this is actually something built into TypeScript. And if we wanted to rewrite our input type of using that, we could export input type, which is a type, is going to be a generic type here, and that's just going to be equal to passing that a generic along here. That should still work successfully, and when I submit, we are getting an error because we need to make sure that we do our extending, so we would need to come in here with an extend to say that this is essentially something that always has at least one parameter. So we could say args, and that's going to be whatever, we don't care, any, and then it could be any number of args. So this one's arg1, and then this is an any array, and then this returns to us a function just like that. And I don't care what the return type of the function is. Now, if we run that, we are still getting some errors, and I believe that's because the way parameters work is it doesn't actually return undefined. You can see it returns never instead. So it's a slightly different implementation than what they asked for us to use here. But again, you can kind of see the power of parameters as a built-in function, and we essentially rewrote that function using a single line of TypeScript. Now, mapped types are really useful because they allow us to essentially loop through a bunch of different things to create a new type out of an existing type. So if we scroll down a little ways, you can see here we have this soldier type, which has a name, an age, and then a branch. And we're creating this optional soldier type, which is taking all the keys in soldier and converting them to be optional. And this syntax looks a little bit confusing, but luckily it reads kind of like English. So this K is our generic type that we're creating. This is our type that we're inferring, or our generic. You can call it whatever you want. You can call it key, K, T, doesn't matter. K is a general stand-in that most people use. Then key of, this is a syntax directly inside of TypeScript we can use. If you use key of and then follow it up by a type, it'll give you all the keys. So it'll say name, age, branch as a union. So we can come in here, I could say type, and we can actually just copy this exact type over. So we have our soldier type, and what I want to do is I want to get the keys of our soldier. So we'll say type A is equal to, let me just add a bunch of space so we have something moved up, and that is going to be the key of soldier. And if I hover over A, you'll see that the type of this is key of soldier, but in reality, this is just a list of name, age, and branch. To see this a little bit easier, let's actually use this as a function. We'll say function test is going to take in a variable A, which is going to be set to that value. I don't care what that function does, but when I call that function and I try to pass along values, I either need to pass along name, I need to pass along age, or I need to pass along branch, because those are the only different options I can pass along. As soon as I pass along something else, I get an error because it's not one of those three different values. So key of just gets the keys of an object and returns them as a union of those strings. This in property essentially is saying, okay, I have a union, doesn't matter what this union is, I have a union of values, and I want to loop through every single union in that value, and I want to save that value as K. So here, I'm looping through the name, the age, and the branch, those union values, and I'm putting those as the keys of my particular string here, and I'm making all of them optional. Then what I'm doing is I'm getting the value of that from my soldier property. So by saying soldier of K, that's essentially the same as me saying soldier of, for example, name. That's the exact same thing. It's just replacing this with each one of those in turn. So this soldier of name, if I say type A is equal to that, you can see if I hover over this, I get string because that's what the type of name is here. So really by breaking down this code, key of just gives us a union. This in syntax allows us to loop over a union, and it gives us a value K for each item in our union. Then what we're doing is we're just setting that value to an optional value. And lastly, we're getting the value from our soldier type. So really this is just essentially the same as the optional type inside of TypeScript. Now let's keep moving on a little bit further because we can do a lot more than just making something optional. For example, we can completely change the value. By doing this, we essentially replaced all the values from string number and this value right here to just be a hard-coded string, as you can see here. And for our assignment, let's go ahead and actually work on that. So we got to clean up our code quite a bit because we have all these extra lines we don't need. We need to complete the blank type. It keeps all the original keys of T, but forces them all to be null. So we just need to convert all the types to null. And then let's actually just do that first before we move on. So this one's going to be relatively straightforward. We want to get each key in whatever the keys of our type T are, because we want to get that union of those keys. And we just want to set each one of them to null. That'll just blank all of them out. Then we can complete the reset form function, except in our object of type T returns a new object with the same keys and all values set to null, does not mutate the original input object. So now what we need to do inside of here is we need to loop through our form object that we're going to be getting in. So what we can say here is we want to do a for each key in our form object. We'll say this is a constant variable, just like that. We essentially want to create a brand new object that is going to be a blanked out version of that. So we can say our result here is equal to an empty object. And then we can just say that our result of key is equal to null. And then finally, we can return our result down here. Now we are getting an error because obviously here I can't define any specific values on this empty object. And like I said, when we have empty objects at the beginning of this course, we need to make sure we give them some type of type. So we're going to say this is going to be a blank of t, just like that. So now I have an object that is this blank of t type. Now, because of the way that our generics and everything are working, TypeScript's not 100% sure how to handle this. So instead, what we can do is we can actually just hard code type this as a blank of t, just like this. And this is one of those rare instances where as casting is fine, because we're just using an empty object. And all we need to do is tell TypeScript what that empty object is supposed to look like. In our case, it's supposed to look like this type of format. So this as casting is kind of useful in this particular use case. Now let's submit that, and it does look like everything's working. So now in this lesson, we're essentially combining together map types with conditionals. So we have this optional soldier type just like we had before, but now we can actually modify this even further by saying we only want to keep the keys that have a value of a string. So if the value is a string or a string-like type, then we keep it, otherwise we return never. So this combines together our mapped type as well as our conditional type into one giant type that we're creating. And as you can see already, our code is starting to look incredibly complex. And unfortunately, when you get to this really high level of TypeScript knowledge and this TypeScript code, it starts to look and be very difficult to read. So this is something that it just takes a lot of practice writing these types to really understand how they work. And it's not something I expect you to get right away. This is something that just takes practice and use case to really understand and see how TypeScript works, because essentially we're creating an array that's a loop here, and this is an if check inside that loop, but TypeScript writes it in such a different way than pretty much any programming language does, so it's kind of difficult to read. And once you get used to seeing, okay, this extends keyword with the ternary, that's an if check, and this key in of is just a check that's going to be a loop. So now we have a loop followed by an if statement. Once you can start to see that, it becomes much easier. But again, like I said, this is very complicated TypeScript stuff. So let's go ahead and actually see what we need to do for our assignment here. The compliance team at support is reviewing some stuff. They want to complete the editable fields t type. It should return a new type with the same keys as t, replace all function or objects with never, and keep the primitive types as is. Okay, that should be relatively straightforward. So we want this editable fields type. This is going to be a brand new type where we need to loop through all of our different keys. So we'll say k in key of t. And then what we want to do is we want to do a quick check on what the field is going to be. So t of k, that's going to give us the value. And it wants to return a new type where we replace all functions or object fields with never, and we keep all the primitives. So we can just put a quick extends on here to see if it extends a function or an object. And if it extends a function or an object, we now know it is one of those types. So what we want to do is we want to return just that exact same type as is. We don't want to change it. So we'll see t of k. Otherwise, actually, we want to replace those with never, sorry. And otherwise, we want to keep the type as is without changing it if it is a non-function or object type. So now when we click submit, you can see that that works. Now this is kind of the final evolution of all of our conditional typing, and luckily it's actually not anything new. What we're essentially doing is we're taking our key in t of right here, and we're checking to see, hey, is this thing a string? If so, normally we would return just whatever the type of that variable was, but instead we're returning the key itself. So we're returning like name or age or whatever. So in this result case, you can see here we get name, name, age, never, and branch, branch. Essentially anything that was a string or string-like type returns the name of that key, otherwise it returns never. Then what we can do is we can just get the key of those different things, and now we essentially have a union that we can use. And that's what this little bit of code down here is doing. We're calling that string keys function, which returns to us this object right here. And now we're getting all the keys of that object, which is name, age, and branch, and we're just returning them. So it's going to give us a union of name or branch combined together, and it ignores anything that's a never because never doesn't really exist. And as you can see down here, we get name or branch being returned. This is something that is not super useful. Like you'll definitely use it if you're writing library code, but if you're writing application code, you'll probably never ever have to touch this stuff. So let's go ahead and actually create this numbered keys or number keys right here. So we'll say export type number keys, and it should iterate over the keys of t, filter to only the keys whose values are numbers, and evaluate to a union of those keys. So essentially the exact same thing that we did up here. So let's just go ahead and write that out. So what we want to do is we want to check to see, is this a number? So if this extends number, then what we want to do is we want to get the key. Otherwise, we're going to return never. So we've done step one. And of course, I need to make sure I do this inside of an object and loop over each one of these keys. So I'll say key in key of t, just like that. So now essentially our numbered keys here is going to be an array, or not an array, an object that has the name is set to the actual key. So key and value are just the name of the things that are numbers. Now what we want to do is we want to take that and we want to convert that one step further to actually just give us a union of those keys. So I believe the easiest way for us to do this is at the very end of this object, we can just say key of t, and that should hopefully solve that for us. And if we click submit, you can see that it did successfully solve that problem. Now you may be a little bit confused by this key of t. Essentially, we're just passing it in a union of values, and it's going to return to us all the things that match that union of values. So this is just giving us all the values from something. I'll make this a little bit simple by creating a brand new type. This is going to be, come here, type, call it A, and that's just going to be an array 1, 2, 3. Actually, let's make it strings, a little bit easier. String, string, and string, just like that. We'll call this one like A's and C's. There we go. We're going to use as const for this because it'll make it a little bit easier. So now we have an array just like this. Now what I want to do with this specific type is I want to take this type and I want to get just the values as an actual union. So I can say type u is going to be equal to here. I can take my A and I want to get the number properties directly from it like this. Now if I hover over my type of A, make sure I put in any different semicolons that I need. Now if I hover over U, you can see it gives me a union, which is C, A, and D, my different types from this particular section here. And by using number here, I'm not passing in a union of values, instead I'm passing in number. And arrays are number based, so it's going to essentially get every single value in my array at all those different numbers. This is exactly the same with how it works with objects. So if we had an object, for example, with a name of Kyle, which is going to be a string here, we'll just say, and we'll say an age, which is a number, just like that. Now what we're essentially saying with this particular code, and actually going back a second, I don't need as const on here. That doesn't make sense. This is not a type. This is just, there's not a value in JavaScript. It's just a type. So back to what I had before, we'll say that this is going to be a name of a string and an age, which is a number. Now if I try to come in here, I could say key of A, and what it's going to do is it's going to loop through all the different keys of A, which is name and age. It's going to get the value for those and turn them into a union. So we get string or number, because those are the two values inside of here. So that's kind of how that section of our code was working when we were writing it out. If we go back to that code in just a second, you can see that's what that part is doing. So now we're going to get to the part where we actually work with TypeScript in our local development environment, which is the most important step of all, so we can actually use TypeScript in our own code. So what we can do to do this is we can install TypeScript globally. And the reason that they ask you to install it globally is to help make these tests actually run properly. So I'm going to make sure that we actually install them globally. So I'm going to come in here and I'm going to bring over my terminal and I can just run that npm install-g command to install TypeScript globally. So now we have that done. Next, we can come in here and we can run tsc-v, and that should return to us a value if TypeScript is actually installed. So let's just come in here, tsc-v, and you can see that returns version 5.83, so we know TypeScript is installed on our system globally. So now once we have that done, we can actually go ahead and run the test. So we can just copy the commands over into our terminal. So I'm just going to go straight with the submit command. We're going to paste that in. So now we just need to go ahead and actually run the commands from the CLI. So we can just copy the submit command to get that working. We can paste this into our code, and we should hopefully see it's running and everything is tested properly. Now, normally if I was using TypeScript inside of my own code, I would use npx to run my command. So I'd say npx TypeScript like this, and that allows me to not actually install a global version of TypeScript, but specifically for the testing purposes, I'm going to be using this testing like this, just because that's what we need to do to be able to test our actual code. So now we at least have this all working, so we can move on to the next lesson. Now the way you can configure TypeScript is through a tsconfig.json file, and it allows you to fine tune exactly how TypeScript works. You can make it super strict or you can make it super relaxed. Generally, I lean more towards a stricter way of using TypeScript, but it allows you to really fine tune what you want to do inside of TypeScript. For example, a very simple TypeScript config just tells us, hey, what do we want to compile down to? Because TypeScript takes your TypeScript code and compiles it down to JavaScript, you can use features that are not available in all versions of JavaScript, and then compile your code down to versions that are older JavaScript to make new features work inside of old JavaScript. So we take a look here, lib essentially defines what code do we have access to inside of our actual TypeScript. So what version of JavaScript do we want to use when we write our code? And target specifies what version of JavaScript do we want to target when we actually compile our code. So let's go ahead and take a look at an assignment. We want to create a new node project. So we're going to npm init-y. We're going to add a tsconfig file with the esnix target for lib and target. And then we're going to create a simple index.ts file with the following code. So I'm just going to copy over this code and we're going to get started on that by using that npm init-y. That's going to create a boilerplate for us. We also want to have that tsconfig .json. And now we can just go ahead and actually copy the exact code that they had up here so I don't have to type it all out again. And I might as well zoom this in a little bit because it's kind of small. There we go. It's a little bit easier to see. And we want to paste in what that code is. So you can see our compiler options is going to target and lib for both esnext. So now we have our tsconfig done. We can come down here. We have our node project done. We can create this index.ts file next. So let's come in here, index.ts, paste in that code. It's just really simple code that is essentially just doing a hello world project for us. And now we can see what's going on. We can run the tsc command to make sure it actually compiles and see how that's working. So let's just come in here. We can say that we want to npx tsc, and in our case, we could just run tsc since we have it installed globally, and we want to just run that command. And if we give it a quick second, you'll see that it compiles down to an index.js file, and it took all of our type-related information, removed it, and just gave us a JavaScript version of our file. And you can see the difference between these two is pretty minimal. They're almost exactly the same file because we have very little type information. Now we just need to test the project to make sure everything's working fine. So let's come over here. We're going to copy over this submit, and we're going to paste that down to see if that works. Actually, that's the run command right there. It looks like everything is testing properly. And if we come over here, you can see everything works properly inside of our test. Now here's a quick overview of some of the most important TS configs. The lib section here where we can add DOM and DOM iterable, this allows us to actually use different libraries for like the browser API. So if we're creating a browser-based app, we can add DOM and DOM iterable to make sure that we have not just Node APIs, but also DOM-related APIs. Strict is by far the most important attribute in the entire config. Setting this to true gives us strict type checking. It essentially takes a bunch of options in TypeScript and turns them to a stricter version. And I would say if you're writing in TypeScript, strict 2 should always be set unless you're migrating like a really old JavaScript project to TypeScript. Maybe then it doesn't make sense because you're going to have so many errors immediately. But strict, if you're working on a new project, should automatically be set, because if you don't have it set, you're pretty much not writing TypeScript. It's just JavaScript with a few extra types. Skip lib check is another one you should pretty much always have true. It just skips checking all the code in your node modules because obviously you don't care about the node modules code, so we want to skip that to speed up our development. For beta module syntax, if we set that to true, it simplifies our import syntax because it forces us to actually use import type for all of our different imports instead of being able to do a lot of other things. So we can set that to true if we want. ES module or interop allows you to essentially use common JS modules, which is the old way of writing code, with the new way of writing code inside of ES6 with like the import syntax. I'd recommend setting that to true as well. Module detection, we want to set that to force to essentially force our project to always assume everything is going to be a module, because that's how modern TypeScript and JavaScript is written. And this one is, a lot of projects leave this one off, but I recommend setting this to true. No unchecked indexed access. Essentially, if I try to access the value of an array, I don't know if that value exists or not. In TypeScript, it's always going to return the type of the array. So if I have an array of strings and I try to access the 57th element, it'll return the type as string. But by setting this to true, it returns the type as string or undefined. This adds a little bit of extra boilerplate in your code, but can help you fix some runtime errors where you actually don't have an element in your array when you try to access it. So what we need to do is essentially add all these different configurations, compile our code, change our code, and then fix the code. So I've gone ahead and I've already added all of our different compiler options that they recommended that we already talked about. So you can see that they're all in here, with the most important being that strict of true. And now immediately we're getting some errors. You can see here, I need to actually specify a type for my name, because if without strict true, it doesn't make me actually type anything. So I know that this is going to be a string, so at least see that is working properly. So we can give that a quick save. Let's read the rest of this. You can see we can try to power code, it'll fail, but we already fixed that. Change the main function to console log the message returned by welcome, and then we can fix the code to pass the strictness test and ensure it compiles. So here we're just going to console log whatever welcome returns. There we go. That'll just help with them being able to check to make sure our code works properly. And now hopefully if we give that a save, our test should run properly. So let's go over to the submit, let's copy that, and we're going to paste that into our terminal. And we should hopefully see that everything runs and all of our tests are passing. And now over here we can move on to the next lesson. Now, if you remember when we talked about interfaces, I specifically mentioned the one case that they're really useful is when you're overriding things in global files, and the main place you're going to be doing that is with declaration files. Declaration files are interesting because they have this .d extension at the start, so it's .d, .ts, and these are files that are specifically just defining definitions for your types. They have no actual JavaScript or TypeScript code in them other than type-related information, and they're essentially globally available inside your application. Now, the place that this is really useful is if you're trying to override specific things. So on the window interface, this is the built-in window object in the browser, oftentimes different libraries you install may add different things to this window property. So what you can do is you can say, you know what, this Google property has all these different properties of Google. Down here, you can see there's a bunch of them inside of here. So we're just saying that we're declaring this global variable. We're saying that there's an interface inside of it called window. This is what the normal window interface looks like. And we're just extending that window interface by adding our own Google property to this. This is a very common pattern you're going to see inside of code bases, especially older code bases that are using libraries that have these types of things where they directly modify the window object. And if we scroll all the way down here for our assignment, that's essentially what we're trying to implement. We're working on a JavaScript project that we're converting over to TypeScript, and this is showing how a lot of older projects use that window object very heavily. So let's go ahead, we're going to create an index.html, which contains all of this code. So we're going to say index.html, paste in all of the different code directly from there. Next thing that we need to do is we want to add a file called legacy.js. This is specifically a JavaScript file, not a TypeScript file. So we're going to say legacy.js and paste in all of that code. And in our HTML file, this is being imported. And then our index.js is the next thing being imported. So inside that index TypeScript file, we're going to replace it with some really simple code. We're just going to come in here, paste that down, and you can see this is accessing that Windows support AI, which we're defining inside of our legacy.js. But the problem is that TypeScript doesn't know that this thing exists yet, because according to it, the window object only contains the normal window properties. So we need to modify that using that .d.ts. So we can create a global.d.ts file that adds the correct type support for this. So let's go ahead, create a brand new file with that specific name, and we essentially want to match the format that we had all the way at the top here. So I'm going to copy that. I'm going to paste that directly into here, and we want to change this to be our interface. That interface should essentially match what's inside of here. It should have a version, and it should have this function. So let's come in here. We're going to say, what was that called again? It was the support AI, API, I believe. So interface window, we want to take the support AI function. This should have a version, which is a string. And then let's look at that function name. It is called enable auto reply. There we go. And this is going to be a function. And I think it just returns void. There we go. Let me make sure that's correct. Yep, it just doesn't return anything at all. So now we've essentially extended this particular thing. You'll notice our TypeScript errors still aren't fixed. Oftentimes to make this work, you just need to export an empty object, and that'll actually fix everything. So that just tells TypeScript, hey, take a look at this file, it exists. And now you can see that fixed our errors, and we have this support AI with these different properties inside of it. Now we need to run our code through the compiler, because right now, this is our old index.js file, which is what we're importing into here, because the browser only understands JavaScript code. So we need to rerun our compiler. So we can say npm, or actually we can just say tsc, and that's going to run our compiler for us. So now if we look at that index file, you can see it's been updated with our brand new version of our code that we just created. And now that can be used in our index HTML. So we can open that up. I generally use live server, but you can use whatever you want. This is just an extension in VS Code that'll open it up with live server. We can see it directly inside of our browser. So if I just pull this over, you can see here support AI dev tool. If I click enable auto reply, it just says auto reply enabled. So at least we know our code is working like we expect. And hopefully if we come over here and we actually submit our test, I believe that's the last step of our assignment. Yeah, it looks like that's the last step. We can just come in here and try to submit this, and hopefully everything works fine. Give it a quick second to run. Looks like all of our tests passed, and of course everything over here is fine. Now, one of the biggest issues you run into, it used to be a bigger problem, not as much anymore, but you install a library and it doesn't have any type information at all. Luckily, most modern libraries that are popular will have type information, but a lot of libraries are written in JavaScript and just haven't been updated to TypeScript. So you can't actually use any of the benefits, because in TypeScript, it just types everything as any if it doesn't know what to do, because essentially you're just using plain JavaScript code. Now, the nice thing is you can create your very own type definitions by using those definition files, or something that is more likely to happen, especially if it's a popular library, is someone else has already created the types for you using this definitely typed project. And to install types like that, all you need to do is npm I, and you just say @types/ whatever the library name is. So you just say library name, and if those types exist, it'll install those types into your project. If they don't, then obviously you'll need to write them yourselves. Now, since this is a course trying to teach us how this works, we're going to write our types ourselves. So to do that, all you would do is you would declare a module, and the name right here is the name of your library. So if our library name is Pregnant Goku, we would write that out as the name right there, but that's just whatever the name of the library is. And then you create essentially an export for all the different things that that library can export from it, and all the types associated with those things. So it has a couple functions and properties. You would just export everything from here so you can use them in your project. Now, in our case, if you have a file that's just in your project that's written in JavaScript, for example, you're working on a legacy code base and you have some code that's in JavaScript that's part of a different library that you have internally, you can just export the types directly without having to declare them inside of a namespace module like this. The only time you need to declare a module like this is specifically when you're trying to declare the types of a third-party library that you're installing through something like npm. So now if we go to our assignment, we want to create this file called chats.js. This is a JavaScript file that we're going to be converting and creating our very own types for without actually touching the code inside this file. So let's go ahead. We're going to create a brand new file, chats.js, paste in the code inside of here. As you can see, there's no type information in here at all. And what we need to do is we need to update our index.ts to include that information. So we're just going to take this brand new code and use it. So it's just calling log with that chats. So index.ts at the very top, we're going to import that information. And then at the bottom, we're going to log our chats just like that. Now we're going to get a bunch of information. Hey, there's no declaration file for this. Everything is typed as any because it doesn't know what anything is. So that's obviously a problem. So if we give these all a quick save, you'll notice everything inside of here is just an any type. It doesn't know what to do with any of these things. So now let's go back to our code. And at this point, what we need to do is create chats.d.ts. You can call it whatever you want. We're just going to call it chats.d.ts. And inside of here, we want to essentially declare what we're going to use for all these different modules. So let's go ahead and create that file and export that module that we're going to be using. So we can come over here. We want to call this chats.d.ts. We'll paste in that declare module, and we need to declare all the different things that are going to be inside this module. So if we look at this, we have a log function and we have our chats right here. So we want to have a function called log. So we're going to say export function log. This log function, it looks like it takes in an array of chats. So we're going to have some chats, which are an array of chat objects. We'll just create that as our very own type if we want. And it looks like it doesn't return anything. So we're going to say that it returns void, just like that. So we at least have that function done. I'm going to export that type of chat as well. So if we take a look at what a chat is supposed to be, it's just a time and a message as a string. So that's relatively straightforward. We can say time is a string and a message is a string. There we go. And this also returns chats, which is just an array of those chats. So we can say it exports const chats, which is going to be an array here of chats. So we can say chat array just like that. We probably don't even need to export this type up here if we don't want to, because we're only using it inside of this particular file. So now that should at least clean up some of our code. But actually our types didn't quite update. And the reason for that is sometimes you need to restart your TypeScript server if you do some complicated stuff with redefining types. So inside of VS Code, you can just type in TypeScript, and you can see there's an option for restart TS server. If you run that, it'll restart your TypeScript server. So if you run into weird bugs where you expect your code to be working, but there are errors, restarting your TypeScript server will almost always fix them for you. Now, if we look at our actual code for what we need to do, the final step is just to compile everything, run it to make sure everything is working as we expect it to, and then we can go ahead and we can actually do all the solution stuff. So let's go ahead and do that. We're going to run tsc to compile all of our code. We're going to open this up using live server. I'm going to bring this over. We can see that this auto reply still works. And if we inspect the console, we should see some logs inside the console. And if we look inside of here, you can see we get those logs inside the console. So at least we know everything is working. And now I can just go ahead and I can run my command. So we can come in here with our submit command. We can paste that down and we can see that it looks like everything is passing, which is great. And now we can come back here and move on. Now here we're pretty much talking about how TypeScript is a language server, and essentially that just means that it's going to be running and compiling all your code in a server. And the interesting thing to note is that when you run TSC, that runs your code through the TypeScript compiler based on what version of TSC you're using. But when you're running TypeScript in your editor and it's showing you errors, that editor is actually using its own version of TypeScript. It may be trying to use the same version, or it may be using a different version. And if those versions are different, you could run into errors where your TypeScript compiler doesn't work, but your editor is actually showing no errors, or your editor is showing errors even though your TypeScript compiler is working just fine. So it's really important that you try to make sure they're the exact same version, which is why I generally don't recommend installing TypeScript globally, and instead I recommend installing TypeScript directly inside of your project. Now, if we scroll down here a ways, that's essentially what they're telling you to do. You can see here, we should install TypeScript as a development dependency, and that'll install TSC into our particular project. So it's using our project version, which we can use inside of VS Code. So they both use the same version. Also, funny enough, they have a note right here on restarting the TS server because it's a very common problem. If types aren't working like you expect, first thing you should do is restart the server and see if that fixes it. So let's go ahead and install TypeScript as a development dependency in our project, just like that. Now, if we go to our package.json, you can see we have TypeScript as that dev dependency, which just forces everyone using our project and the editors using our project to use this version of TypeScript. Now we can just run the command for submitting our event. We should hopefully see everything is passing. There we go. And if we come back over here, everything's passed. Now, sometimes in TypeScript, especially when you're converting from a JavaScript file to a TypeScript file, there may be certain pieces of code that don't work very well with TypeScript and throw errors, and you don't want to spend the time to actually fix those errors. So you can use the @TSIgnore line, and that'll essentially completely shut off TypeScript for the entire line below it. Or you can use @TSNoCheck, which turns off TypeScript for an entire file. This can be useful again when you're converting from a JavaScript project to a TypeScript project because you have lots of errors that you'll need to fix. So turning some of them off could be really useful. So what we're going to do is we're just going to play around with that by essentially deleting our global.dts file, trying to recompile, realizing there's an error, and then ignoring that error. So what we can do inside of our code, we have that global.d.ts file. Let's just completely delete that. Now we get an error right here, and we can just come in here with that check. So we can say @TSIgnore, and that's going to completely ignore this line. But I actually recommend doing something slightly different. Instead, I recommend using the TSExpectError. It does the exact same thing as ignore. If there is an error on the next line, it'll say, hey, there's an error, I'm going to completely ignore it. But if there's no error after this, it'll actually throw an error on itself. So for example, if I put that up here, you'll notice it says there's an error. Hey, I expected there to be an error after this particular line, but there is no error. That's essentially what this is trying to tell us. Now, if I use ignore, I won't get that handy message. So this is really useful when maybe something is broken because like a library you're using is broken and it needs to be updated. So you can just throw an expect error on here. And then when that library finally gets updated, you'll notice that this thing has been updated. So you then can remove this expect error because it'll essentially tell you, hey, there's no longer an error on this line. So I almost always use expect error over ignore, but they both pretty much do the same thing. Now with that done, everything should be working just fine. So we can run our command to actually submit this. Let's go ahead and see if that works. And of course it doesn't work because they specifically want us to use ignore, which is fine. So we're going to just change that over to ignore. We'll rerun that command and then it should hopefully succeed. And there we go. We can move on to the final lesson. Now in this lesson, we're talking all about Vite, which is probably the best bundler when it comes to creating TypeScript related code. And a bundler is essentially what the name implies. It takes all of your code, bundles it together and creates a usable version that you can put inside the browser. So it takes all your HTML, CSS, TypeScript code and spits out some HTML, CSS and JavaScript code that you can use in the browser. Now, Vite is probably the most popular and probably the best bundler out there. It's incredibly fast, super great, and really makes the workflow so much better. So we're going to get started with a Vite project, and to do that, we actually need to completely remove all of our code. Now, in this documentation, it recommends installing Vite as a development dependency. We don't even need to worry about doing any of that. What we can do inside of our code is we can just come in here, delete absolutely everything inside of here, and then we can run the command npm create Vite at latest. What this is going to do is it's going to get the latest version of Vite from npm, and it's going to create a brand new application for us using Vite. So I'm going to make this a little bit larger because it actually has a lot of options you can use. And of course, we need to say we want to install this. So we're going to install the brand new version. When it comes to saying a project name, you can just put period and it'll install in the current folder, or you can specify a project name. And then we can just select our framework. Now in our case, we're just going to be using vanilla JavaScript and TypeScript. So we'll choose vanilla and we're going to choose TypeScript as our option because we're creating a TypeScript project. Once we've done that, you can see it creates a bunch of files over here. We're going to create npm i just to install all of our dependencies. And then we're going to run the development server by calling npm run dev. So if we look at our package JSON real quick, we'll minimize this down. You'll see in our dev dependencies, we have TypeScript just like we did before, but we also have Vite, which is the actual project we're going to be using to create everything in our application. It does all the bundling and stuff for us. And you can see it has a dev command that runs Vite. It has a build command which runs TSC for us, and it even has a preview command which runs whatever we build inside of here. For the most part, dev is really what you care about. Now inside of our source, you can see it generates a bunch of different code for us. We have like this main file, this counter file, and so on. And it looks like it possibly is still installing things. Let me take a look at the terminal to see if we can open our application. Yeah, it's still installing stuff. So I'll come back once all that's done. There we go. That finished installing everything for us. And the really nice thing about bundlers, especially a bundler like Vite, is it's going to be very fast. I mean, it took 82 milliseconds for me to start that up. And now if I open this up on localhost, you can see that I get a brand new project. I can increment my count because that's what the code inside my project is doing. And the really great thing is as soon as I change any of the code inside my project, for example, in this counter, if I change it so it increments my count by even more, so we'll come in here and make it increment my count by 10, you'll now see I just saved my file. I didn't have to run any build command or do anything like that. And automatically inside of here, now it has updated my code to increment my count by 10. This is the real power of bundlers, and pretty much anyone that works with a project that is a real project is going to be using a bundler like Vite to make creating everything super easy because I don't need to run the TSC command. All that stuff happens behind the scenes for me, and when I save my code, it automatically updates in the browser for me, which I absolutely love. Now let's go into our instructions and see exactly what we need to do. You can see we've installed Vite, which we kind of did our own way. We delete all of our code. Yeah, there we go. We created a new Vite project using our own method of doing that. We installed our dependencies, we ran the dev server, and we noticed that when we clicked on things, it automatically updated. We changed the counter to 10, which is what it told us to do inside of here. So we've pretty much actually completed all the steps inside of here. And now let's try to run this to see if this actually works as we expect. So let me just bring that code over. Let's make sure we close down our terminal. There we go. We're going to paste in that command and we should hopefully see everything passes, which it does. And now if we go over here, we've completed the entire course. Now, one thing that I do want to say about Vite, we'll just bring this back, is that Vite is what I use for all my projects pretty much. I mean, if I'm making a React project, Vite is the way to go. A TypeScript project, Vite is the way to go. I absolutely love Vite because of how easy it makes everything. Because like I said, it was really a pain having to run that TSC command, create your own TypeScript config, configure everything on your own. Vite just handles all that out of the box for you. It is really easy to configure, and we even have our own TS config we can change, but it has a lot of really nice defaults that we like to have. So with that, I really hope that you enjoyed this course and that you're able to learn a little bit about about TypeScript. Like I said, we covered a lot of stuff from the absolute beginner stuff all the way to some really, really advanced TypeScript stuff. So if you get confused when you're working on TypeScript in your projects, feel free to come back to this video and check out the specific sections you get stuck on of generics or and so on. Wherever you get stuck, come back, rewatch that section, and hopefully with your newfound knowledge and your trial and error, it'll help you even further understand those different sections.
I really hope you liked that course. We actually have a ton of other courses over on boot.dev that you should check out as well. Things like Python, Golang, JavaScript. In fact, we have an entire backend learning path in TypeScript that you should check out. It has courses like SQL, Docker, AWS, file servers and CDNs, a lot of cool stuff in there. You'll actually learn how to build a REST API in TypeScript, so lots of cool stuff that you can do with this language, so go check that out as well. Again, it is free to create an account on boot.dev, but if you do want to become a paying member so you can take advantage of all the interactivity on the platform, use code WebDevSimplified for 25% off your next year on an annual plan. That goes to helping us make more of these courses, but it also goes to helping WebDev Simplified. He gets a cut of that when you use his promo code. So go ahead and do that. Hope you enjoy. See you in the next one.